Hey, what's up everyone? So in this course, I'll help you to get started with creating complete applications with CRUD operations and authentication using the MERN Stack. It's also worth mentioning that this video is a compilation of my MERN Stack series here on YouTube, and I thought that some of you would like it as a single video, but I have also divided it into different sections so that you can easily jump into a specific section if you want. In case you're new here, my name is Charles and I create content around web development. If you like the content in this course, please remember to leave a thumbs up and also support my channel by subscribing. So in the next episode, let's take a look at the demo of the application that we will be creating in this entire course. Hey, what's up guys? Welcome to this video which marks the beginning of a new series where we will be creating a complete to-do app with authentication using the MERN stack. So on the front end, we'll be making use of React and Redux, and then on the back end, we'll be using Node.js, Express and MongoDB. We will host our front end on Netlify, and you can actually access a demo of this application on this link, which I'll also leave at the description section below. And then our backend, we will host it on Heroku. So right here is where our backend is hosted, and this is the link of accessing our backend. But all our endpoints, our API endpoints, will be protected with authentication, so you cannot access the to-dos or perform other operations if you are not logged in. Okay, and I'll show you how we can do that. So on our front end here, we have a form for signing in a user, and we'll also be performing data validation, and this we will be doing it on the backend. So if I try to log in as an invalid user, we will see that we will get an error. So we don't have any value, and I have clicked signed in. We get this error here: email is not allowed to be empty. So we'll be performing some data validation, and we'll be doing this on the backend and sending some response to the user, okay, on the front end or to the client. Okay, so right now let me try to log in as a valid user. So I'll use an email which is already registered, so chaoo@gmail.com, and then I'll enter a valid password. But before I log in, I have a tab opened here. I just pressed F12 and then visited the application tab, and what I want you to pay close attention to is our local storage. So we are on this domain, and I want you to pay attention to the key and value. We will be using JSON web tokens to authenticate the users. So we will be generating a new token every time we are logging in and verifying this token on the backend. So pay close attention to this section when I press sign in here, and here we go, sign in, and you see now we have a key token and the value is a string of characters here. So if I copy this string of characters and go to jwt.io website, you'll see that we can decode this token just at the bottom here. I will select all this one and delete, and then paste what we just copied from our local storage. Okay, and when I paste it here, you'll see that our token has three sections. The first section is the header, which contains the algorithm and the type of our token, and then we have the second section here, which represents a payload, and the payload may contain information about the currently logged in user, and also information about the token, when it was created and when it will expire. So right now you can see we have the ID, and this is the ID of the user. We have the name and the email, and these are the details about the user. We also have when the token was created, and then the last section is verification signature, which makes our token to be secure. Okay, so right now we are logged in as Chaoo, and we can be able to perform all the CRUD operations once we are logged in. So we can create a new resource right here. I can create a new to-do, and this will be added to the database, and then we can fetch that new to-do and display it to the user. And here it is. We can edit a to-do using this button here. I can add a 2h and then submit. You'll see that this to-do was actually edited. We can mark a to-do as done, and this will turn green and add a line crossing that to-do, and then we can also delete a to-do. And also we can display more information about this to-do, like when the to-do was created and who created that particular to do. Okay, so we'll see how we can do all this in this particular series. Now, as I told you, all our endpoints are secured. So if we don't have a valid token, if you are not authenticated, we cannot perform these CRUD operations. Okay, so for example, if I mess up with this token here and change the value, remove the one, if I try to create a new resource, we should get an error. So if I submit, you'll see that invalid auth token. So this token is submitted to the backend, and then a verification process happen, and this is now an invalid token, and we cannot accept that as a good request. So this is a bad request. So if I come to the console here, you'll see that we have a post request 400 bad request. Now this was not accepted as a valid request. We cannot delete, and also we cannot edit or perform any other CRUD operation, e.g. reading, even reading the data itself. So if I try to refresh this one, you'll see that we can't read that data. Okay, and then if we sign out, this token will be deleted from our local storage. So if I sign out here, you'll see that we'll be simply deleting that token, and we are redirected to sign in. And also we have a way of creating a new user using this form. Okay, so yeah, this is just an introduction of what we will be creating. And if you want to support my channel, you can do so by directly donating to my PayPal account. So if you click this link, it will take you directly to this donation page, and the purpose of your donation is to help me to continue creating free content, because as you know right now, I am not even monetized by YouTube. So you can directly donate to my PayPal account, and that will be a huge support. And if you are not capable of donating, you can just watch some of my previous videos right here, and this will increase my watch time. And by increasing my watch time, I'll be able to beat this requirement for me to be monetized by YouTube. Okay, so go there and watch some of my previous videos, relevant ones. I'm not telling you to watch all of them, just go check them out and watch the relevant videos, and that will be a huge support to me. So that's it for this video, and I'll see you next, guys. In this episode, I want us to start by creating an Express server, and to do that, you will need a code editor. My preferred code editor is Visual Studio Code. You can download the same if you want to have the same experience as me. And then the next thing that you will need is Node.js. So visit nodejs.org and download the recommended version here. So this version is more stable than the current version. So I recommend you download the recommended version for most users here. So once you download and install Node.js, now you can go to your desktop and create a new folder, and I will call this folder MERN. And then inside this folder, I'll create two new other folders. The first one, I'll call it Frontend, and in this folder is where we'll be working on our React app. The second folder will be Backend, and this is where we'll be working on our Node.js app backend. So right now, we will start by working on our backend, and then later on we'll move on to the front end. So I'll click the backend here and visit this path by pressing CMD. This should open that path on the command prompt, and here we are. The first thing that you may want to do is to make sure that Node.js is installed in your machine. So run this command node-v, and this should give you the version of Node that you are running in your machine. If you don't see the version that you are running, maybe you get an error, you'll know that Node.js is not installed in your machine and you may need to try and reinstall it. Okay, the next thing is that I want to open this folder on Visual Studio Code. So there is a shorthand for that. Just run this command code and a period, and when I press enter, this folder should open on Visual Studio Code. So here we are. So we need to install a few dependencies for us to create our Express server. And let's come back to our command prompt here, and to do this we first need to generate a package.json file. So to generate this file, you need to run this command npm init, and then we apply a flag, a yes flag, enter, and a package.json file have been just generated for us. Okay, and with this we can now be able to install other dependencies that we will be needing in our application. So at the bottom here I will install two dependencies that we are going to use in this episode. So npm I, the first dependency is Express, and Express is a Node.js framework that makes creating of routes or endpoints much easier. Okay, and then the second dependency we will be needing is NodeMon, and NodeMon will allow us to automatically run our server whenever we make a change in our files. Okay, so I'll press enter, and this should install Express and NodeMon in our application. So NodeMon have been installed, and I am using version 2.0 and Express version 4.17. Okay, once this is done, I can minimize this and maximize my code editor here. And when you look at my package.json file here, you will see that at our dependencies we have Express and NodeMon, and these are just the dependencies that we just installed. Now we can go ahead and create a new file at our backend folder, and this will be the root of our application. I'll call this file index.js. So right here I can say index.js, enter, and now in this index.js file we can try to create our first Express application. Okay, the first thing that we need to do is to require Express and store it in a constant. So I'll say const Express to be equal to require, in brackets here, Express. And then to create an Express application, all we need to do is to invoke this Express as a function. So right here I can say const app will be equal to Express and invoke this as a function, and now this app will represent our Express application. Okay, and with this we can actually create our first route, and you can do this app.get. So this is a get request. So with app.get you can fetch something from this route, and you can use other CRUD operations with app. So we can have app.get, app.put, app.delete. So this app have a lot of useful methods that we will be using in this application. Okay, so let's create our first route here, app.get, and then the first parameter for this one is the route or the endpoint that you want this one to be. So I can press this to be just the home, and then the second parameter can be a callback function, and in this callback function I can pass two parameters, that is request, and this is what we are getting from the client to our server here, and also we have a response, and a response is what we are giving back to the client. Okay, and with this we can do something in here. Okay, so this is just an arrow function, and we can do something in here, and what I want us to do is to send back something to the client using our response. So we can say res.send, and in here we can just have a welcome message, welcome to our to-dos API. Okay, so this is it, and this should be an arrow function, and this is how we simply create an endpoint. So in future, when we work with MongoDB, we will be able to get data from our database and send that data to the front end, and then we need to listen to a port. So right here I can say app.listen, and then the first parameter is usually a port, so we can listen on port 5000. So right here I can say 5000, and then the second parameter, optionally you can log something to the console. So right here I can say console.log server. We can have a message here, server running on port 5000, just like that. So later on we will be replacing this port with an environment variable. Okay, and we'll see how we can do that, but for now let's see if this implementation works. So I'll come to cmd and run this command node, and then the name of the file index.js, and this should run our server. So enter, and now you can see server running on port 5000, and this is the exact message that we placed here. So now when we visit localhost 5000, we should get this message, welcome to our to-dos API. So I'll come back to the browser here, open a new tab, and visit localhost 5000, enter, and there we go, welcome to our to-dos API. So earlier we installed NodeMon, and NodeMon will allow us, every time we make a change, it will automatically restart our server. So if I come to my code editor and make a change here, okay, I have included 3 dots at the end. So for us to see these changes on the front end, what we will need to do is to stop the server and run node index.js again, and we don't want that. That is a very bad developer experience for us. So what we can do is to stop the server and run this using NodeMon. So NodeMon will automatically detect our index.js file and run it by default, and it will restart the server every time we make a change on our files. Enter. So now you can see server running on port 5000. If I come back to my browser and refresh, we should see these changes. But now let me change something. Let me maybe delete it again. So you'll see that our server will restart. So when I come back here and just refresh, we should see that the changes were applied. So yeah, congratulations, you have just created your first Express application. So next we will start working with MongoDB. So in this episode, I want us to connect our Express application to MongoDB Atlas. And to do that, we will be needing two more packages, that is Mongoose and .env package. And to install these packages, I have just opened my Visual Studio Code terminal. You can do the same. When you look at the very top, you will see terminal. When you click it, you will see new terminal. When you click new terminal, that should open this terminal right here. So let's install those two packages by this command npm I mongoose, and it have a double O here and then the .env. Mongoose will enable us to connect to MongoDB, and later on we'll be using it to create schemas and models, and then the .env package will allow us to read environment variables from a file called .env. So I have already installed Mongoose and the .env package. So if I come to my package.json file, you can see that I have Mongoose installed here, version 5.11 and .env version 8.2. So for you, just run this command and it should install Mongoose and .env. As those two packages installs, you can go to your browser and visit mongodb.com. If you don't have an account with MongoDB, you can simply create one for free. You will see a button saying try free next to the sign in button. And once you create the account, you will land a page just like this one. And the first thing that you need to do is to create a cluster. So right here, you will click build a cluster. Just create a free cluster right here, and then you are taken to a page like this one where you can select a cloud provider. We have AWS, Google Cloud, and Azure. In this case, I'll just go with the defaults. Okay, you can also change the region if you want, but I'll go with the default. So I'll just come at the very bottom and create a cluster. Now this will take 1 to 3 minutes to complete, so be patient and wait your cluster to be created. When this completes, all you need to do is to click on connect. So the first thing is to add an IP address to be whitelisted by MongoDB Atlas, and I won't be adding my current IP address because sometimes it changes, so I'll allow access from anywhere. And add IP address, and then we need to create a database user. Okay, so right here I will enter a username and a password. So I'll enter a password test 987. This is just an example password. You should create a more strong password than this one, and then I will create the database user. Once this is done, we can now go to the next step. Choose a connection method, and I'll go with the second option here, connect your application. And in this last step, we will get a connection string. Okay, so I will copy this string the way it is. I can just click this copy here to copy the string, and we will be needing our database user password and also the database name. Okay, so I'll cross this one. Once we copy the string, we are deploying your changes, so this will also take some time to complete, and I'll leave it at it as we go back to our code editor. By now, your Mongoose and .env packages should be installed. So at the moment, I'll just close the panel, and I want us to store our connection string on an environment variable. So to use the environment variable, we need to configure the .env dependency or package. So right here, we will require .env and then right here we will tap a .config method and invoke it, and this should configure our .env dependency. Okay, and we can now be able to read environment variables from a .env file. Let's create a .env file. So I'll come at the root of our application, click add, and then .env. The reason we use a .env file is because it makes our application to be more secure. So for example, when we use this connection string right here, this code won't be pushed to GitHub. This file won't be pushed to GitHub, and it is not accessible from the public. It will be available on the server, but not on the public code like on GitHub, and that makes our application to be more secure. So right here, I will create a variable connection underscore string, and it is a convention to use caps, and then right here I'll paste the string that we copied from MongoDB, and we enter the password for the database user here, test 987, and then we enter the database name. So right here I'll say to do app. I'm using camel casing to do app and then the password. So now this is our connection string, which is stored on an environment variable called connection underscore string. So how can we read this string from this file? So in our index.js file, I'll come here and create a constant, and I'll call it connection underscore string. Spell this one correctly. Will be equal to, we have a global object called process, and this global object have a property called env, standing for environment variable. So with this global object, we can read environment variables from our .env file. So the next thing, we will tap a connection string, which is now our environment variable from this file. I'll just copy this, copy, go back to index.js file and paste it here. So now our connection string is available on this constant, okay, on this constant. And now the next thing, we need to require Mongoose. So at the very top, I'll say const Mongoose will be equal to require in brackets Mongoose, and now we can use this Mongoose to connect to our database. So at the very bottom, I will say Mongoose dot connect, and the first parameter here is our connection string. So I can get that from connection string, this one, which is reading our connection string from the environment variable, and then this will take some time to process. So we can tap a .then method, and with this .then method we can log something to the console. So an arrow function, and I'll say console.log, and we can say the connection was successful. So MongoDB connection established. Okay, and I can take this to the next line, and if the connection fails, we can catch that error. So right here, dot catch, an arrow function, we get an error, and then we can console dot error, and then we enter a message, MongoDB connection failed, and then we can add an error at the very end, error dot message. Now with this we will get some duplication warnings. So the first parameter here is usually the connection string, and then we have the second parameter, which is options, and with these options we can avoid those duplication errors. Okay, so right here just use these options. So use new URL parser and set this one to true, comma, and the second one here is use create index, set it to true, comma, and the last one is use unified topology, and you can set this one to true. So now with this we won't get any duplication errors, and this is how we connect to MongoDB database. So right here we have Mongoose. The first parameter is our connection string, which we are getting from a .env file, and then we pass an object here with several options. If this is successful, if the connection here is successful, we tap a .then method and log this message to the console. If it fails, we tap a .catch method and display the error on the console. So by now this one should work if this one completed, and it seems that it's still completing, and yeah, now it's complete. Now let's test this one. Okay, so we can go to the server and we should see MongoDB connection established. So I'll open command prompt, and I had stopped the server, so I'll just run nodemon, enter. So we have gotten the first message, server running on port 5000 and MongoDB connection established. So perfect, our connection worked. And to test this one out, we can enter an incorrect password, maybe omit the 7, and come back and see if this should work. So the .env file is not detected by nodemon. So you can see how secure our application is. So I can come back here and maybe change something, remove this one, and then add it again. So that should restart our server. Let's see if we will get an error. Server running on port 5000, MongoDB connection failed, bad auth, authentication failed. So you can see if we enter an incorrect password, the connection is failing, meaning that this is working perfect. Now one last thing. Now that you have learned about environment variables, I want us to change this port to use an environment variable, and this is because when we deploy our application to the cloud, this port is not may not be available. Like, we are not assured port 5000 will be available on that server that we will deploy our application. Now for this reason, an environment variable is usually used. So right here we will set another const and set it to port, and then we will use our process object and then .env, and the environment variable for the port is port. So this should read a port from the environment variable called port, and it will be dynamically assigned to us once we deploy this application to the cloud. But because we are working locally, we can optionally define this environment variable here. So right here we can just say use this one or this one. So if this is not available, this one will be used. So right now we can replace this one with port, and this should read either from an environment variable. If this is not a variable, this port will be used. Okay, so let's see if our server is still running, and as you can see, it's still running correctly. Now to test if this is working, we can set a port on our .env file here. So we should go to the next line. I'll scroll to the end here and press enter. I set an environment variable called port and set it to 3000. So I'll come back to my index.js file and mess up with something, maybe include 3 dots, and this should restart the server. Come back and our server should run on port 3000 and not 5000. But as the look of things, this is not working. So the issue is our message. So whatever port it connects to, we are still getting this message. So we should dynamically display this message depending on our port. So instead of using these quotes, I'll be using backticks right here. I use a backtick, and with this we can use a variable right here. Okay, I will use a dollar sign and then brackets here and pass in our port variable. So now we should correctly see that it is running on port 3000. So back here, server running on port 3000. Perfect. So you can see that our port is coming from an environment variable, but in this application locally we don't want to define the port, so I'll simply remove this. It was for a testing purpose, and now we should see that our server is running on port 5000. So right here, server should restart. Maybe I can change something, remove one here, and let's see. Server running on port 5000. So this is now cool. We have successfully connected our application to MongoDB, and also we are using a .env file to read our connection string, which is more secure. We have also worked on our port so that when we deploy our application, we will get the port from an environment variable which will be assigned to that particular server. And that's it for this video. I'll see you next. So in the last episode, we were able to connect our application to MongoDB Atlas, and in this episode, I want us to talk about Mongoose schemas and Mongoose models. Now to create our first model, we'll come to the root of the application and add a new folder called models. And we will start by creating a to-dos model. Inside this folder, I'll create a new file called todo.js. Now, to create a Mongoose model, we'll first have to define a Mongoose schema. And a schema basically defines the structure of our documents. So in MongoDB, instead of having tables and rows, we usually have collections and documents. So let's first create our to-do schema, and you'll see why we need a to-do schema and how it is useful. So the first thing we will do is to import the Mongoose module in this file. So right here, I'll say const mongoose will be equal to require in brackets mongoose. And with this, we'll now be able to create a Mongoose schema. Right here, I'll first define a constant to do schema, and this will be basically an object because we'll be creating it from a schema class which is attached to the Mongoose object. So right here we'll say new mongoose dot schema, and in here we will add an object, and this object have properties of our document. So if we want a to-do to have an author, this is where we will add that property and add its type. Okay, so right here we can add a name for our to-do, and you can set the name to be of type string. But because we will be needing to define different options for our name, what I'll do is that I remove this string and add an object. So right here we can have multiple options. The first one is type to be string, a comma, and you can make this to be required. So what you do is to just say required to be true, and this will act like a validation. So when you submit an empty form where we don't have a name, you'll get an error. Okay, and then right here we can set a minimum length. So we just say min length to be of 3, and also you can set a max length if you want. So I expect our to-dos to be short ones, so right here I can set a max length to be of 200 characters. So this is how we simply create a Mongoose schema. It's an object coming from this schema class, and we have properties. We can define properties for our schema. So this is a to-do schema. So when we submit a to-do from a form, it must have a name, and we can add as many properties as we want. So the other property that we want for our to-do is the author, and this can be of type string, and then we want to have a UID, which is the user ID, to be also of type string. We want to know whether a to-do is complete or not, so we can add is complete, and this is a boolean, so it should be either true or false. When you submit a string to this one, you will get an error. And then finally we want to have a date of when our to-do was created. So date, we can have multiple options here. The type will be date, and we can set a default value for our date. So default to be new date, and we invoke that function. So if we don't submit a date, it will automatically create a default date for us. So this is now our to-do schema, and you can see that it is simply defining the structure of our document, which we will be storing in MongoDB. Now the next step that I want us to take is to create a Mongoose model. Now what is a Mongoose model? A model helps us to directly interact with the database, and to create a Mongoose model we will need to use this schema. So right here I will create a new constant, and I'll call it to do. The reason that I am using a capital letter here is because this to do is a class, and by convention classes starts with a capital letter. And then right here we'll set it to be equal to mongoose dot model, and then inside here is the name of our collection in singular form. So we want the name of our collection to be to-dos, so right here I'll set the name to be to-do. And then the second parameter for this one is our to-do schema. So now the only thing that remains for us to do is to export this to-do model. So right here I can say export dot to-do to be equal to do, and by exporting this to do, we can be able to use it on any other file where we will import it, and we will be using it on our to-dos route. So in the next video, we will see how we will use this to-do model to create documents to MongoDB. So in the last video, we were able to create our to-dos model, and I promised that we will be performing a put request where we are creating a document and saving it to the MongoDB database. But unfortunately, we'll be doing that next after this video, and this is because one of you asked me a question about exporting this module. So if I come to my browser here, go to my last video creating a Mongoose model and scroll to the comment section, you'll see that Vishant asked this question, and the question is, can we export our to-dos model this way? Export default to do. And how we did it is this way. Now in JavaScript, we have two ways of working with modules. A module is a way of helping us to separate logic. So we can define our Mongoose model in index.js. We can just find a place here and add all this code in here if we want, and add all our routes in index.js. But with time, this file will become too much crowded. Like it will have a lot of lines of codes, it will become hard to read the code, and so on and so forth. Now to simplify things, we have modules. We can create our own modules. We separate logic like the way we did here. We are separating the logic of creating a model, and then we can simply import all this logic with some few lines of codes to another file and use it there. And also you can see that we can use third-party modules or libraries. For example, Mongoose is now a third-party module in this file. We have Express, and this is now a third-party module. We didn't create this, it is available in npm, and if you want, you can also create your own module and upload it to npm, and maybe you can advertise it. So this way we can use modules that are already created by other individuals, and this makes our work very easy. So as I was saying, we have two ways of working with modules. The first way is using the common JS, and the common JS way is by using the require statement, where we require a module and store it in a constant, and now we can use this constant to perform other operations. And then how we export modules is by using a global object called module. So if I come to index.js file, and right here I can console.log module, and you'll see that this is a global object. So if you come to the console, and you'll see that module is a global object with a lot of properties, and the property that we are interested in is our exports property. So to export this to do, we can alternatively say here module dot exports dot to do, and we set this one to do. So what is happening? We are accessing our global object called module. We are accessing the exports property, and when you pay a close attention to it, you'll say this exports property is set to an empty object. So when we say dot to do, we are simply adding a new property to this exports object, and this to do property, we are setting it to be our model. So you can change the name of this if you want, but you can change the name of this. The name that you use here must be the same as this one. and it seems like I messed up something here, and there we go. So what we are doing, a recap, we are accessing modules, and then we access the exports property and add our own property called to do. So by this we are able to export our to do model, and these two lines basically do the same thing. Okay, so if I comment out this one, come to index.js and try to import our to-dos model, right here we can say const to do will be equal to require. We access this folder which is on the same path, so stroke models, and then we access our to do file. So we don't need to add .js when we are using require. Node.js will automatically add it for us. So now we can log this to do to the console. So right here I'll say to do. Let's come back and I'll scroll at the bottom. I'll try to restart the server by pressing space here, and you'll see that this is an object which is now our exports object, and inside this object we have a property called to do, and this to do is our model. So now to directly access our model, what we can do is to destructure this property. So right here you can wrap this one inside the curly brackets, and this will directly get our model this way. So now when I come back to the console, try to restart the server here, you'll see that now we are directly getting our to-dos model. And the way we exported this is by using this method exports.todo to do. Now let me comment out this one and let's use this one. I'll come back to the console and try to restart, and you can see that we are getting the same result. Now what if we want to have a default export? Because this is like a named export, because we have to destructure it from our exports object. So to have a default export, what we can do is to exclude this to do. Okay, so we have module.exports is equals to do, and this will directly give us our to-dos model when we import it here. And because we don't have this property, we are not destructuring it, so I remove this one, and now we should still get the same result. So right here I'll try to restart the server, and you see we are still getting the same result. But this won't work the same way now with our exports here. If we try to remove this property, this won't work for some reasons. So if I try to comment out this one, come back to the console and refresh, you'll see that we are getting an empty object. So don't use exports is equals to do at all. If you want to use exports only, you need to add the dot to do property. Okay, so now we have seen that we have three methods here. We can use this one, we can use, let me type them out, we can use module dot export dot to do is equals to do. So these two are basically the same, and this one is a bit different. So let me revisit this one so that in here we can do it this way. Okay, so yeah, now that is the first way of working with modules. So we can use the require statement, and then we can export our modules this way. Now the second way is using ES6 syntax, and with ES6 we use an import statement to import our modules. So to use ES6 to work with our modules, we need to come to package.json file, and below the main property here we can add type, and the type that we will be adding here is module. And now this line of code will allow us to use the import statement to work with modules. So when I come back to my todo.js here, we can now omit our require statement here. I'll comment it out, and then we can use import mongoose from mongoose. And now this is how we can use the import statement to import modules in this file. Okay, so now how can we export our module using the ES6 syntax? What I'll do, I'll just comment out this, and then below here we can now use this line of code, export default to do. Now when I come here and paste this one here, I have just pasted it the way it is. Now we can come to index.js, and we need to get rid of all the require statements. First of all, this is not importing, so I'll take this line of code below our imports that way, and then I will comment all these ones, move at the top, and you'll see that I have already imported them using the import statement, and uncomment this. Okay, so what do we have here? We have import express from express, import mongoose from mongoose, and then import.env from .env, and now we are importing our to-do. Now when using the import statement, we must include this .js. When we omit this, it will throw an error, unlike when using require. Okay, I'll remove this one and remain with this one here. When we log this to the console, we should see that we are exporting our to-dos model. So here we are using require, so let's get rid of require. I'll come to index.js and get rid of require and see what we have. It's refreshing, and you can see that MongoDB connection failed because we are not configuring our .env file. So let me come back to my browser here and go to this other video where we were connecting MongoDB Atlas. So our friend who is Vishant also asked how to write import.env file using module method. So how can we use import statement to configure our .env file? So I'll come back to the code. This is how we are importing our .env file using the import statement. Now to configure this file so that we can read environment variables from the .env file, all we need to do is to use now this .env. So we can say .env.config, and we invoke config, and this will configure now our .env module so that we can read environment variables from a .env file. So now we should get our to-do to the console right here, and you'll see that we are getting model as to-do, and this is now a default export default to-do. How can we have a named export? So I can remove this one. Actually, I'll just comment it out so that you can see it. With this one, with ES6, we can use this syntax, export const to do, and this will now be a named export. So let's see if we are getting something to the console. We are getting an error, and the error we are getting is that this file, this module todo.js does not provide an export named default. So we don't have a default export in this module. It's a named export, and to import it, what we need to do is to destructure it. So right here we need to use curly brackets and then curly brackets. So when I come back to this and it refreshes, you'll see that we are still getting our model. So, and that's it. So just a recap, we have import for importing modules in ES6, and to configure ES6 imports, you need to come to package.json and add this property here. And we also have the require, which comes by default in our Node.js. And then finally, the way we can configure our .env file is to import our module and then configure it just like this. So in the rest of the videos, personally, I'll be using require, but if you find import more comfortable with you, you can use it. But the good thing with import is that it's the same syntax. This syntax is the same syntax that is used in React, but because it's experimental in Node.js, I won't depending on it. So I'll just get rid of all of this and I'll stick to my old school method. And we won't be using our to-dos model in this file. We'll be creating a to-dos route. So I'll just get rid of this also, and then we configure our .env, we invoke our application here, and then in our to-do file, I'll stick to the old school method, remove this one, and also I'll stick to my export here. Okay, so you can use any export that you want, and that's it for this video. I hope it was helpful, and now I'll see you next. So in the last video, we were able to work with our modules, how we can import them, how we can export them, and so on and so forth. So in this video, I want us to perform a post request, okay? But before we do that, I want to do some cleanup. Right here, I can see I am exporting to do twice. So I don't need to include this export here. And then I'll come to my package.json file and remove this configuration which I had included in the last video. Because I'll be using require, this configuration will throw an error in my application. But if you are using the import statement, make sure this configuration is here. So for me, I'll just remove it, okay? And now our app should run without errors. Let me see. It's restarting, and yeah, server running on port 5000 and MongoDB connection established. So the next thing that I want us to do is to install a package that we will need to configure. So I have just opened the terminal here, and all you need to do is to say npm I CORS, and this CORS stands for cross origin resource sharing. It allows us to access our endpoints from a different domain. For example, we'll be hosting our React app from a different domain, and this CORS will allow us to access our endpoints from different domain. Okay, so in my index.js file, I will import this CORS after just hitting enter so that it installs as we proceed. So right here, how we will import this package is by saying const CORS will be equal to require and then CORS. And how we configure this one is by using a method available in our app called use. So right here, I'll say app.use. And then I pass in CORS here. And CORS is now a middleware. Every time we use app.use, you'll know that we are now using a middleware function. And a middleware function simply adds functionality to our application. It is added to the request pipeline, and it have access to this request, it have access to response, and it have access to a method called next. Okay, and next allows the middleware to pass functionality to the next middleware, so it can access request and change the body of the request. It can send something to the client and thus terminating the process, and it can pass functionality to the next middleware function. Okay, later on we'll be learning more about middleware functions when creating our own middleware function. Okay, so for now, don't worry too much about it. Just know that it adds functionality to our application and it have access to request, response, and next. The next thing that we will do is to configure JSON. So right here, I'll say app.use, and how we configure JSON in our application is by using Express. Okay, so how we do that is by saying express.json, and then we invoke it, and now this is a middleware function. And what this middleware function will allow us to do is to pass JSON in the request object. Okay, because we'll be working with JSON data, and that will allow us to pass JSON in the body of the request. Okay, now that we have configured these two, we will go to the root of the application and add a new folder called routes, and this will help us to create all our endpoints in this routes folder. We'll add a new file in this folder called to-dos, and in this file is where we'll have all our to-dos endpoints. Okay, and that way our index.js will remain to be simple and easy to read. So in our to-dos.js, I'll open this. The first thing that we need to do is to import our to-dos model. So this model that we created here and exported it is what we need to use in this to-dos.js file. I'll say const to do. So as I told you before, here we are extracting the to-dos property from the exports object, which is available in a global object called module. Okay, and then we get this from require. We need to go to the models folder, so 2 dots and a slash. We go to models stroke to do. The next thing that we need to do is to import express. So here I'll say const express will be equal to require express. Earlier we used express here to create our main app. So if I come to index.js, you'll see that we imported express this way and then used it to create our main app. And we can use the same procedure, but right now we'll be creating a mini app to help us work with our routes. So in our to-dos.js file, I will say right here const router will be equal to express dot router. Now this is a router class that is available in Express, and we invoke it. So this way we are creating an instance of our router, and this instance is now an object representing a mini application, and this mini app we can use it to create our endpoints. So at the bottom here we can create an endpoint. So router dot post, and now this will handle the post requests. The first parameter is a path, and then the second parameter is a callback function, and this callback function have access to request and response. And then so in here we'll be creating a document using our model. Okay, and this document is simply an object. Okay, so right here I can say let to do. So this is how we define a variable in JavaScript using let, and then we say is equals to new to do, and this to do is our model. And as I told you before, this to do is a class, and when we use the new keyword here, we are now making it to be a constructor to create our object. Okay, and now right here we can invoke it and pass several properties inside here as an object, and these properties are similar properties to what we included in our to-dos schema. So as you can see, the to-dos schema was shaping our document. It was giving us a structure of how our document will look like. Okay, so we should have a property called name, author, UID is complete, and date. So in our to-dos here, I'll say name will be equal to request, and then we tap dot body dot name. Okay, so this is how we access the properties that we send in form of JSON from our request. So request.body.name, we can extract all our properties, the name, the author, from the request body this way. Okay, so at the top here I will extract the properties. This is how we do it. You can do this way if you want, but an alternative way, you can extract the properties just like this. So right here I'll say const, I include these curly brackets to extract the properties. We will be extracting the name from request.body. We will be extracting the author. We will be extracting is complete, and then we'll be extracting the date and the UID. So they don't have to be in order. Okay, you can use any order you want, and then this will be coming from request.body, and we don't now need to keep repeating request.body when adding our properties. We can simply say name will be equal to name, and then even a better implementation, you can see the key here and the value are the same. When key and values are the same, you can use only name. So now we can just say name. So this is now a better implementation, because all we need to do is to pass all these other properties in here. I'll copy this and then paste here. And with this, we are now creating a to-dos document. Okay, now this is a document which will contain all these properties once we send a request from the client. The next step is saving this document to the database. How we do that is that this to-do have a method called save. So we can say to-do.save, and when we invoke this method, our document will be saved to the database. But this is now an asynchronous request. It will take some time to process, and then it will return a promise to us. So for that, we can either use async await, or we can use the .then method. So I'll start by using the .then method here. So to do .save, you can tap a .then method, and then in here we will get a to-do. Once this is complete, a response will be given to us, and that response is our to-do document. So right here we'll get a to-do, and then we use an arrow function, and we can do something in here with this to-do. For example, we can now send this to-do to the client by using res.send, and we pass the to-do here, as simple as that. And then we can tap a .catch method here. So right here you can say .catch. We have an error object. We have access to an error object here, and then we use an arrow function, and we can log this error to the console this way, console.log, and then we say error.message this way. Okay, so we save the document. It takes some time to process. Once it's done, it returns a to-do. We send this to-do to the client. If there is an error, we catch the error and log the error to the console, or alternatively, you can send this error to the client. So the other way of doing this is by using async await. So what I'll do is that I'll remove all this code. You can use this method if you want, but I remove it. And then using async await, right here we'll be getting a promise, so we await it. So we will say await and store this promise in a to-do. We earlier defined this as a variable, so we can reuse it here. To-do will be equal to await to-do.save, and now our to-do will be a variable in this variable. And then the next step, we will send a response to the client, res.send, and we pass our to-do in here. But when using await, we need to wrap our function with async. So you can see this is our callback function, so we can wrap it with async here, this way. Okay, so async await. And then how do we handle the errors? In the .then method, we used a .catch to catch the errors. In this one, we use the try and catch block. Okay, so right here we can try, and then in here we include this code, and then right here we can catch an error if there is any. So right here we have access to the error object, and then we can log it to the console if we want. So we will log it to the console, and also we can send an error to the client. So right here we'll say res.status, and with this we can set the status of the request, and we'll be using the status 500, which means that a server error occurred, and then we can send a message to the client. So .send, and we include the message here, error .message, and we can also log the error to the console.log error.message, this way. And when I save this file, you'll see that I am using Prettier, and it will auto format the code for me, and then I can include a spacing here for better readability. So just a quick recap, we are extracting our properties here from request.body. We are creating a document using the to-do model and passing these properties inside this model, and then we are using a try and catch block to handle the errors, and then we are saving our to-do document to the database using to-do.save and sending the response to the client. And then in our errors, we are sending an error message to the client and a status of 500, meaning that this is a server error, and then we are logging also the error to the console. Now we need to use this file in our index.js. So at the bottom here, we need to export it. So I'll say module.exports. In the last video, we learned more about exports, and we saw this global object called module, and it have a property called exports, and we can by default set this one to router. And now here we are exporting our mini app from this module, and our router have our endpoint, which is this one here. Okay, so let's go to index.js and import this file right here. So at the top I will say const to-dos will be equal to require. We will go to the routes stroke to-dos, that way. And then just at the bottom here, after this middlewares, I will include app.use. Okay, because now this is acting as a middleware because of our mini app. So if I come to the to-dos here, we defined our mini app here, and this mini app is like a middleware function, so we should use app.use, and then the first parameter here we can pass in the path. Okay, the path of our to-dos endpoint, I want us to be stroke API stroke to-dos. And then the path that we included here in our to-dos.js file here, this path will be automatically added at the end here, okay? So if you use a stroke something in our to-dos here, stroke example, now our endpoint will be localhost 5000 stroke API stroke to-dos stroke examples. But for now, it will be localhost 5000 stroke API stroke to-dos, okay? And then the second parameter is now our mini app, so to-dos. And this is how we do it. And we have just created a post endpoint to handle our post requests. So in the next video, we are going to test this endpoint using Postman, okay? So first of all, I'll come back to my server here and see if everything runs. Server running on port 5000 and MongoDB connection established. So everything is working, and our course was successfully installed here. Make sure yours is also successfully installed, and I can cancel this one. So I'll see you next, where we'll be testing this endpoint and see if everything now works, okay? So in the last episode, we were able to create an API endpoint to handle post requests. And in this episode, I want us to test this API endpoint using Postman. The first thing is to open your browser and visit postman.com/downloads, and then you can download Postman for your OS, for Windows, and if you are using Mac, just scroll at the bottom here and you can download for Mac or Linux. Once you download Postman and install it, just open it and you land to a page like this one. At the top here, open a new tab, and this is where you can test the endpoints. So you can test a get request, post request, put, patch, and delete. So these are the CRUD operations. And let's start by testing a get endpoint, which we created earlier in my index.js file here. You'll see that we created an API endpoint to handle get request. So when we test this endpoint, we should get a welcome message. Welcome to our to-dos API. So now let's test this endpoint. Right here we type the URL, which is http:// and then we are running our server on localhost :5000, and then this is the home page. When we send this request, we should get that welcome message. So send, and there we go. Welcome to our to-dos API. So this endpoint is working okay. Now let's test our post endpoint, which we created on our to-dos file, okay? So when I come to the to-dos.js, this is where we created our post endpoint, and we can test this endpoint with Postman. So the first thing is to enter the URL, which is http localhost 5000, but right now we'll add something at the end here, because at our path in index.js we included stroke API stroke to-dos. So I'll copy API stroke to-dos, and then in my URL here I'll add it here. And then we need to send something to the body of the request. So right here we have body, and then click row, and we'll be sending our data in JSON format. So here at the drop down, select JSON, and I'll enter sample data here in form of an object. The first property is name, and the name can be our first to do, and then the other property was author, and the author can be Charles, and then is complete, So this was a boolean, so it must be either true or false. So right here I'll say false, and I can enter these three properties, although we had more than this. So if we come to our to-do schema, you'll see that only the name was required. So if we omit these other properties, it should not throw an error. So we have a name, an author, and is complete. Date will be added automatically because we included a default date, and we can omit the UID. So now when we send this request, we should get a to-do back, because in our endpoint, let me show you, once we save our to-do, we are also sending the same to-do to the user once it have already been saved. Okay, so let's send this request, submit, and perfect. Now we are getting a to do back, and you can see now it have additional values because this is now coming from the database. We have a date which was automatically added by default. We have an ID which is a string of characters. This was added automatically by MongoDB. And then we have what we included in the body of the request: name, author, is complete, and also we have a version for this particular to do. Now when we go to MongoDB, we should see this data. Okay, so I'll open my browser and then go to MongoDB Atlas. Now right here you can click collections, and you should see that a database was created automatically called to do app. And when I come here, this is the data that we just added: name, author, and is complete. Now where did this name come from? This is the name of the database. Remember, in our connection string in our .env file, we had included the name of our database here, to do app. So this is the name that was added. Now let's test whether this validation works, where we set a minimum of 3 and maximum of 200, and we made the name to be required. So I'll come back to Postman and I'll omit the name. Let's submit, and now we should get an error: to do validation failed, name path name is required. Now let's include a name but with fewer characters than 3. So I revert this and delete something. Only include 2 characters. When I submit this, we should also get an error: to do validation failed, name path name is shorter than the minimum allowed length, which is 3. So you can see that our Mongoose validation is working. Now in the next video, we will look at further data validation using Joy. So in the last episode, we were able to test our post endpoint, and we were also able to see that our Mongoose data validation works. Now in this episode, I want us to perform further data validation using Joy. So when I come to my browser here, you'll see that I am in Joy documentation. So just visit joy.dev, and I want us to go through this example together. And then after this, we'll try to use Joy in our application. So the first thing is to obviously install Joy. So as we go through this example, you can run this command in your terminal. So in my VS Code, you can run this command to install Joy in your application: npm I, and then you say Joy. And this command should install Joy in your application. So for me, I have already installed Joy, so I'll skip this step, but for you, make sure you hit enter and install Joy as we check at this example. So as you can see right here, we are importing Joy from Joy, and then the second thing is to create a schema. So we already created a Mongoose schema. Now this schema is just similar to the Mongoose schema, okay? It is just containing the properties that we should save to MongoDB. So how we create a joy schema is by calling joy.object, and this is a method, and we pass an object here which contains the properties that we want to save to MongoDB, okay? And then right here you can see this is now a username, and the type of a username is a string. Now in Joy, to define a string, you call a .string method which is attached to our Joy here. To set a minimum value, you tap a .min method here, and then you set the minimum value, and then you tap a .max to set a maximum value, and also you can set it to be required by tapping a required method. And then after creating a schema, the other step is when I scroll at the bottom here, is calling a .validate method which is available in our schema object, okay? So we tap a .validate method, and inside that validate method we pass the data that we are getting from the client. Now in our case, this data will be available in request.body, and the return of this call is a value or an error if there is any. So the value is the data that was passed just right here, and then the error is an error message from Joy depending on the validation. So like in this case, you can see when we call a .validate with an empty object, you can see the error we are getting is that name should be required. So I'll show you how we can extract the value and error and store them in a constant so that we can use them in our application. Now let's go back to our app and try to use Joy in our app. So first of all, you might wonder, why are we doing a double validation? We already have this validation. Why do we need Joy? So the reason we need Joy in our application is because sometimes the data that we get from the client is not the same data that we save to the database. So we need to validate the data that we are getting from the client directory, and then sometimes we manipulate the data in our API here before we actually save it to the database, and that is why we need Mongoose data validation, which will happen while saving the data to the database. And a good example for this is the password. So when we get a password from the client side, it's usually in text form, okay? Just some simple text, okay? But when we come back to our endpoints, we usually manipulate the password and encrypt it to a very long string which is not the same length as the one that was entered by the client, and that password also needs to be further validated by our Mongoose schema so that we can then save it to the database. Another reason is because Joy have an awesome way of displaying error messages, so we can send these messages directly to the client. Now let's make use of Joy, and I'll assume that your package have already installed here, so let's import it at the top. We will say const joy is equals to require Joy, and then we can now use Joy inside our route here, okay? So right here, the first thing we will do is to define a schema. To create our Joy schema, we use joy.object, and we invoke this method and pass an object in here containing the properties that we want to validate. Now we want to validate the name to be a string, So joy.string, and this is a method. We tap other methods at the end here. We want it to have a minimum value of 3 and then a maximum value of 200 characters, and we also want it to be required. Now this line right here is similar to what we had in our Mongoose schema. So here we were passing an object and then type string, required true, min 3, maximum of 200. Now let's go to the author, and I need to call this required like that. And then right here we include the author, and now we will use joy.string, and we can also set a minimum value for the author to be 3. So right here I'll say a min of 3 and also a max of that characters. So a min of 3 and a max of 30. Now let's do the same in our Mongoose. So to do this in Mongoose schema, we need to convert this to an object so that we can pass different options. The first one is type to be string, and then the second one is min length to be 3, and the other one is max length to be 30. Now this is similar to what we have here, but now we are using different packages. So right here we'll say UID, and we simply want this to be of type string, so joy.string, and we invoke that as a method there. We go to the other one, which is complete, and this should be a boolean, so we say joy.boolean, and we invoke it, and then lastly we have a date, and this should be joy dot date. So now perfect, we are now creating a schema with all these properties. Now let's see whether we can get error messages from our schema. Okay, so what we can do is to first call the validate method, which is attached to our schema object. So right here we'll say schema dot validate, and we pass the data that we are validating right here, and we'll be simply validating our request.body because it's the one that is containing our object with all these properties. So right here I'll just say request.body, and this should be an object containing the properties. If you want to destructure, you must set this to be an object and then pass the properties. Okay, so you see the difference. So request.body, so this is our value, and earlier we saw that this is returning either an error and a value. So a value is being returned and an error is optional. If there is an error, it will be returned. If there is no error, will be undefined. So we can store the error and values in a constant. Because they were in form of an object, we can say const, and then we destructure them from the object. Let me show you. So at the bottom here, when I scroll, you will see that we have an object which contains a value and an error. So we can destructure the value and errors from this object. So that is what we are doing. We get a value and then we also get an error from here. Now we have access to error and object, and we can log this to the console. So at the bottom here, I'll simply say console .log. We log the value to the console, and we can also log the error. Yeah, let's try this one out. And what I'll do is that I'll go to Postman and perform a post request so that this code runs. So in my Postman here, I already have an invalid name here. So, and I can also include an invalid author. So the author, I'll set it to 2 characters so that it's invalid also. And let's send this request. And we are getting an error. Yeah, so this error is coming because we didn't include a comma at the end here. I also cross this one, and I'll need to restart my server here. I'll stop it and restart it with NodeMon. So don't let errors scare you, because as a developer you'll always encounter errors. So back to Postman, let's send this request again. Our request is hanging. So when I check here, you can see unhandled, promise rejection, type error, joy.string.mean is not a function. So let me check my code. You see right here, I also made this mistake where I didn't invoke the string method. Okay, so yeah, these are just typos. Make sure you don't have the same typos as me. So now let's see server is running again, and then I'll send the request again. And now everything have worked. So these error messages which you are getting here is from Mongoose, and we are getting 2 error messages. The first one is for our name, and the second one is for our author. Now let's take a look at the output of Joy, and remember we logged the errors to the console and the value. So I'll come to this terminal where we were running our server, and you can see we have an output here. And you can see the first thing we have is the value. Okay, as the same way we logged to the console, the value first and then the error. So, and you can see the value contains just what we sent from Postman, and then the error. So you can see how it's displaying error messages nicely. Name length must be at least 3 characters long. Okay, and then when we look at our details here, this is where we have the error message. But now in Joy, you can see we are getting only 1 error message, and this is so because Joy aborts the validation process once it gets an error. So when it gets an error in name, it will abort the validation process and return that error to the user. But there is a way that we can go around this and display all the error messages right here. Right here, we can tap options. So we invoke this and pass an object in here. The option that we'll pass is abort early, and this option is set to true by default. So all you need to do is to set this to false, and this will enable Joy to display multiple error messages. It will validate all the properties and then give us a feedback. So now let's send the request one more time and see if we get 2 error messages. So I'll come to Postman and submit the request. This is like hanging, and I don't know if I have an error. So our server is not running, and I'll press this space to make it restart. Let me send it again. So this is the error messages that we are getting, but let me resend this one. And now in the console, you'll see that in details we have 2 error messages now, name and author. So if you want to access all the error messages, you can include these options right here and set the abort array to false. But in my case, all I want is to display each error at a time. So I'm just keeping it simple. So right here, I remove the options, And once we get an error, I want to send this error to the client. Okay, so I want to send a response to the client. So how we can do that is to check if this error is available. So if there is an error, it will be available. If there is no error, it will be undefined. So we don't need to use the value in this case. So I'll remove it and also remove this log. So right here, I'll perform a check. If error exists, we want to return something to the client. And what this will do, it will terminate all this process and it won't even reach to our Mongoose schema. So we will return this error to the client. So right here, we can use our res object here and we will say res.status. And we will set the status code to be 400, and this means that this is a bad request from the client, meaning that this is a client error and not a server error. So the client should change the values or do something so that this works. Okay, so status code 400 just means this is a bad request and it is a client's error, and then we can send a message to the client. So .send, and we want to access our error message. So when I come to Joy here, how can we access this message? We have access to our error here, so we can set error and then we tap .details and access the first value from this array. Okay, because this is an array of objects, and then we access the message from that. Now let's do this right here. We have access to error .details. Now details is an array containing our errors, okay, our error objects. Okay, so we access the first object this way, and then we include a 0. So this is the first object in our array. Okay, and once we access this object, we can now access our message property. So right here, I'll just say .message, and this should give us this message right here. Name length must be at least 3 characters long, and we won't be having this one because we removed the options. So if this one is valid, this is when we will get this error. Okay, so let's test our application. I'll press space to restart this and go to Postman. And now when I send this request, we should get a response here from Joy. So, and perfect. Name length must be at least 3 characters long, and this is coming from Joy. Now let's make the name to be more than 3 characters long, maybe hour, and try to send this request. And now we get the second error. Other length must be at least 3 characters long. So you can see we are aborting everything by returning a response to the client. So this process doesn't happen where we are creating a document and saving it to the database. Now once all this is valid is when we will perform these other functionalities. Now let's test with valid values. So maybe here I can say our second to do and send a valid author Charles. And once I send this one, now we should not get any error here. Okay, so send, and we are getting back our to do. Now let's see if this is available in our database. Now when I come to my collections and then in our to-dos collections, you'll see that we have two documents right here. So as you can see in MongoDB, we don't have tables, we have collections and documents. And that's it for this video. In the next video, we'll see how we can get this data from the database and send it to the client. So we will be handling GET requests. In this episode, I want us to create an endpoint to handle GET requests. So at the top here, I just say router dot get, and then the first parameter is our path, and a second parameter is a callback function which have access to request and response. And since we'll be handling promises in this function, I wrap our function with async. So right here I'll say async, and then our callback function have access to request and response, and we can set it to be an arrow function. Now in here we can get our to-dos from the database using our to-do model, which we had created earlier in our models folder to-do.js, and exported it as to-do. So in my to-dos.js, I'll say to-do, and we have a method called find, and with this method we can be able to get all the to-dos that are in our database. So I'll invoke this method, and this will return a promise, so we can await it and store this in a constant. Okay, so right here I can say const to-dos. I'll spell this correctly. So what we will get from to-do.find is our to-dos. We can send this to the user just like this, rest.send to-dos, and let's test whether we are getting our to-dos. So I'll come to Postman, and we'll now perform a GET request. So I'll change this to GET, and then the endpoint remains as it is. So I'll send this request, and we should get our to-dos from the database, and there we go. So now we are receiving our document, which is our to-dos from the database. Now we can create more complex queries. With this to-do.find, we can chain other methods to perform more complex queries. Now let's see our Mongoose documentation here. Just go to mongoose.com/docs/queries, and we can look at this example right here. So we have performed a to-do.find, and we included nothing inside here. So when we include some properties or options in here, we are simply filtering our to-dos. So for example, we can filter our to-dos depending whether they are complete or not complete, just like this. So right here we can say we pass an object, and then is complete. We can set it to true. So if there are no complete to-dos, we should get an empty array, but if there are complete to-dos, those to-dos are returned by this endpoint. Now when I come to Postman and try to test this, we should get an empty array because all our is complete here is set to false. So I'll submit, and you'll see that we are getting an empty array. So this is how we perform a filter using the properties, and you can include multiple properties. So back in my documentation here, you'll see that you can include any property that is available in the document, and then you can filter using the comparison operators. So for example here, age, we have these comparison operators. Okay, so you set age to be an object instead of setting it directly to be maybe 17, you set it to an object, and then you can say age to be greater than 17 and less than 66. So we have more comparison operators like in here. Just search for MongoDB comparison operators and click this option, docs.mongodb, and you'll get to a page just like this. And here you can see all the comparison operators that you can use. You can use equal to, where you filter depending on equal values, greater than or equal to, and then in matches any of the values specified in an array. So in this Mongoose documentation, you can see that in we are passing an array and we are passing several values. Documents that have the property likes containing, vaporizing, and talking are the ones that will be returned. And then we have more, less than or equal to, not equal to, and not in. Okay, and we have more query operators, like the logical query operators. So you can check this documentation if you want to perform more complex queries. And then in my Mongoose documentation here, we can get a certain number of documents. Okay, so we can limit it to only 10 documents. You just tap a dot limit method here and pass the number of documents that you want to be returned. You can sort. So in our query here, we can sort depending on the date. So right here it says sort, and then in brackets I include an object and I want date to be in descending order. So here documents that were added last will appear first, and to sort in ascending order you just include a 1. So old documents will appear first. So this is sorting. And then we have more. You can select certain properties that you want to be returned to the client. So for example, we can select only the name, and let's try that one out. Right here you can say dot select, and then you pass an object and you set the name to 1. So this means this is true. Okay, so name will be selected. And then let's see this last one. You execute a callback. Let's see what we get from this query. We are filtering depending on whether it's complete. So here we will get an empty array. So let's change this to false so that we get some documents. And then we are setting the date to be in descending order, and then we are selecting only the name property. So let's come to our Postman and send this request one more time, and you'll see that now we are getting only one property and an ID. So this is how you can perform more complex queries, and you can check on the comparison operators and also the logical operators. So in my case, I won't be performing any filtering at this point, but later on when we add authentication, we will filter our documents depending on the author or the UID. Okay, so I remove this, and then we'll sort our document using the date so that the to-dos that were added last will appear first. And then right here we won't select any fields, we'll return all the fields to the user. And this is an async action, so we need to wrap this in a try and catch block. Okay, so right here we'll say try, and I'll move this inside this try, and in case of any errors I'll catch them right here. So I'll say catch. We have access to our error object here, and we can send an error message to the client. So right here I'll say res.status, and we use the status code 500, meaning that this is a server error, and then we send a message right here .send, and we will get the message from error.message. Just like that. and then we can also log the error to the console. So right here I'll say console.log error.message, and that's it. This is how we can handle get requests. So we use to-do.find. You can apply some filters here if you want. You can sort, you can set a limit, you can use the comparison or logical operators, and then you send those to-dos to the client. If there is an error, you log the error to the console or send an error to the client. Now let's test this endpoint one more last time by performing a get request. So I'll perform a get request and I am getting all my to-dos. So that's it for this video, and in the next video we will try to delete our documents from the database. So we will create an endpoint to handle delete requests. So in the last episode we were able to create this endpoint for handling the get requests, and in this episode I want us to create another endpoint to handle delete requests. So I'll scroll at the bottom here, and this is where I'll create an endpoint to handle the delete requests. So we will say router.delete, and as usual the first parameter here is the path, and then the second parameter will be a callback function, which will be an async function, and then we have access to request and response, and we set it to be an arrow function, just like this. And now we can do something in here. So I want to show you 3 ways in which you can delete documents from MongoDB, and the first way is by using delete one method, and the delete one method will delete one document from the database. And then we have another method called delete many, and the other method that we will use is a find by ID and delete. So we have 3 methods which we will try out. The first one is delete one, which will remove one document from the database. Delete many will obviously remove many documents from the database, and this one will remove a document depending on its ID, and this one is supposed to be in camel casing. Okay, now let's try the first method right here. So we will use our to-do model to do, and this method is now available in this model, to do.delete one, and we invoke this method. Now whatever we pass in here is a filter. We can filter the document that we want to delete in form of an object, the same way we performed a filter when we were trying to get our to-dos from the database. So we can pass properties for the document that we want to delete. We can pass an ID. That is one of the best way to delete a specific document, but you can also pass other properties like is complete, and you specify the value. So if I set here is complete to be true, we will delete a document that have is complete to true. But with this, we may have more than one document or to-dos that have a property is complete set to true. So the first document that will be found by MongoDB is the one that will be deleted. This process will return a promise, so we can await it, and we can store the result in a constant, just like this. So const to do. And when using delete one, this to do just have some information of the number of documents that were deleted and the time that it took to delete the document and some other details. Okay, we can send this to the client just like this, res.send to do. Okay, now let's go to Postman add a new document, set it to true, and then test this delete endpoint. Okay, so I'll come to Postman and I'll perform a post request, and actually I'll just use one of these from the history here. So I'll click this, and then when we come to the body of request, we'll see that we already have some data because it's something that we have done before. We can set this one to true, and we can also change the order so that we differentiate, and we set it to Chaoo. So let's perform a post request, and we get the to-do that was added to the database. Let's perform a get request. We confirm that we have 3 documents in our database. Okay, so I have also reused one of these. I send, and when I scroll here, you'll see that we have 3 documents in the database. This is set to false, this is false, this is true, and the other is Chaoo, this is Charles, this is Charles. Now let's perform a delete request and see if this document will be deleted from our database. So right here, I'll just set this to delete, and the path is the same. Okay, now I will send this, and look what we get back. We get the number of documents that were deleted. It is 1 document and some other information. Now let's perform a get request again and see if we have 2 documents in the database. I will send, and perfect. Now the to do that head is complete as true is gone. So this is one of the way that you can perform a deletion of documents in the database, and you can pass any kind of filter that you want here. Okay, let's try delete many. We will just change this to many. Okay, and then we can set this to false, and this should delete all the documents that have is complete as false. So this should clear our database because our database have 2 documents which are set to false. Now let's perform a delete request at this endpoint. I will submit, and look what we get back. 2 documents were deleted and some other information. Now let's perform a get request and confirm that we are getting an empty array. I will send, and perfect, there are no documents in the database. So by using delete many is another way you can delete documents from the database. Now let's use find by ID and delete. So I'll just replace this method right here, find by ID and delete, just like that. And now all we need to do is to pass an ID in here. So how we usually do this is by passing an ID to our path. So we can change our path here, and we include a parameter just like this way. We will include a parameter called ID. Okay, and to read this parameter so that we can use it here, we will use request dot params. So this is an object that will allow us to read these parameters that we use here, and the parameter that we added is ID. So I'll just pass dot ID here. The next thing is that what we get right here is the deleted to do. Okay, so right here I can just say deleted to do, to be more specific, deleted to do. So we can test this one out. I'll come back to Postman, and we don't have any document at the moment, so I will use one of these, and let's set this one to our test to do. I send and perform a get request to confirm that we have this document in the database, and there we go. So our test to do is there. Now let's try to delete this to do using our third method of. So we will need the ID of this to do. I copy this. We perform a delete request, and I need to include this ID at the end here. So stroke ID. Let's send this request, and we are still getting back the to do that we deleted. Now let's perform a get request to confirm that we have an empty array in our database. I will send, and we get an error, and this is because our get request is trying to reach this endpoint which have an ID. So we need to remove this and perform a get request, and we get an empty array, meaning that that to do was actually deleted. So back to my code here, you have seen that we can use all these methods to delete a document from to do, and the method that we will be going with is find by ID and delete. So I remove these ones and remain with this piece of code. Now we need to wrap this in a try and catch block so that we catch the errors. So right here I'll say try, and we pass this code in here, and then we catch the error. We have access to our error object, and we can send the error to the client. So right here I'll say res dot status. We use the status code 500, meaning that this is a server error, and then we send the error to the client just like this, error dot message, and then we can also log the error to the console. So right here I'll say console dot log error dot message, and when I save this, I am using Prettier, and it should format my code. So that's it for this video, but in future when we add authentication, we'll come and make some more changes in this endpoint. But for now, this is good enough, and in the next video we will create another endpoint to edit our to-dos. So in the last episode, we were able to create an endpoint to handle the delete requests, and in this episode I want us to create another endpoint to handle the put requests. So put is used to edit a document, and there are two requests which you can perform to edit a document. The first one is put, and the other one is patch. So in this video we will start by handling put requests, and then in the next video we will handle patch requests. So at the top here I'll create a new endpoint using router.put, and the first parameter is the path, and the path here should have an ID of the document that we want to edit, just like we did with our delete here. Okay, so right here I'll include a path and also pass an ID to this path, and then the second parameter here is an async function. So I'll say async, and it is an arrow function which accepts request and response. And then in here we'll be able to do something. Okay, so let me create good spacing there, and we continue down here. Now with put requests, we usually send a new version of an existing document. Okay, it's like we are replacing the existing document with a new one. Okay, and to do that we usually send a new version of the request body. So at the top here, since we will be getting the data from the client, we will validate the data using joy, just like we did with our post request. So I won't repeat the whole of this process. I'll just copy all this code from where we are creating a schema, getting an error from schema.validate and then checking if the error exists or not. If it exists, we send the error message to the client. So I'll copy this code and then come at the bottom here where we have our put here and paste this code. So the next step after we check this, we need to check whether the document with this particular ID exists or not. So just right here, we will use our model, which is to do, and then call this method dot find by ID. And then in here, we will pass the ID that we are getting from our path here, okay? And earlier we used request.params.id to read IDs that are included in the URL. So right here, we'll just say request.params.id. And this will check whether a document exists in our database or not. And right here we will await this process because it will return a promise. So await, and we store it on a constant. So right here I'll say const to do will be equal to await to do dot find by ID, and then we pass the ID in here, and we are reading this ID from our path. So now we can perform an if statement, and we'll say if, we will use an exclamation mark here, meaning not, okay? If not to do, so to do does not exist, we will send a 404 error, meaning that the to do was not found, okay, or the source was not found. So right here we'll terminate the rest of the process by calling return, and we say res.status 404. Now this means that this resource was not found, and then we send a message to the client just like this .send, and what we will say here is to do not found, and I can pass some dots there, and that's it. So if this resource does not exist, we will tell the client that it does not exist, okay? But if it exists, so this won't be called, and we'll proceed to updating our to do. Now right here we will say to do dot find by ID and update that way, and we call this function. The first parameter is the ID of the to do that we want to update, which is available in request.params.id, and then the second parameter is the body of the request, so it contains the name, the author, the UID, and is complete, and that is what we will pass as the second parameter here. So I'll just come to our post right here and reuse this code where we were destructuring the name, the author, is complete, date, and UID from request.body, and I'll come right here. Just before we perform this update, I'll paste that code right here, okay? And we'll pass the name, the author, is complete, and date in this object. Now this will return a promise, so we can await it and store it on a constant. So I'll say updated to do will be equal to await, so I need to call const here. Const updated to do will be equal to await to do dot find by ID and update, and then I call this. If I save this file, it will be auto formatted by Prettier. I am using Prettier as an extension here, okay? So this is what we have. Now this updated to do, which is returned right here, will be our old version of the to do, but what we want to get is the new version of our to do, okay? And to get the new version, we need to also include another object here, and this object contains the property called new, and the value here is true. So we will get the new document which have already been updated by this particular method. Now the next step that we need to perform is to send our updated to do to the client. So just right here, we will say res.send and pass our updated to do here, updated to do. So I'll save this file to auto format, and then we need to catch the errors. So I'll place this code where we are updating the to do and sending it to the client in a try and catch block. So right here I'll say try and pass this code in here, and then the next code will be catch. And since we have already performed such a thing, I'll just copy this, copy, and then down here, just after try, I'll paste it here. Okay, if I save and then scroll at the top, this is what we have. Try, we place our updated to do in a constant, and then we use this method to update the to do, find by ID and update. The first parameter is the ID of the document we want to update. The second parameter is our request .body, and then we set a flag here, new to true, so that we can get the updated to do back and send it to the client. And then we catch the error, res.status 500, meaning that this is a server error, and then we send the error message to the client or also log it to the console. So this is how we can perform a put request. And as I said before, put usually replaces the existing document with a new version of the document. Now let's test this one on Postman. So I'll come to Postman. If I perform a get request, so I will use one of these one here. We send this request. So you see we don't have any documents in our collection. So let's perform a post request to add a new document. So I'll perform a post request and send. And now this is our new document. Now I need the ID of this document for us to update it. I'll copy, and then we perform a put request. We include this ID at the end here, and then in the body of the request we can update our to do. So as I told you before, we need to send a new version of this to do at our body of the request. So right here we can say our edited to do, and then we can change the name here to Chaoo Charles. We can set is complete to false, and also we need to pass a date to this document. For the date, I will use this one. So I will use the date, and then the ID we don't need to update that. Name, author is complete, and version we don't need to touch that. So if we send this request, we should get our updated to do back. Okay, so send, and there we go. So we have a date, which is this, we have an ID, we have a name, we have an author, and is complete. So you can see all the properties that we updated have been edited, but we didn't include a UID, and it have been set to null. So I'll show you how we will send all our updates from the front end, because on the front end we'll only have one input field for the name, but we won't have other input fields for the author, for is complete, for date. For now, don't worry about how we will do it. We will handle that when we get to React. And that's it. That is how we handle our put requests. So in the last episode, we were able to create an endpoint to handle put requests. And in this episode, I want us to create another endpoint to handle patch requests. So both put and patch are used to edit documents, but what is the difference between put and patch? So with put, we usually replace the body of our document with a complete new version. So we include all the data here, and when we submit that, we replace the existing document with our new data. And when we omit some of these properties, you'll see that we get null for that particular property. For example, in this request, we omitted a UID, and when we submitted it, we got a response of UID as null. So at the body of the request, we should include all the properties that represent our document. Okay, someone asked me why I didn't include a UID in the body of the request, and the reason is currently we don't have a user, but when we work with our front end and add authentication, we'll be able to add a UID to the body of the request. Now with patch, we can edit just a particular property, and that is what we are going to do. We are not replacing the whole body of our document. We are going to just replace a certain property. You can replace all of them if you want, but in this case, we are just going to replace one. And the endpoint that we are going to create is for marking a to-do as done or not done. So the property that we'll be editing is this particular property. Now, when we performed this request, there was an error that was popping on our command prompt here, and it is a deprecation warning. And it's complaining that find one and update and find one and delete without the use of use, find, and modify set to false are deprecated. So to get rid of this deprecation warning, we should add this option, use, find, and modify when connecting to MongoDB. So when I come back to my code and go to index.js, scroll at the bottom here, we should add this option just right here, and we should set this to false. Now when we send requests, we should not get that duplication warning. Now let's go to our todos.js file and we create another endpoint just after put, and we'll create it here using our router, and this time we are creating an endpoint to handle patch requests. The first parameter is a path, and we should include an ID to this path, and then the second parameter is a callback function which is async. It have access to request and response, and we can update our document in here. So the first thing that we will do is to check whether a to-do exists or not. So right here, I'll come and reuse this code where we were finding a to-do by ID and also using an if statement to check whether it exists or not. So I'll copy that and then come to our patch and paste it here. And we should also do the same for our delete. Before deleting a to-do, we should check whether it exists or not, and then if it doesn't exist, we send a 404 error to the client. So in our router.delete, I'll also be that code right here. Okay, now let's come back to our router.patch. If our to-do exists, we want to update it. Okay, so right here we will still use find by ID and update. So we use our model to do dot find by ID and update, and then we invoke this method. The first parameter is the ID of the document that we want to update. So we use request dot params dot ID. So that is the ID, and then the second parameter is an object here, and the body of this object should contain the property that we want to edit. And this endpoint is for marking a to-do as done or not. So we will target the isComplete property, and what we are getting here is the to-do that we want to edit. So we have access to that particular to-do right here. And we can also target the isComplete property on this particular to-do, just like this. So we can say to-do dot isComplete. And then we want to, every time we send a request to this endpoint, we want to change this property from true to false or from false to true. So that is checking and unchecking that particular to-do. So right here at the front of this, we should use an exclamation mark. So this means that we set the isComplete to be the opposite of to-do.isComplete. So if to-do.isComplete here is true, our isComplete will now be false. If this one is false, this will be true. So this is what this line of code does, and what we get after performing this request is our updated to-do. So we should await this and then store the result on a constant. And now we can send our updated to-do to the client. So we can say res.send updated to-do. Since this is an asynchronous call, we should wrap it in a try and catch block so that we can catch any errors. Okay, so right here I'll use try, and I move this code inside the try block, and then in case of an error we will catch it right here. So I'll copy this code where we were catching an error and I can paste it here. When I save, the prettier extension will auto format the code. So let's do a quick recap. Right here we are checking whether a to-do exists or not. If it exists, we use to-do.findById and update to update the to-do. The first parameter is the ID of the to-do that we want to update, and then here we set the property that we are updating, and after we get our updated to-do, we send it to the client. If there is an error in this process, we call a catch method here. We have access to the error object, and we can send that error message to the client or log it to the console. Now we can test this endpoint using Postman. So I'll come back to Postman. So right here I'll open a new tab and then select patch, and I want this path right here. So I'll copy this path, come back to patch here and paste it here. So we have the ID of our to-do. So I want the body here to be empty, and we won't include any JSON object at our body. So when I come back here to put, what we want to edit is this particular property isComplete. So when we send our patch request here, this isComplete should come back as true. So I'll come back to the patch here and send this request. Okay, and there we go. Now we get our feedback where isComplete is true, and this is the only property that was edited. And if I send this request again, now isComplete is false. So it's like we are checking and unchecking this particular property, and this is so because we only included this property right here. It's the only thing that we are editing. So that's it for this video, and in the next video we'll start talking about authentication and how we can start creating endpoints to handle sign in and sign up. So in the last episode we concluded our CRUD operation endpoints, and we were planning to move on to authentication, but there is something that have come to my attention. So before we move on to authentication, I want us to perform a better error handling. So I deleted all the documents in my MongoDB collection, so we don't have any documents, but I also made sure that I grabbed a valid ID for a certain document. So although I have this ID, there is no document in our MongoDB that have this ID because I deleted it. So if I perform this put request, we should get a to do not found error, which is a 44 error. So I will send this and we get to do not found message. Now what if I supply an invalid ID here? So this is a valid ID even though the document does not exist. What if I just give a particular ID which is not a valid object ID for MongoDB? So we should get a different error and not to do not found error. And let's try this one out. I'll send this, and you'll notice a weird behavior. This process is hanging. We are not properly catching our errors. So if I come to my console, you'll see that unhandled promise rejection, cast error, cast to object ID failed for value, this one. So this is not a valid object ID and we did not properly catch that error. So what we should do is to come back to our endpoints and change how we catch our errors. So let's start with the first endpoint here, which is our get endpoint, and when I check at this, everything is fine. We are properly catching the errors, and for our post request, we are also properly catching the errors. But for our put request here, everything looks fine, but it is not. And that is because of this particular line of code where we are finding a document by ID. So this is an async action and we did not wrap it in a try and catch block. So when it throws an error, it will make our requests to hang and the error will be on the console, but the client won't know what is the problem. So what we should do is to change this try and move it at the top here just before our find by ID. Okay, so I'll paste this one here, and now all our async action, which is find by ID here and find by ID and update, are inside the try block. And then we should do the same for patch and delete. So I'll move this line of code, I'll cut it and paste it here. Actually at the top here, because this is where we are finding by ID. I'll paste and save this file to properly auto format, and then I'll move to the delete and do the same. I'll save, and there we go. And now let's try this one out by sending an invalid ID and see whether our server will stop instead of giving us a response. So I'll come to Postman and send this request one more time. And there we go. Now we are getting an error here, cast to object ID failed, because this is not a valid MongoDB ID and this is an internal server error. So this is now a much better error handling. Instead of sending a request and it hangs, we at least get a message right here. So in the next video, we'll start now talking about authentication. Hey, what's up guys? So in the last couple of videos, we were able to create our CRUD operation endpoints, and in this video, I want us to handle authentication and authorization. So this video will be divided into several sections, and in the first section, we will talk about creating a user model. So the first thing we will do is to create a user model. Once we have a user model, we'll be able to use that model to create new users. So basically we'll be registering the users. So we will create an endpoint to handle sign up, which is registering new users. When registering the user, this is where we expect the user to also create a password, right? So when we are creating this endpoint, we will also talk about hashing the password. So we will hash the password so that it can be stored securely on our database. Okay. Once we have a user in the database, we'll be able to sign in the users. So we'll create an endpoint to sign in the user. And this is where we'll also talk about JWT, standing for JSON Web Tokens, to authenticate the users. And then after this, we'll be able to protect our endpoints. So right here, we'll protect our protect APIs, and we will talk about middleware function in this section. Okay, so we'll create our own middleware and use that middleware to protect our CRUD operations endpoints. So basically this endpoint and this endpoint will be public. Okay, so these two endpoints so these two endpoints will be public, and this one will also be public. Anyone can access the sign up and the sign in, but our CRUD operation endpoints will now be private after we protect them using a middleware function. So when protecting our endpoints, we'll also talk about authorization. So there is a difference between authentication and authorization. So this video will basically have 4 sections, and these are the sections. We will create a user model, we will handle a sign up, we handle sign in, and then we'll protect our APIs. So let's start by creating a user model. I will remove these notes because I don't need them. So to create a user model, we have a models folder which we created earlier in this series. So in this particular folder is where we'll add a new file called user.js, and this is where we will create our user model. So the first thing that we need is to import Mongoose. So right here I'll say const Mongoose will be equal to require Mongoose, and then we'll start by creating a user schema. So const user schema will be equal to new mongoose dot schema. So this is an object coming from this schema class available in our Mongoose module. So remember, we said before that a schema basically represents the structure of our documents. It provides the shape for our documents. So right here, we will invoke this one, and we should include an object here with properties of our user. So the first thing we need for our user is a name, and then we can include different options here. The first thing is that the type of the name should be a string. It should be required, so we set required to true. We can set a min length and a max length. So min length of 3, a max length of 30. And then the next thing is that we will need an email. And for an email, it should be a string, so type of string. It should also be required, so we set required to true. And next thing is that we can set a min length for the email. Min length, we can set it to be 3. We can set a max length also, max length of 200 characters. And then the email should also be unique, so we should not register a user with an email that already exists in the database. So unique should be true. And when I save this, the code will be auto formatted by Prettier. Okay, now the last thing that we need here is the password, name, email, and password. So we should have a password. The password is of type string. It should be required, so we set required to true, and then we can set a min length to be of 3 or rather 6. We need someone to set a strong password, so a min length of 6 and a max length of about 1000 characters, because we'll be hashing the password. If you enter a password which have a plain text of 6 and we hash that password, it will have a lot of characters. Okay, I can set a max length of 1024 characters. So right now we have a schema. Now let's create a model which we will use to create our new users. So right here we'll say a const user. Remember, now this is a class, that's why it starts with a capital letter here. Will be equal to mongoose dot model, and then the first parameter is the name of our collection in the database. Okay, so we want the name of our collection to be users. So right here we usually use user in singular form, and this will be converted to plural in small caps. So this one will be users. Okay, and then the second parameter here is our user schema, so just say user schema. And now we have a user model which we can use to create new users using a name, email, and password. And then we need to export this user model so that we can use it on other files. Okay, so right here, let's just export our user model this way. Exports dot user, and we set this one to user. So I'll spell this one correctly, exports.user, and we set it to user. So this section is done. In the next section, we'll see how we can use this user model to create a new user. Okay. Now in this section, I want us to make use of our user model to register a new user. And to do that, we'll create a new endpoint where we can register a new user. Okay. So I'll come to the routes folder here, and then I'll create a new file, and I'll call this one signup.js. So in this file, I want us to do several things. The first thing that we will do is that we will validate the incoming data from the client using Joy, and then we will check if a user already exists or not. Okay, so does the user exist? We'll check if a user exists. If they does not exist, we will create a new user. So right here we'll create a new user. After creating a new user, we want to take the password and hash that password. Okay, so right here we will do hashing of the password, hash password. And lastly, we'll save the user after we have hashed the password. So right here we will save the user. And before we continue, when hashing the password, we will use a popular library called bcrypt. So this is the library that we will need to hash the password, and we need to install it. So right here, open the terminal and run this command, npm i bcrypt. And this will install bcrypt in our application. But because I have already installed bcrypt, I won't run this command, but for you, you can run this command as we proceed. So I'll just cancel this terminal, but make sure you have installed bcrypt. Now let's start by validating the incoming data using Joy. So the first thing that we will do is to, of course, import Joy to this file. So I'll say const Joy will be equal to require Joy. We will need to use express. So right here, I'll say const express will be equal to require express. And with express, we can create a mini app. So right here, I'll say const router will be equal to express dot router. So this router will act as a mini app, and we can later use it on our index.js file to integrate it with our main app. Okay, let's now create an endpoint here, and this will be a post endpoint. It will be handling post requests because we are creating a new resource. Okay, and we'll use our mini app here. So router.post, the first parameter is the path, and I'll use the root as the path here. And the second parameter will be an async function, which is also a callback function, which have access to request and response. This is also an arrow function, and we can do something in here. And the first thing that we will do is to create a schema, which is a Joy schema, and use that schema to validate the inputs which we are getting from the client. So right here, I'll create a schema. We set this schema to be equal to joy.object. We invoke this method and pass the properties which we are getting from the client in here. And earlier we created a schema using Mongoose in our user file here, and we had 3 properties: name, email, and password. So right here we will have a property called name, and then we can use Joy to validate name. So joy.string, we invoke this one, meaning that this is a string. We want it to have a min length of 3, so we attach the min method here and pass 3 in here. And also we want it to have a max length of 30 characters. We tap a max method, pass 30. We want it to be required, so we tap the required method. The next thing is the email. We want it to be a string, so joy.string. I invoke this method. I want it to have a min of 3. And if you want to know more about Joy, you can check the episode where we talked more about Joy. So right here, I'm just rushing through. Okay, max length of 200, and this is an email, so we tap a method here, email. So this will validate whether the email input is an email, and then we want it to be required. Finally, we have the password. For the password, we want it to be a string. We want it to have a min of 6. We want it to have a max of 200 characters. And also we want it to be required. Now note that this password, we are getting it as a plain text, and that's why we have a max of 200 characters. Later on, we will hash the password using bcrypt, and it will be much longer than 200 characters. And that's why in our user here, where we were creating our user model, we performed a Mongoose validation, and the password was much way longer. Okay, now let's come back here to our signup.js, and we have now created a schema using Joy. Now let's use this schema to validate our inputs, and how we do that is by simply calling the validate method. So schema.validate, and then we invoke it. We get our inputs from request.body, and this will validate those inputs. The response is the value and the error. So if there is an error, the error object will be there, but if there is no error, the error object will be undefined. So how we can get this error object is by destructuring it from the object that we'll be getting here. So we can just say const, we destructure the error from an object containing error and value. We only want the error. We get the error and store it in a constant. Now we can check whether this error exists or not. If it exists, we want to tell the client that an error exists and you should make some changes. So right here, I'll say if error. If this exists, we will return a message to the client, and this process will terminate the other operations in this particular route. Okay, so right here we will say res.status, and the status code for this one is 400, meaning that this is a client error, and then we send a message to the client. Earlier when we were talking about joy, I showed you how we can access the message. So the message is available in the error object, and then the error object have a property called details. So right here we can tap details, and this details is an array containing errors. We will get the first error using 0 here. Okay, so this will get our first object, and then we get the message for that object this way, just like that. Now if this error exists, we will send the error message to the client. So the first thing we have done is validate our data using joy. Now let's check if a user exists. So now I'll scroll right here, and we will use our user model to check if the user exists. So we need to import it at the top here. We need to destructure it from the exports object. So right here we'll say const, we destructure our user from the exports object, and we get this one from our models. So we'll move one level up, access the models folder, and then access the user module, which is our model. Now we are getting this user model in this particular file. Now we can use it to check whether a user exists or not. And how we will do that? We will use the method called findOne, which is available in our model, user.findOne, and we can filter using the email. So right here we can invoke this function and then pass an object to filter the users which we are getting from the database using the email. And since the email is unique, it should tell us whether this user is already registered or not. So right here we'll say email to be equal to request.body.email. And now this request.body.email is the email that we are getting from the client, and we can store this user on a variable. So right here, this process is an async action. It will return a promise, so we can await it and store the response, which is our user, on a variable here. So to create a variable in JavaScript, we use let. So let user be equal to await user.findOne, and we filter the user using the email. Now the reason I have used a variable is because I'll need to reuse this user later. Now we can perform an if statement here. If user is true, that means that this user already exists. If this is null or undefined, that means that the user does not exist. Okay, so if user, we return a message to the client, res.status. So we include a status code of 400, meaning that this is a client error and not a server error. Send we include a custom message here. So user with that email already exists. If there is no user with that given email, we now want to create the user. So now we have checked if a user already exists. Now we want to create a new user. But before we continue, you'll see that this is an async action and errors may occur. So we need to wrap this inside a try and catch block. So what I'll do here is to include try and then move the whole of this code in here. And then we need to call catch here to catch any errors. We have access to error object, and then we can do something in here like send the error to the client or log it to the console. So I'll come to my to-do.js file and I'll copy this from this file. So I'll come back to the sign up file and paste it here. So what is happening is that if there is an error when performing this action, we will send a status code of 500, meaning that this is a server error, and we include the error message, and also we can log that error to the console. So now I'll come to our try block and continue to perform more async action like saving the user to the database and so on. So the first thing that we need to do is to get these properties from the request.body. So I'll just destructure them. I'll say const with destructure name, email, and also we destructure the password. And we are getting this from request.body. Now that we have these ones, we can use them to create a new user. And how we do that is by using our model. So our model is a class, and we can use it as a constructor by including the new keyword. So we can say new user, and when we invoke this one, now this is a constructor for creating a new user. We pass in an object with these properties: name, email, and password, and this will come from request.body. Okay, so what we'll get from this is an object, which is our document or our user. So we can set our user, which was a variable, so we can reassign it to be equal to this particular user. Okay, now this is our new user. Now at this point we have created a user using our model. Okay, now the next step that we need to do is to take the password and hash it. So we are at this point, we have created a user. Now let's hash the password. To hash the password, we need to use our library, which is bcrypt. So let's import it just right here. I'll say const bcrypt will be equal to require bcrypt, just like that. And now we can use bcrypt to hash the password. The first thing that we will do is to generate something we call a salt. And a salt is a string of characters, random string of characters that helps to make our password unique. Right here, I'll say const salt will be equal to, we await, this is an async action, await bcrypt, and then we call this method gen salt, like generate salt. And right here, what we pass in here is the number of characters that we want our string to have, and the default is 10, and that is what we are going to use. So right here, I'll just pass 10. Our salt will have 10 characters. Now the next step is to hash the password, and we use bcrypt.hash method. So right here I'll say bcrypt dot hash. The first parameter is the password that we want to hash, and this is our user object, and it has a property called password. So we can access that property just like this, user.password, and then we pass the second parameter as this salt, and this is an async action, so we can await it. and set our user.password to be equal to this hashed password. So what will be returned here is a long string of characters, which is our hashed password. So we can change user.password to be our hashed password. Okay. The next step is to save the user to the database. So this is simple. We will take our user object, which have name, email, and the hashed password. So we'll say user.save, just like that. But this is an async action, so we can await it. So right now we'll not be sending anything to the client. What we'll be sending is just a simple message that the user have been created. Later on we'll come back to this and logging the user once they register. So we'll be sending back a token with user details to the client. Okay, so right here what I can say is res.send and just a message user created, just like that. And now we have completed our steps. We have validated the data using Joy. We have checked if the user exists or not. If they does not exist, we have created a new user. After creating the user, we get the password and hash it and then save the user to the database. And then what we are sending back is just a message that this user have been created. But later on, we'll be sending back a token which will contain our user details. Okay. So the next step we need to do is to export this module. So just right here we need to export it. So module dot export, and what we will export is our router, and the router is a mini app which we created using Express, and this mini app will give us access to our endpoint. So right here I'll just delete all these notes so that we can have a clean file here. And then if I save this file, it will be auto formatted by Prettier, so my code becomes more readable. And we need to import this module to index.js. So what we will do is that we need to import sign up module, just like this. Now we have access to this sign up, and then the next step is to use app.use, because now our router, which is the mini app, acts as a middleware, and we pass in the path which we want to access our endpoint, and then we include our import, which is sign up, this one. So now we can test this using Postman. So what we'll do is that I'll come to Postman, I click on a new tab here, and what we want to do is to perform a post request. Okay, so our endpoint is using post to create a new resource, which is our user. So right here we'll change this to post, and then right here we access our endpoint, which will be available in http :/localhost 5000, and then a slash, we access it through API stroke sign up. And then we need to come to the body of the request. We select row, we include this as a JSON object. So right here we can enter the properties. The first one is the name, and the name should be not less than 3. So right here I'll say Chaoo. Then we get an email here. The email should be a valid email, so chaoo at gmail.com, and then we include a password, and the password I'll just include a test password, which should not be less than 6 characters, so test 987. So this is the user which we want to create. Let's make sure that our server is running, and it's running. Now let me send this request. So if I send, we should get a message of user was created. Send. So I am getting an error. Our request is hanging, and this is a joy error, unhandled promise rejection, type error, joy.string is not a function. So let me check on this. I'll come back to my text editor and come to sign up, and I think this is the error. Email, we include a minimum of 3 instead of this should be required. So make sure this is required, this is correct. I'll wait for this to restart. Now I'll send it again, and user created. Now perfect, we don't have any error, and the user should be created. So if I go to MongoDB and check for the user, I should see a new collection of users with these details. Now to test this, whether the user was created or not, we can test it, and it should give us an error of user already exists, okay, because we are sending the same email. So I'll send this one again just to check whether our validation works. I'll send. User with that email already exists, so validation is working. We can try to send an invalid email without an @ here and see if the email validation works. I'll send. Email must be a valid email. Perfect. So joy validation is working. Now let's check if the user was actually created. So I'll come to MongoDB, and then right here I'll need to refresh this page, because right now we only have to do correction, we don't have users correction. I'll come here and click refresh, and now you can see that a new correction was added of users. If I click on users collection, we should have at least one document, and this is the document where we created a new user with this name. This is the email, and then you can see our password is hashed. It is not the plain text password that we entered, and it is a very long string. Okay, now in the next section we'll see how we can create an endpoint to handle sign in, and we'll see how we can compare this password with the password that we will be getting from the client. So now we have already created an endpoint to register new users, and in this section I want us to create another endpoint to now sign in the users. So in our routes folder here, I'll add a new file called sign in, just like that, and I include Node.js. Now in this file we are going to do several things. The first thing is that we will use joy to validate the inputs, and then if the inputs are valid, we will get our user from the database, and what we will be doing there is checking whether the user exists. Okay, so does the user exist? And then if the user exists, we will validate the password using bcrypt. So we have a method called compare in bcrypt, which will help us to compare the plaintext password and the hashed password which is available in the database. So right here we will validate password. After validating the password, we will then generate a JSON web token, JWT. Okay, we'll generate a token and then send it to the client. Send to client, and by sending the token to the client, it simply means that the client is now logged in. This is what we'll be doing in this particular section or this particular file. So first things first, let's import all the dependencies we need. So I'll come here to sign up, and we need to import joy, bcrypt, express, and also our user model. We'll also create a mini app which will help us to create our endpoint, and we'll also import JWT in our sign-in file. So right here I'll just copy all this and then come back here and paste it. So now we are importing all this, and then we'll also need to import JWT. And what you need to do first is to install a JSON Web Token module. So at our terminal here, you need to run this command npm I JSON Web Token to install this module. And I have already done this, so I won't be repeating it. So make sure you install JSON Web Token. I'll just close this one, and then I'll import JSON Web Token just like this. So const JWT, which is a shortcut for JSON Web Token, and we require JSON Web Token just like that. Now we'll be able to use JWT in this file. The first thing we will do is to validate our data using Joy. I'll create a new endpoint, so router.post, and then the first parameter is the path, and the second parameter is an async function, which is also our callback function. And we have access to request and response, and this will be an arrow function. So by now I expect that you are used to this. Now in here we can create a schema and return an error to the client. So instead of doing everything from scratch, I'll come to sign up and I'll copy all this where we are creating a schema and sending an error to the client. So I'll copy that and paste it here. But when signing in, we don't need a name, we only need an email and a password. And since we are not saving this data to the database, our Mongoose schema won't complain that we don't have a name, so don't worry about that. So now we are validating the email and password using Joy. Now let's check whether the user exists or not. And how we do that is by simply using this line of code. So I'll copy all this again, come back to sign in, and I'll use a try and catch block just as we did in sign up. So I'll say try and paste this one in here. Now the difference between this check and the one that we had in sign up is that here we want a user to exist. Okay, we want a user to be in the database before we allow them to the system. But in sign up, we don't want a user in the database. We want a different kind of a user to be registered. Okay, so we won't be returning this message, we are getting a user. If a user does not exist, okay, we want to send an error. We want to tell the client that, oops, this user does not exist and you need to register this user. Okay, so right here we'll send a different kind of message, maybe user with a given email does not exist. Or you can use a different kind of a message which is more vague. Okay, the person signing in should be aware whether they are using the correct credentials or not. So you can send a vague message here like invalid email or password. So we don't want to specify which field is wrong. They should figure out that by themselves. The next thing, if this user exists, we will move on to validating the password, and we will use bcrypt for this. And right here, we should have a catch method which have access to error, and we display the message right here. So I'll just come to sign up, scroll at the very bottom and copy this, come back to sign in and include these messages here. Now let's use bcrypt to compare the password. We have a method called compare which is in our bcrypt module. So bcrypt.compare, and this method will accept the first parameter as our plain text password, which we are getting directly from the client. So right here I'll say request.body.password, and then the second parameter is the password which already exists in the database in user.password. Now this is an async action which will return a promise. We can await it and store the results in a constant. So maybe I can say const varied password, and this is const and should be equal to await bcrypt. This is the password you are getting as plain text, and this is the password that is available in our database. Now this valid password should be either true or false. So if this password is correct, this will be true. If it's wrong, this will be false. Now we can perform another if statement. So I'll minimize this one so that we get an extra space here. And we should say if we use a not operator, valid password. If this password is not valid, what we want to do is to send an error to the client, and we will send this exact message: invalid email or password. We just don't want to specify which is which. Okay, so I can just paste this one here, and if I save, Prettier should auto format this file for me, and it doesn't, meaning that we have an issue. This one I'll save, and there we go. Now which point are we at? When I come here, we have used joy, we have checked whether the user exists, we have checked whether the password is valid. Now we should simply log in the client by generating a token and sending it to the client. So let me include some spacing for this one for much better readability. So right here, we should generate a token, and we will be using JWT. We have already imported it at the top. This is how we imported JSON Web Token. Now we can use this JWT to create a new token. How we create a new token is by using a method available in JWT called sign. And this sign accepts the first parameter as the payload. Okay, and this is the data that we may want our token to have at the payload, and I want the token to have a UID, so I'll include an ID here, and this will be coming from user._id. When we create a new user using our sign up endpoint, an ID was auto-generated by MongoDB, and this is now the ID of that user. And then we will want the name of this user, which will be available in user.name. And remember that this user object is the one that we got from this line of code. Find one, and we used email to filter that user. Okay, so this is name, and then I want an email to be user.email, but we don't want to send the password to the client, so we'll only include the name, email, and the ID. So this is the first parameter, which is the payload of our token. And then the second parameter should be a secret key, which makes our token to be more secure. And we should store this secret key in an environment variable. So earlier we talked about environment variables, and we store them in a .env file. So I'll come to the .env file and add another environment variable just right here. And I'll call this one secret underscore key. And you can set this one to be a string of characters, any string of characters. And we should not actually include the quotes. So this can be anything. And then we can read this secret key from our environment variable using the global object, which is process. So right here, I will store our secret key in a constant. So I'll say secret will be equal to, we use our global object process, which have access to .env, and we can read our environment variable right here. So it should be the same. I'll just copy this secret key, and then come to sign in and paste it here. Now we have our secret key available in this constant, and that is the second parameter that we should pass here. Now we are using a sign method which is available in JWT. The first parameter is the payload. The second parameter is a secret key which we are storing in an environment variable which should be more secure. So our .env file should never be available in GitHub or public place. It should only be available in the server. And what we will get from this is a JWT token. So we can store the response in a constant. So const token will be equal to this. And then the next step is to send this token to the client. So res.send and token. So we are sending the token to the client, and that means that now the user have signed in, because we will use this token to secure the routes, to allow access to certain features and deny access to certain features. Now the next thing that we need to do is to simply export this endpoint just like this. I'll come at the bottom here, say module dot exports will be equal to our mini app, which is router. And this is how we simply sign in a user. Okay, now I'll save this file to auto format everything and come back here at the top and delete these notes now that we are done with them. The next thing is that we need to be able to read this file, and we will do that by going to our index.js file, and then I'll just duplicate this line and include sign in. By now you know what this one means, and then right here is sign in, and we should import it right here. I'll just duplicate this, change this one to sign in and this one to sign in. Now we should be able to sign in a user using this endpoint. Now let's go to Postman and test our endpoint. I'll come back to Postman here and change the path here from sign up to sign in. So sign in, and then the body of the request should have only an email and a password, and this should be a valid email which already exists in the database, and then the password is that one. And now our response should be a JSON web token. So I'll send this, and yeah, perfect. We are getting a very long string here, which is our JWT, and you can see it have 3 sections. I'll copy it. In my web here, I'll go to JSON web token website, which is jwt.io, and I'll scroll at the bottom, and what I'll do is to decode this token. So I'll select all this and delete, and then paste the token which I copied from Postman. And now when you come here, the first section of our token in red is the header, which contains the type of algorithm that was used, and then the second section is the payload, and you can see the payload. Now we have an ID of the user, we have a name and an email, so perfect. And then the other is a timestamp of when this token was generated, and finally we have a signature which makes our token to be more secure, and this came from our header, our payload, and also our secret key. So we are now signing in the user, and we can use this token on the front end to allow access to certain features and so on and so forth, and we can decode the token to read this data to know the currently logged in user. Now that is how we handle sign in. And I want us, when we register a user, we also sign them in automatically. And how we can do that is to simply generate a token and send it to the client once we save the user to the database. So this way, I'll just come to sign in, and I'll copy the last 3 lines right here where we have a secret key. We generate the token and send the token to the client. So I'll copy this, come back to sign up and paste it just right here. And then I'll come back to sign in, scroll at the very top, and I'll copy this module where we are importing it, JSON web token, come back here and also import it right here. Now, when we sign up a user, we should save the user to the database and also generate a token. And this user here is available where we were finding a user by email right here. So we should get their ID, name, and email. So I'll come back to Postman and test whether we will get a token when registering a user. So right here, I'll change this one to sign up. And then when signing up, we should have a name. And right now, I can include the full name here, Chaoo Charles. And then for the email, we should send a different email. So I'll change the email to 2 and include a comma. Now this is the body of the request. This is the endpoint and it's a post request. Now we should get a token back and the user should be saved to the database. I will send, and we are getting back a token. When I copy this, go to JWT, select this, delete, and paste this one. You'll see now we are getting Chaoo Charles at our payload and Chaoo 2 as the email. So we are now signing in the user by generating a token and sending it to the client. And when I come to database and refresh, we should have this user available in the database. So I will come and find the refresh button right here. Refresh. And in our users, we now have 2 users. And this is the one that we just created. Now that's it for this section. In the next section, we will see how we can protect our endpoints. So far, we can register a user and also we can sign in the users. Now in this section, I want us to protect our to-dos APIs or endpoints so that a user may not be able to delete a to-do or create a new to-do and perform other operations if they are not logged in. So how we will do that is by using a middleware function. So I'll come at the root of the application here and create a new folder, and I'll call this folder middleware. So this is where we will store all our middleware function, and in this case we want to create a middleware function for making sure that a user is authenticated before performing a certain operation on our to-dos. So right here I'll add a new file called auth.js, and then inside this file we'll have several steps. The first thing that we will do, we'll simply create a function, and this function is our middleware function. And then we will check whether user is logged in by checking whether a token exists. So does the token exist? If the token exists, we will verify the token. So verify the token. If it is valid, we will pass functionality to the next middleware function using the next method. Okay, so these are the 4 steps that we are going to perform, and let's start by creating a function. So right here we'll use the keyword function and the name of the function, and I'll call our function auth, and it have access to request, response, and also next. Now this is our middleware function, and a middleware function is simply a function which have access to request, response, and next. So they can manipulate the body of the request, they can send a response to the client, and they can pass functionality to the next middleware function. Okay. Now, right here, we will check whether a token exists, and how we will do that is by reading the header of our request. So when sending a request, we will include a key and a value, where the key is like a variable of the token and the value is the token itself, and this will be at the header of the request. So we can read the token from the header of the request and store it on a constant. So right here, I'll simply say const token will be equal to a request dot header, and then we will have a key called x of token. Now this is a key and it will have a value which is the token. If it doesn't, our token here will be either null or undefined. Now we can use this token to check whether it exists or not by using the if statement here. So if token does not exist, not token, we will return an error to the client. So return res.status, and we will use the status code of 41, meaning that they are not authorized to perform this request. So right here, I'll say 41, and then we can send a message to the client, not authorized. And you can send your own custom message here. So we have performed this second step where we are checking whether a token exists, and the token will be available at the headers of our request. Now the next step, if this token exists, we need to verify the token, and to verify the token we need to use JSON web token module. So let's import JSON web token to this file just like this. So we'll say const jwt will be equal to require JSON web token, and then we can use this jwt to verify our token. So right here, I'll use a try and catch block. So how we verify the token is by using the verify method available in jwt. So we'll say jwt.verify, and then it have two parameters. The first parameter is our token, and then the second parameter is the secret key, which we included in our environment variable, this one. Okay, so I'll come back to auth, and we need to read this secret key from this environment variable. So I'll come and create a new constant here, or rather go to sign in and copy this line, okay, where we have secret key is equals to process.env.secret key, and that will give us our secret key. So I'll just copy that, reading secret key from the environment variable, and include it here, just like that. Now this method will return the payload of our token if the token is valid. We'll store this one in a constant, and we can call this payload. And now we can attach this payload to our request. Okay, so I'll say request.user will be equal to payload. Now our payload contains the details of our user, because remember when we are signing in a user right here, we included this data in the payload. So our payload will have the ID, the name, and the email, and that basically represents our user. So we can attach an object to our request called user and set it to be our payload. And then after this, it means that we have successfully verified this token, and we can pass functionality to our next middleware function, just like that. Now, if this process fails, it means that that token is not valid, and we can use a catch block here to catch the error. So we have access to the error object, and we can send a message to the client, res.status, and I'll use the status code of 400, meaning this is a bad request, and then .send, and you send a message here, maybe invalid token. So now we are successfully checking whether a token exists and also verifying that token. If it is valid, we pass functionality to the next middleware function, and if it is not valid, we send an error. Okay, and we are also attaching our payload data to a user object right here. Now the next thing that we need to do is to export this middleware function so that we can use it on our to-dos file. So I'll just remove these notes, and then I'll export this function at the bottom here using module.exports will be equal to auth. Now we can import our auth middleware function in our todos.js file. I'll come to todo.js, scroll at the top, and I can import it at the top here. So I'll say const auth will be equal to require one step upwards, and then access the middleware folder, and then we access our auth file. Now once we import this auth, remember it's our function, our middleware function, we can use it on our endpoints. And how we will do that is by including it as a parameter at our get method here or post method in any of these CRUD operation methods. So the first parameter will be the path, the second parameter will be our middleware function. So our middleware function is executed before this callback function, and once it's executed, all this process must be valid. So we must have a token, the token must be valid, and then we pass functionality to the next middleware function, which is now our callback function, right here. If that process fails, it means that we won't proceed to getting our to-dos. Now we can test this using Postman. So I'll come to my command prompt here to make sure that server is running, and then open Postman. So the first thing that we need to have is a valid JSON web token, and we'll get that by logging in a user. So I'll perform a post request to localhost 5000 API sign in to log in a user, and then at the body of the request we will have an email which is registered already and a password which is valid, and then I'll send this request. So send, and we get a token as the response here. I'll copy this token, and we need to perform a get request to this endpoint, this one here, where we have included auth middleware function here, and see whether we will be able to access the data. Okay, so back to Postman, I will perform a get request, and we don't need anything at the body of the request, so you can ignore this or delete everything if you have anything here. And when you check at the headers here, you'll see we have key value of our headers, and it's currently empty. So when we perform this request, we should get an error because we are not authorized. Let's see. I'll send this request, and not authorized message comes in, and this is from our middleware function, so it means that it's working. Now we can set a key here, and remember we gave a key of X auth token, and the value is our token, what we just copied. Okay, so I'll paste it here, and when I perform this request, we should now get our to-dos. I will send, and perfect, we are getting an empty array. This means that we don't have to-dos currently at our database, but we are getting back something. So our token is valid. But what if I mess up with this token? Like maybe I remove the 5 and replace it with another digit. So this is not a valid token. So I will send, and we should get a different error. Invalid token. So our middleware function is working. So that is how we protect our routes. We just include this middleware function with every request. But for now, I want these routes to remain public so that we can first work on our front end, and when we get to working with authentication and authorization on the front end, we will come back and protect our routes, and we will perform a further authorization so that users only get the to-dos that they themselves have created, and also post the to-dos and edit or delete to-dos that they themselves have created and not other people's to-do. And we have access to our user right now in our request. Okay, so right here we can maybe log the request to the console, just like this. So we can say console.log and then request.user, and this is the user that we attached to our request at the auth middleware as payload. So if I log the user to the console, just like this, request.user, we should get that data. Okay, now let's try this one out, and I'll come to Postman, and then we should have a valid token for this to work. So I will revert this where we had a 5 and it have disappeared, so I'll paste it again. Yep, now we should get a user at our console, but here we should get an empty array. I will send, so we are getting an empty array. Let's check our console, and we are getting our payload ID, name, email, and when the token was created. So we will have access to the user ID, and when creating each to do, we'll also attach a user ID. So we'll be able to perform a check whether those IDs are equal, and then perform further authorization. So that's it for this video, and in the next video we'll start now checking at React, Redux, and also Material UI. Hey, what's up guys? So far so good. We have created most of our backend, where we created the CRUD operation API endpoints and the Auth API endpoints. And in this video, I want us to move on to the front end. So if you haven't watched some of the previous videos in this particular playlist, I recommend you do so that you can see how we created our backend using Node.js, Express, and MongoDB. I'll leave a link at the description section below to that particular playlist. So on the front end, we will be working with React. So what is React? React is a very popular JavaScript library which was created by Facebook for building user interfaces. And React is component based, so we'll be creating several components and then composing them to make more complex UIs. And it is also declarative. And what we mean by declarative is that when a particular piece of state changes in our application, React will efficiently update and render just the right components which were affected by that particular piece of state. So React won't re-render the whole application, but certain parts of the application which were affected by that particular piece of state. And then React can be used on mobile applications, so you can create mobile apps, that is iOS and Android apps, using React Native. So you can take your skills to the next level by learning React Native and start creating awesome mobile applications using React. So in our definition here, I want you to pay close attention to some keywords. The first one is library, and the other one is user interfaces. So React is a library and not a framework. The difference between a library and a framework is that a framework comes as a whole package for creating complex applications, but React is just a library for creating user interfaces. So React won't handle other parts of our application, e.g. routing or performing network requests. So for that, we'll need to depend on third-party libraries. For routing, we'll be using React Router. And what React Router does is to give us a multi-page feeling in our single-page React application. So with React, we only have one HTML page, that is index.html page, and we inject the whole application in that particular one page. But with the traditional websites, we usually have multiple HTML pages. We have an index.html page, which is mostly the home page. We have the about.html, contact.html, services.html, and we have a lot of HTML pages in the traditional websites. But with our React app, this is a single page web application. That means that we have only one HTML page, and then we will use React Router to bring the multi-page feeling in our application. And then for network requests, we'll be using Axios, which is another very popular JavaScript library. As you can see, we have more than 16 million downloads within the last week. So Axios is a very popular library for performing network requests. We'll be able to perform the post request, get, and all those CRUD operation requests to our backend. And then for our components, we'll be making use of Material UI. So we won't be styling our components from scratch. We'll be using Material UI. It provides React components for faster and easier web development. And for state management, we'll be making use of Redux. So Redux gives us what we call a global state. So we'll have a Redux store which will contain our application state, and we can access this state from any other component instead of passing state via props, which is a much tedious way of doing things in React. So we'll be making use of Redux, and the good thing is that now in Redux we have hooks. So we'll be using hooks instead of using the traditional connect higher order component and map state to props at the bottom of our components. So traditionally we used to use the connect higher order component and do some crazy stuff at the bottom of the component in order to get our state and map it to props in that particular component. But in this case, we'll be doing things in a much easier way, so you don't need to fear Redux. We have a hook called use selector, which will select a piece of state from the store, and we can easily use it in a particular component. One last thing is that you'll need to have Node.js installed in your machine. So make sure Node.js is installed, which I assume you already have it installed because we have been working with the Node in this particular playlist from the start. So I just expect you to have it installed in your machine. Now, how do we create a React app? To create a React app, I'll just get out of this browser and I'll open this folder which I created when we were starting this series. And inside this folder, we created two folders, the backend folder and the frontend folder. On our backend is where we created our API endpoints, connected to the database, used the .env file for environment variables, and did all the fun stuff on the backend. But this time round, we'll be working on our front end. So what I want us to do is to open this folder on CMD. So I'll just type CMD here, and then I'll open the entire folder on Visual Studio Code. So I'll use code and a period. This will open the entire folder on Visual Studio Code. And once it opens, what we will be doing is that we will be running our backend server on this command prompt. And what you'll do is to just type cd and then the name of our backend folder, which is backend. This is where our server is located, and this should take us to that path, and we will run our backend using NodeMon. So this is how we run our server. and we'll be able now to connect to our server and do all the fun stuff with it. But for now, because we haven't reached the point where we are performing CRUD operations on our front end, we can leave this one out, but this is what we'll be doing later on in this particular series. Okay, so I'll just minimize this. I won't run it because we don't need it for now. But in our Visual Studio Code, I want us to work with our front end. So click at the terminal at the very top and then create a new terminal, and this kind of a terminal will open up on VS Code. And what we want to do is to enter into the front end folder using cd and then front end. And we want to create our React app in this particular folder. And how we create a React app is by using npx and then create a -react-app. And then at the end here, we usually place the name of our React app, and that creates a complete new folder in here with our React app. But I don't want any other folder inside the front end where we have our React app. I want our React app to be generated just inside our front end folder. So I'll just use a period, and the React app should be generated inside this particular folder. So for me, I have already done this. Okay, I have already created a React app inside the front end folder. So if I extend it, this is what was generated by running this command. So I want you to do this so that you can create a React app. And then after creating the React app, how you can start it is by using npm start. So when you press enter, this should start our React app on the browser. Okay, so after a few minutes, your React app will automatically open on the browser, and it is running on localhost 3000. So remember, our server will be running on localhost 5000. So once the React app completely loads, you'll get such an output, which is a template for us to get started with. So when I come back, you can see our React app is running on localhost 3000, and in the next video is when we'll start looking at these other files that are in here. We have a public folder with all these files, we have an SRC folder with all these files, and then we have the node modules, and that's why you need to have Node.js installed for you to work with React. And then when I open app.js here, this is what is included in our application, where we have the React logo and then edit and save to reload. So if I check here at the browser, you can see edit src app.js and save to reload. So we'll start working with all these files in the next video. This was just a kind of an introductory video to our front end, and from here on we'll now be able to move to more fun stuff. So I'll see you next. So in the last episode, we were able to create React app, and in this episode I want us to register the different routes that we'll be needing in our application. So before we do that, I want us to take a look at the different files that we have right here, and we can start with the public folder. And inside the public folder, you'll see that we have an index.html file, and this is the only HTML file that we'll be having in this application. And this is where you can change like the title of our app. Just right here, you can change React app to maybe to do app, and then you can define the different meta tags for the application for SEO purposes. You can also change the favicon just right here, or you can just change it from the public folder where we have a favicon.icon. And then when you scroll at the bottom here, you'll see that we have a div with an ID of root. And this is where our React app will be rendered so that the whole application appears as a single page application. So when we go to our SRC folder and check the index.html file, you'll see that we have an object called React DOM, and we have a render method where we are rendering our app inside the root. And this root is the one that is just right here in our HTML file. So we have a div with an ID of root. So from the index.html file, you can remove some of these files because we don't need them. For example, most of the styling we will be depending on material UI component. So I'll just remove the index.css file and also delete it from our SRC folder here. And then when you move to the app.js file, which is a component imported in our index.js file so that it can be rendered at the root of our application, you'll see that we also have some files that we won't be needing. For example, we don't need to have the logo here. I'll just remove it. We also don't need to have the app.css file, so I'll also remove this one and I'll delete them from the SRC folder. So the app.css and also logo.svg. And then I want us to create our different components which we will style later, but for now we'll be using them to register our different routes. So in my SRC folder, I'll create a new folder called components. And then inside this folder, we'll also have several folders. The first one is the auth folder. So in here, we'll have the sign-in component and the sign-up component. And then we will have the navbar. So I'll create a folder called navbar. And then the last folder will contain our to-dos file. So right here, I'll also create another folder called to-dos. And we can start with our auth folder here. I'll create a new file inside the auth folder called signin.jsx. And you can see the convention that I am using here. The file for this component starts with a capital letter, but for our folders, we are starting with small letters. And I am using JSX because this is a syntax which looks more like HTML, which we'll be using in React. And then now to create this component, I'll be making use of an extension which is available in VS Code called Simple React Snippets. So if I come to the extensions here and then search for Simple React Snippets, this is the extension that I'll be using, and it will make my work much easier when creating the different components. So if I scroll at the bottom here, these are the shortcuts that I'll be using. There is IMR, meaning import React, and then there is SFC for creating a stateless functional component. And if you are creating class components, you can use CC, and you can also use any of these shortcuts if you want. But mostly I'll be using SFC and IMR. So I'll come back to the sign-in component and I'll import React in this file using IMR. And then I'll create a stateless functional component using SFC. And the name of our component will be sign-in. And inside the return, I'll just include a React fragment and return a simple H2, but later we'll come back here and create a form for signing in the users. So right here I'll just say H2, and I'll just say sign in so that we can know that this is the sign in component. Okay, and then I'll copy this content of our sign in component, and I'll go back to our auth folder and create a new file, and now this will be sign up, and I'll paste what we had in sign in. Okay, so this is supposed to be sign up.jsx, so I'll add .jsx, and then I'll change now the sign in here to sign up. So you can select the sign in and then use Ctrl D, and you can edit multiple times here. Sign up. Now we already have our sign in component and sign up component. Let's go to the navbar and create a new file called navbar.jsx, and in here we'll have the navbar component. So similarly, I'll select this, use Ctrl D, and I can replace sign in with navbar. And then now we can go to our to-dos, and I'll create a to-dos.jsx file. And in here I'll paste this content and replace sign in with to-dos. So later we'll be having more files in our to-dos, e.g. a file for adding a new to-do or listing the to-dos, and linking those files or components to these to-dos. So this will be like the root of our to-dos. But for now, this will be good enough for registering our routes. Now, to register our routes, we need to import a new module or a new library, which is React Router DOM. And first of all, we'll install it. Just open a new terminal, because the terminal that we already have here is running our development server. So open a new terminal, and then inside this new terminal, you'll just say npm I for install, and then react hyphen router hyphen DOM, and this should install React Router DOM in our application so that we can create our different routes. So press enter, and when I come back to my first terminal here, you'll see that we have an error in our app.js line 6. So I'll go to app.js, and this error is coming because we already removed our logo, but we are trying to display it in our application. So what I'll do, I'll just remove everything from in here so that we remain with a div with a class of app. Actually, I'll also remove this class name, and then I can just display a h2, and I'll just say to do app, and then at the top I'll also import React in this file using imr, just like that. Now let's check whether our React Router DOM was successfully installed, and it's still loading, but as it installs, we can import different components from React Router DOM. So in our app.js, I'll just say import, and we destructure the browser router, which is a component coming from React Router DOM. And then we will have a route component for registering the different routes. And finally, we'll also have a switch component, and I'll show you why we need this component in this particular file. So switch, and all this will be coming from React hyphen router DOM. And then we need to import our different components from the other files. We will import the sign-in component because we'll have a sign-in route. We'll also import the sign-up component, the navbar, and our to-dos component. So at the top here, I'll just say import to-dos, and this will be from components stroke to-dos stroke to-dos. And then we will import our sign-in component, and this will be from components stroke auth stroke sign-in. This is import, and then I will duplicate this so that we can replace sign-in with sign-up. Let's also import our navbar from components stroke navbar, and then stroke navbar. So now we are importing all the components that we need in this particular file. And as you can see now, our React Router DOM have successfully installed. So I'll just minimize this one. And then we need to wrap everything that is inside our application with this browser router. And this will give every component in our application access to the history object so that we can be able to navigate between the different components. So I'll replace this div with just a React fragment, and then I'll remove this h2 and replace it with the browser router component, which we are getting from React Router DOM. So browser router, and then in here is where we are going to register our different routes. So the navbar should be accessible from every route. So at the very top, I'll include our navbar component, just like this. And then I will use now the route component to register the different routes. So right here, I'll say route, and the first prop for our route component is usually the path. So we can define the path for this particular route. So here the path will be equal to sign in. So I'll include stroke sign in, and then the second prop will be component. And at the component, we will load our sign-in component. So component will be equal to sign-in. So when we navigate to our sign-in path here, we should load the sign-in component. I'll duplicate this and I'll change this sign-in to sign-up, and the sign-in component here to sign-up component. I'll change our Rust route path to be the root, and then the component that will be loaded here is our to-dos component. Now when I go to the browser, you will see that at our root localhost 3000, we are loading the navbar, and also we are loading our to-dos component. So navbar will be accessible from any route because we included it at the very top. We didn't specify any path for our navbar. And then if we try to go to the sign up, so right here we can try to access our sign up. Now you'll see that we have the navbar, we have the sign up, but we are also loading our to-dos component here. So this is a weird behavior. We shouldn't have this to-dos component, but at least our sign up is loading. Let's try to load the sign in here by changing the path to sign in. Now we have the navbar, the sign in, and also we have a to-dos component being loaded. So this behavior is happening because the algorithm that is used to map our path will try to check all the paths, and if any of these paths are matching that particular path which we are loading, all those components will be loaded. For example, what I mean is that when we try to load our sign-in path, our algorithm will also check the sign up, and also it will check this path right here. And you'll see that at the beginning of the sign-in we have a slash, which is our last path. So this to-dos component will be loaded because it is matching this particular path, and then our sign-in component will also be loaded because it is matching this path. So we will load both the sign-in and our to-dos component. Now, to prevent this behavior, we either use the exact prop. So in our to-dos component here, we can use the exact prop, and this will only load if the path is matching exactly this path. So if we have the sign-in, this path won't load our to-dos component because in front of our slash we also have sign-in. So this path is not exactly this one. Okay, so this is one way that you can do this. And when we come to our browser, you will see that we are on our sign up path, but our to-dos is no longer being loaded. And when we try to access the sign-in path, you'll see that our to-dos is no longer loaded because this path is not exactly this one, our home page. So if I try to load the home, you'll see now that our to-dos is loaded. Another way you can do this is by using our switch component. So the switch component will load the first matching path. So if this path matches with what we have at our URL, this component will be loaded and the rest will be ignored. So if I remove the exact prop here and wrap our routes inside the switch component, so switch, and I'll then move these routes inside the switch, each path will be loaded at a time. If it finds the first match, the other paths will be ignored. So let's try to load the sign-in. In our browser, I'll come to the sign-in right here, and you'll see that we have the navbar and the sign-in, so our to-dos is not loaded. So this is the one that I'll stick with right here. Okay, and this is how we register our routes using React Router DOM. Later on, we will be making more use of our React Router DOM, e.g. working with the links and so on and so forth. For example, on our navbar, we will have different links to navigate to this particular routes. For example, when we click on a link, we go to sign in, to sign up, or in to-dos. But for now, this is good enough, and in the next video, we will start going to the individual components and styling them further using Material UI. For example, we'll create the forms for sign in, for sign up, we'll create our navbar, and also we'll design our to-dos, how they will appear, and we'll also include a form for adding our to-dos. So this is it for this video, and I'll see you next. Hey, what's up guys? So in the last episode, we were able to register our different routes using React Router DOM, And in this episode, I want us to style our UI using Material UI components. So this is what we currently have, but we want to achieve a design just like this one, where we will have a top navbar with the name of our app, some details, and some buttons on the other side. And then we'll have an input field for a new to-do, and the to-dos will be displayed at the bottom. Each to-do will have some action buttons on each side, and then we'll also have the sign in and the sign up forms. Okay, so I want us to start by creating this top navbar. Okay, and to create this top navbar, we will need to install Material UI in our React app. To install Material UI, you can visit material-ui.com, and then when you scroll at the bottom here, you'll see some instructions on how you can install Material UI and usage instructions. So this is the command that you need to use to install Material UI. So just copy this, and then when you go to your code editor, you can open a new terminal, new, and a terminal will open at the bottom here. And then just paste that command right here and press enter to install Material UI in your application. So I have already run this command, so I won't do it again. And to confirm it's available in our app, you can go to package.json and check on the dependencies right here. Okay, so make sure you install Material UI, and then I'll move to the navbar component. Inside our navbar folder here, go to navbar component, and this is where we want to create our navbar. So we need to import several components from Material UI library, just like this. Import. The first component will be app bar, and then we will have typography for the text, and then we will have toolbar. So I'll show you why we need toolbar component in this component, and then we'll have a button for all our buttons in this particular navbar. Okay, and then this will come from Material UI library. So from Material UI, and then stroke core. And then we'll also need a hook from Material UI called make styles, and this will help us to create some custom CSS styles. So we won't use a lot of CSS style because most of these components have already been styled by the Material UI team. So this is just for simple custom styles. Okay, and this will come from Material UI core, and then we have a module called styles, just like that. Now with this two, we will be able to create our navbar. So let's come at the very bottom where we have our h2 and remove it. And we want to use our app bar component right here. So app bar. And then inside here, we will use our typography component. Typography. And inside the typography is where we can enter the title of our to-do app. So I can say to-do app, some fancy camel casing here, just like that. And with typography, we should specify the type of text that we are entering here using a prop called variant. So right here we have a prop called variant, and with this you can specify whether this text is a heading, a paragraph, a body, and so on. Okay, for this case I want it to be a h4, and if you get confused with any of this, you should check the Material UI documentation, and I should spell this one correctly, variant. Okay, we can check what we have at the moment. Okay, so I'll remove this one. This import, I think it was automatically imported, but we don't need it here. So I'll go back to the browser, go to the to-do app, and you can see we have something that is failing here, no such file or directory. So one thing that might cause this is that Material UI in my application was not properly installed. So for me, I'll reinstall Material UI library and I'll see if this error disappears. So I didn't touch the code, I reinstalled Material UI and restarted my server. So this is what we currently have, the to-do app, and this is our app bar component. And now when we come back, we can add a prop to the app bar, and that is the position prop. I want this one to be static, so I'll set it to static. And you can change the colors for your app bar using the color prop here. And the primary color is that blue color, but you can also set it to secondary color, which is I think reddish. Yeah, there you go. So the secondary color is this reddish color, and you can check on colors on the Material UI library, so there are other options you can use. So I'll go with the default, so I won't specify the color here. And then I want, when we click this to do app, I want it to take us to the home page. So this will act like a link, okay? And to do that, we will use the link component from React Router DOM. So I can just import it at the top. So I'll say import link, and this will be from React Router DOM. And then at the bottom here, we should wrap our to-do app inside the link component. So I can say link, and then we take a to-do app in here, and we have a prop called to, okay, in this component, and we can enter the path where we want this to take us to. So this is the root path, and this path must be defined in our routes here. So it will take us to this path, which is our home page. Now when we check this, you'll see that the styling for the to-do app have changed to an anchor tag. So you'll see that this styling have changed to an anchor tag because of that link component. But when we place it, it will always take us to the home page. So if we go to the sign up component or sign in component, you'll see that the navbar was common, but when we click on the to-do app here, it will take us to the home page, which is our to-dos page. Now let's change the styling for this to-do app using the hook that we imported at the top, which is make styles. So you can search on Material UI how make styles work. So at the top here, just search for make styles, and then you click on that make styles. And when I scroll at the bottom here, you import make styles, and then you will create a constant you call the make styles hook, and inside you pass an object with some styles that you want, and then later you create a const called classes, and you call the use styles right here. So let's do this. I'll just copy this one right here, and then come back to our editor here. After our imports, this is where I will use make styles. So we import make styles at the top, and then we create a constant use styles, make styles, and then inside we pass some styles, okay? And I want to change the style for our link. So right here, I'll create a key called link style. You can call it any name you want, and then inside this key we pass an object. I will change the text color right here. So I remove what is inside here, and then I will change the text color. So that is color, and I'll set it to white, okay, what we had earlier. That is hash FA, something like that. and then I use a comma, and then I want to remove the text decoration so that we don't have an underlined text. So text decoration, and I'll set this one to none. Now to use this one, I'll come inside the NavBar component, and in here I can create a const classes, and then I invoke use styles, just like that. And now we can use these classes to access any key in here. Okay, so how we do that is to come to our link now, and then use a class name. So this is how we use classes in JSX. So you can see this is a HTML like format, but instead of using class, we use class name. Okay, so we can enter a class name here, and the class name that we want is link style, which will give us these styles. So how to access these styles? We'll use the classes right here, dot link styles. So right here we can pass an object, and then we'll have classes dot link style, just like that. And this should change the style for our to do app to have color white and also text decoration of none. So yeah, let's see. I refresh this one, and there we go. Now we have a link, and also the styling is okay. So if I go to the other component, which is sign up, and try to click to do, it still works perfect. Now let's go on and style our UI further. Now you have seen how we use make styles, which is a hook, and we can now proceed to the next step, which is adding another typography. So just after this typography, I'll add another typography here. So typography, and then the variant for this one, variant, I want it to be subtitle 2. So I'll set it to sub title. So this is just a smaller text than the H4 here. So subtitle 2, and then I can include the text here, logged in as Chaoo. When we add authentication, we'll be able to dynamically display the name of the logged in user. Okay, but when we look at this, you'll see that we will have a weird behavior. Let's see, it will come at the bottom here, so they are not side by side. So to make this one to be side by side, this is where we will use our toolbar component, because it will flex the item in a row instead of in a column. So our app bar flexes the item in a column, our toolbar will flex the items in a row. So just after the app bar, we should call our toolbar component, and we include all the typographies inside there, just like that. Okay, that's the purpose of the toolbar, just to arrange them nicely. So I want to remove this space, and if I save this one, it should auto format due to prettier, and I should also cross this one to create more spacing here. So perfect, this is now nice, and when I come back here, you'll see that they'll be side by side. So momentarily we have an error, but when I do this, now you'll see that we have the to do app and logged in as side by side, and it have also created some spacing around our text. Now we need to make this one to go to the center at least, and for that we'll make use of our make styles again. I'll create a styling here called root, and I'll set this one to a flex grow of 1. Now we can use this style at the bottom here on our typography. So we set a class name we use our classes right here, dot root, and this will set the flex grow of our logged in as Chaoo to be 1. Okay, and then we should also set our to do app to have a flex grow of 1. Class name, classes dot root. So this will have a flex grow of 1 and this one a flex grow of 1. So they should occupy like equal spacing. So if I come back and try to refresh, you'll see now this is pushed to the other side. Okay, perfect. Now we need some buttons on the other side. So at the bottom here, after the typography, we will add a button component, which we already imported earlier. And then inside this button, we will have sign out. Just like that. And I want when we click this button, it takes us to the sign in component because we are signing out of the application. So what I can do is that I can add an on-click event to this button right here. So I can just say on click, and when we click this one, it will call a helper function. So right here we will use an arrow function and it will call a helper function, and this helper function will call it handle sign out, just like this. So we haven't created this helper function, so we can create it now. Just before our return statement, we can say const handle sign out, and then this will be an arrow function. And in here, the first thing that we will do is to sign out the user. So when we add authentication, we'll come back here and sign out the user. Okay, and then after signing out the user, we will redirect them to the sign in component. And for this, we need another import from React Router DOM, which is also a hook called use history. So right here where we imported the link, we will also import use history, and this is a hook and we can make use of it in this component. First of all, I'll create a constant here called history, and I'll set this one to use history, and I invoke this hook just like that. So right here I can just say history, and we have a method called push, which will push the user to the path that we specify in here, and we want it to take us to the sign in component, just like that. Okay, first of all, let's see what we have. I'll refresh, and we have our button on the side here. So the thing that I want is that I want this button to be white in color, just like this one, sign out. And how I'll do that is by adding another key in our make styles, and I'll call this one auth button. Or rather, we can use a prop called color inside this button, and we inherit the color from the parent, which will be white. So right here I can just say color will be equal to inherit. So this will inherit color from our app bar component here, which will be white. Okay, let's see. So yeah, there we go. So now we have a sign out button, and when we click this button, we should go to the sign in component. Perfect. When we click this one, we go to the to-dos. Now we need the other buttons, so let's create them just at the bottom. So we'll have another button. I'll save this one to auto format, and we will have another button. This will be for sign in, and then we'll have another one, and this will be for sign up. Now let's add the different props. We'll have color of inherit, and then in here we want this one to be a link which will take us to the sign in component. So I can use the link component and take my sign in here. So we will use this class name. I'll just copy it so that the link will remain to be white, and it will not have any text decoration. For the next button, color, and then this will be inherit, and then we also want it to be a link which will take us to the sign up component. So link, and I take this text in here, and then I use this class name, and also we should include the to prop so that we can specify which component it will take us to. So right here we can say to sign in, we can say to sign up. I'll save that, and I'll come at the top here and remove this one because we ain't using it anymore, and we can test our button so far. So we have some errors. I'll try to refresh, and there we go. We have all the buttons: sign out, sign in, sign up. When I click sign in, we go to the sign in component. When I click sign up, we go to the sign up component. So later on, when we add authentication, we will conditionally render these buttons so that if you are logged in, you won't see the sign in and the sign up button, and if you are not logged in, you'll see the sign in and the sign up button. So for now, I want us to achieve this design where our navbar is a bit at the center and we have spacing on the other ends. So what we can do is to go to our app component, and here we will import a component from material UI components. So right here I'll say import, and the component that we want is the container component, and this will be coming from material UI. So at material UI core, and then when I come at the bottom here, I can wrap all our components inside the container. So right here I'll say container, and I move the whole of this content in here, and then we can specify the max width for our container. Max width, and I'll set this to medium. So this should create some spacing for our application on the sides. Let's see, and we have a very big error here. Now we are good. So you can see now we have some spacing on the ends, which is perfect. So now we are done with the navbar component, and in the next section we will go on and design this particular input field, and also we'll see how we can use icons in our application using material UI. Okay. Hey, what's up guys? So in the last episode we were able to install material UI in our application, and we created this top navbar. And in this episode I want us to proceed to our other components where we will create a component for adding a to-do, and then we'll be able to work with icons in this video, and we'll also create the sign in and the sign up forms. So to get started, we need to install material UI icons in our application. So you can come to material UI website. And then when you come at the search bar here and search for icons, choose the first option. When you scroll at the bottom here, you'll see installation details. So to install Material UI icons in your application with npm, you just run this command, npm install at Material UI stroke icons, and with the yarn you run this command. So just copy this command right here, and then go to Visual Studio Code, open a new terminal, paste that command right here, and all you need to do is to press enter to install Material UI icons in your application. So I have already done this and I won't repeat it just to save time. So I'll close this one, and then to see how you can use these icons, you can scroll at the bottom here and you can import the icons just like this. So the name of the icon, and they come from Material UI icons module. And then to get all the icons and their names, you can come at the top here and you'll see this link. You can search for full list of these icons, click it, and then you land to this page where you can see all the available icons in Material UI. So you can filter them, filled, outlined, rounded. So you can choose any kind of icons that you want, and these are the names of those icons. Okay, so you can scroll them and see the different icons that are available, and you can be able to use them in your application. Now let's get started by creating this component for adding a new to-do. So I'll come back to the text editor, and then we had created a component called todos.js, and what we need to do is to add a new file inside our to-dos folder called add todo.js. So I'll use JSX instead of JS, and then I'll come in the todos.js file, copy everything that is in here, and then paste it in our add todo.jsx file. Now we need to change the name of this component, so I'll select this one, use Ctrl D 2 times to select these to-dos and these to-dos, and then hit backspace and change the name to add to do. Now this is our add to do component. Now the next thing that I will do is that I will import this component inside our todos.jsx file right here. I'll just say import add to do, and this will be coming from the add to do file, which is available in the same folder, add to do. And we can use this add to do component in here instead of a h2. So I'll just say add to do, just like that. And then I'll create another file in our to-dos folder, and I'll call it list todos.jsx, and this will help us to list our different to-dos that will be coming from the database. So in here I'll simply paste what I had copied earlier and change the name for our to-dos component here. Use Ctrl D and then come at the front and include list, just like that. Now I can also import this component in our todos.jsx file. So I'll come here and say import list todos, and this will be coming from list todos, just like that. And then we can use it at the bottom here, list todos. Okay, now we should see add to do and list to do in our app. I'll come back and check it, and there we go, add to do, list to do's. Now let's tell our add to do component. So I'll come to the add to do component, and I'll import two components from the Material UI core library, and that is a text field and a button. So right here I'll simply say import ID structure text field and a button and this will be coming from the Material UI core library. This is supposed to be a comma and not a full stop. So from at Material UI stroke core, and then we will need an icon, which is a send icon for our button, coming from at Material UI icons module. So right here I'll just say import, the name of the icon is send, and this will be coming from at Material UI icons. And then now we can use this text field and this button in here. So I'll just get rid of add to do, and then I'll include a form tag. So this should start with a small letter. It's just a tag and not a component. And then in here we can include the text field component. So text field, it is self-crossing, and then below the text field we'll also have a button, just like that. Now I can include a closing and an opening for the button, so that in here we can include an icon, which is our send icon, just like that. So now we have included a text field, a button, and also an icon. So this text field should be capital here. So now this is what we currently have: a text field and a button which have an icon, but we can't clearly see the button, we only see the icon. And also we don't have a text field that we want this kind of a text field. So what we can do is to add several props to achieve our style. So in our text field we can add these props. The first thing we will add is an ID for our text field. So right here I'll say ID to be equal to enter to do, and then we will have a label which will be enter to do. Some camel casing here, it is not a must, enter to do. And then we can set autofocus for this field. We set it to full width, and then we will have some other properties here, like the value and an on change event later when we start working with the actual data. But for now this is good enough. Now let's go to our button, and we want to set a color for our button to be primary, which is the blue color. And then we will set the variant to be contained, so it can be outlined, contained, or it can remain as default. The type for our button will be submit. Just like that. And that's all we need for now, and we can see what we have. So I'll come back to the browser and wait for this to refresh. And now this is what we have. Our text field have not been styled correctly. So when I look at the label, autofocus, we should have a variant right here, variant to be outlined. So just like that. And now we should have the design that we want for the text field. So perfect. Now we want our enter to do text field and the button to be side by side, and for this we will depend on some custom styling. And for custom styling we used a hook earlier called make styles. So let's import this hook from Material UI, just right here. So we will import make styles, and this will be from at Material UI. at material UI styles. And now we can use this make styles to create some custom styles. So just above our component here, we can create a constant use styles, and then we invoke the make styles hook here, and we pass an object inside with the styles that we want. So I'll create a key called form style, and then I'll use an object to list the different styles. So we want a margin top and bottom to be 0px, and then left right to be auto, just to center our text field, and this one should be inside quotes. So I'll select all of them and use a quote, make them to be inside the quotes, and then we will have a padding for our text field, and I want this one to be 30px. So padding 30px, and then we will have a border radius, just a straight border radius. Remember to use a comma here, and then use border radius. And you can see that we are using camel casing here because this is JavaScript, and then right here you say 9px. I'll include a box shadow with these values 0px, 0px, and then this will be 12px and negative 3px, and then the color will be black, so hash 000000. And I have realized that this is misspelled, so make sure this is make styles. And now the next thing I'll do for our form styles is that I'll add a display of flex and a justify content of space between, just to make the text field and the button to be side by side. So right here I can say display to be flex. Remember to use a comma here and a comma here. Use justify content to be space between. Make sure this is spelled correctly. And that's all for our form style. We'll also have a styling for our button. So right here I'll say submit button to have a margin left of 20px. Now to use these styles, I'll come inside our component, create a constant called classes, and then invoke use styles, just like that. And now I can use these classes to access the different properties inside our make styles hook. So right here for our form, we can set a class name. We set it to be equal to classes dot form. What did you call it? Form style, just like that. And then you can add more properties for our form. I'll add no validate. Will depend on the server-side validation which we added using Joy. So no validate, and then autocomplete. I'll set it to be off. So off. Now let's come to our button here and add this style, submit button style. So I'll say class name, and I'll set it to classes dot submit button. I guess that's correct, right? And that's it. We can now see the kind of styling that we are having for our add to do component. So I'll come back to the browser, and perfect. I think we are almost there. We have this text field and the button on the side, and we have some box shadow on it. Now the only thing we need to do is to create some spacing between the navbar and this one, and also to make this one to be a bit smaller, just like we have in this app. Okay, yeah, just like we have here. So for this one, we won't touch our add to do component. We'll go back to our app.js file, and right here I'll use the make styles hook to create some custom styling, so I can import it from material UI styles. So import the make styles hook, from material UI styles, and then at the top of our app function we can create a constant use styles, which will be equal to make styles. We invoke it and pass an object in here where we can pass a key content style, and all I need to do is to add a top margin. So margin, this will be top and bottom to be 30px, and then left right will be auto, just to center it. This should be content style, and I guess we are good. Now I can come here and then create a constant, so const classes, which will be equal to use styles. I invoke it just like that and make sure the camel casing is okay. And now we can use classes to access content style. So what I will do is that I will wrap everything in here apart from the navbar inside a container component, and we had already imported the container component at the top. So right here I can use the container component again, and then I'll move the switch inside this container. Now we can use these classes right here. I'll set a class name to be equal to classes dot what did we call it, content style. Yeah, just like that. And then we can set the max width for this container. So max width, and I want it to be smaller than this one, so this will be SM for small, this is medium, and that's it. But I don't know why these errors are popping. Okay, this should be closed this way. Yeah, I think that should make the error disappear. Perfect. Now let's check our app and see if we have what we want. And there we go. Now we have our form and the submit button for adding a new to do. Perfect. Now the next thing we are going to style is our list to do's component. Before we proceed to the list to do's component, let's fix our autofocus on our field here. So when we come back to the code editor and go to our add to do component, you'll see that in our autofocus we should be using camel casing. Instead of using small f, use a capital F, and this should fix that. So when our app reloads, it should autofocus our enter to do field. And there we go. Now let's go to our list to do's component, and the first thing that we should have is a title, just like this one. Let me show you the to-dos, and then we'll have a component inside our list to-dos which is a single to do. So this is a single to do, this is another single to do, and so on and so forth. So I'll add this title by importing the typography component from Material UI. So right here, just import typography, and this is from Material UI core. And then we can use that typography right here. First of all, I'll start with a div, and I'll move this one, and then in here is where we'll have our typography component, and we should remove this. So import typography from Material UI core, and then we have the typography component here. And in here I can simply say the to-dos, and then the variant for our typography will be h5. So this will be h5, and then after this heading is when we'll have our to-do component. So let's create the to-do component. Inside our to-dos folder, I'll add a new file called todo.jsx, and I'll copy everything that we have in our list to-dos component and paste it in our to-do component. Now the only thing that I remove is the whole of this, and add a h2 simply saying to do. So this is a single to do, and then we change the name of our component, use Ctrl D, delete, and rename it to do. Now let's import this component in our list to do's component. So right here I'll say import to do from, so they are in the same folder, to do, and we can use this component just right here. So I'll duplicate this so that we have at least two to-dos in our list to-do component, and we can see what we have in our app. So I'll come back here, go to the app that we are working on, and we have the title, and then we have two to-dos. Now let's create some spacing between our form here and the title here, and also style our list to do's. We'll create this shadow and so on. So I'll make use of the hook, make styles hook. So in our list to do's component, I'll import make styles from our Material UI styles. So this will come from at Material UI styles. And then before our component here, I'll create a constant called useStyles, and then we invoke our makeStyles hook. By now you are used to this. We invoke it and pass an object. I will use to-do's style as the key, and then we set a margin. Our top will be 20px, so this is top and bottom. Left right will be auto, just to center our content, and then we'll set a padding of 20px. We include a border radius of 9px, and we also want to have a box shadow. So right here I'll say box shadow to be 0px, 0px, 12px, -3px, and the color will be black. So hash with 6 zeros here. Now we can use this style by creating a constant here called classes, which will be equal to use styles. Right here we'll set a class name, and we access our to-do styles using our classes here. So we'll say classes dot to-do styles. Just like that, and now we should have a box shadow around our to-dos and some margin top and bottom and also padding. And we can preview this, and there we go. Nice. So the next thing is that we will work on our to-do component. In our to-do component, we want to have the name of our to-do, the author, the date, and then some action buttons on the side. So I'll come back to our list to-dos, and then I'll include a semicolon here, just some fancy text, and then I'll go to the to-do.jsx file. We will need to import several components from Material UI core. The first one will be typography. The other one will be a button for our buttons, and then we'll also have a button group. So this will be for our action buttons. So button group, and then we will import several icons from Material UI icons. So let's import them here. The first one will be create, and then we will have a delete icon and a check circle icon for checking a to-do as done. And all this will be coming from Material UI icons. Just like that. Now let's make use of these components. Right here I'll use a div, and then I'll use another div for the content of our to-do, and below this we'll also have another div for our buttons. So in here we will start with a typography, and this will be the name of our to-do. So for example, we can say our maybe learn React, and the variant will be subtitle 1, include another typography. Actually, I'll just duplicate what we have here. So I'll select these and then use Alt, Shift, and a bottom arrow so that we duplicate what we have. And this will be our author. So we can set the author to be Chaoo. Later we'll dynamically display this name depending on who created that particular to do, and then this will be the date, and then let's say 4 days ago. So we'll also display this dynamically depending on when the to do was added. So the variant for this one, I'll set it to be body2, the same as this one. And then when I scroll at the bottom here, we can come inside this div and create our buttons, our action buttons. I'll use the button group component, and we can create the first button in here, and inside this button we'll simply have an icon, and the first icon we will use is for checking a to-do is done. So I'll say check circle, and for our button group we'll have several props. The first one is the size, and I'll use the small size. So here I'll set size to small. Area label will be outlined. So right here you'll have area hyphen label. This will be outlined. Primary button group. And then I'll duplicate this button 2 more times and change the icon from check circle to create, and check circle here to delete. I'll set the color for our delete button to secondary. So this is reddish color. And the color for our create to primary. And for our check circle, I'll set the color to action. So later on, we'll conditionally render the color for our check circle depending on whether a to-do is done or not. At this point, we can see what we have. We should close this one properly. I'll go to the browser and wait for it to refresh. And perfect. Now this is what we currently have. We have the details for our to-dos and then the action buttons. But we want to display the details for this to do side by side. So we'll have the details and then the action buttons will be on the side. And for our other and added art or the date will be grayed out. Okay, just like we have here. So this is grayed out and then we have them on the side, and we'll also add a border around them and some padding. So with this we will use custom styles. So I'll come back here and we need to import the makes styles hook. So let's do that. I will import make styles. And this will be from at material UI styles, and then just before our component we create a constant use styles. We set it to make styles and invoke this hook, pass an object in here, and the key here we'll use to do style, and we can include the different styles for our to do. So first of all, we want some margin top and bottom for each to do to be 20px, and then left and right to be auto. We want some padding for each to do. I'll set this one to 20px. I will include a border for each to do to be 2px solid, and then this is the code for the gray color bd. And then we will have some border radius, and this will be 9px. And then to display the content side by side with the our action buttons, we'll use flexbox. So right here I'll set display to flex, and then justify content to space between. And to gray out our author and added art, we will use another key here, and I can call it maybe gray style. You can use any name, okay? And I'll simply set the color to this code #8f8f8f. So now let's make use of these styles, and I'll come right here, create a const classes which will be equal to use styles. I invoke that. Now this div is the one that represents our entire to do, so I'll say class name to be equal to classes dot to do style. I guess that's what we called it, and then we can use the gray style right here on this typography and this one. So right here I'll set a class name to be classes dot gray style, the same as this one. I can just copy this and paste it here. Now let's take a look at our to-dos here, and our flex was not applied, so I'll come back to the code and check our flex styles. So I misspelled display. I think that should fix it, so I'll come back and confirm. And there we go. Now we have achieved the exact style as this one. Now the next step that we will take is to create our sign-in and our sign-up forms. Now to work on the sign-in component, let's go to our text editor and open the sign-in.jsx file. So we'll need to import several components from Material UI, that is a typography, a text field, and a button. So let's do that. Import typography. We will need a text field and also a button, and all this will come from at Material UI core, just like that. And also we'll need some custom styles, so we can import the make styles hook, and all this will come from at Material UI styles. So it can be this way, or you can also include core here. Either way it works. So in here I'll just create a form, and we will use our typography component. Right here we'll simply say sign in, and the variant for this one will be h5. The next thing that we will have is a text field, and we'll have several props for the text field. We'll have an ID, which we can set it to enter email. So this text field is for the email, and then we'll have a label, which will be enter email, and then we'll have a variant to be outlined, and finally we'll have full width, just like that. And then we'll duplicate this text field, and this one will be now for password, so enter password, enter password, and outlined full width. For the password, we'll also add a type of password so that the password is hidden, just like that. Now finally we'll need a button, so let's use the button component, and for the button it will say sign in. We can set several props. Variant will be outrained, and then the color will be primary, which is a blue color, and the type will be submit. And now we have the layout of our form. So for the form, we can also include some props right here. So we can have no validate, and then autocomplete to be off, and then we will add some custom styles. But for now, let's see what we have so far. Okay, so I'll come back to the browser. Text field is not defined, and let's see. So this is text field with the capital F here, and let's see what we have. So this is what we currently have, and our blue color was not applied to our button. So I'll come back and fix that. I'll check the color here, and it seems to be okay. Okay, variant here should be contained so that the blue color can be visible, but you can leave it at outlined if you want. So variant contained, primary, submit. Now let's proceed to some custom styling. At the top here, we'll create a constant, use styles, and this will be equal to make styles. We invoke this hook and pass an object in here. The first key will be form styles or form style ladder, and then we can pass several properties here. The margin, I want it to have 0px of margin top and bottom. Left and right will be auto. Padding to be 30px. I'll also set a border radius of 9px, and a box shadow. I'll use the box shadow for this one, so I'll just copy this from the list to do's component and come to our sign in, paste it here. So now we have the form style. The next thing is to use it, so I'll come here, create a constant called classes, and I set it to use styles. I invoke that. Now we can set a class name here, class name to be equal to classes.form style. Yep, just like that. And now we can see what we currently have on the browser. So we have a cool box shadow here, and then some padding, but we need spacing between our different fields. So we can include another custom style right here, and I'll simply call it spacing, because that's what it does. And all we will do is to add some margin top of 20px, and now we can use this spacing key to access our margin top. So we will come on the text field component and add a class name to be equal to classes dot spacing. I will copy this, add it to this text field, come to the button and also add it here. So for each of these components, the button will have a margin top of 20px, margin top of 20px, and margin top of 20px. And when we look what we have, now we have some good spacing for our form. And that's it. When I enter the password here, it's hidden. Now let's go to the sign up form. And for the sign up, this will be super easy because we will use what we have in our sign in. So I'll copy everything here, open the sign up file here, and then select everything, paste our sign in content here. I'll come at the top, select this sign in, use Ctrl D so that we can edit multiple times, and change everything to sign up. And then when I come at the top here, I can start this with a small caps. Okay, now let's see what we can change, because now we already have a sign up component with an email text field, with a password text field, with a button that can submit the content. The only thing that we will add is another text field for the name. So I'll duplicate this at the top here. We change the ID to enter name. We change the label to enter name. And that's it. That's all we need to change. So we can check what we have. I'll come back to the browser, and there is our sign up form. So we can enter a name, email, and a password, and we sign up for an account. So at this point, I think we have successfully completed styling our UI. We have the forms, we have our to-dos component, entering a new to-do, the way we can display the to-dos. And in the next video, we'll now start working with the logic of our application. We will start by setting up Redux and then performing all the CRUD operations, and then later on we'll move to authentication and authorization. So that's it for this video. Thank you for watching, and please make sure to subscribe so that you don't miss any of my videos. Hey, what's up guys? So in this video, we'll be able to perform all the CRUD operations in our application using React and Redux. So CRUD simply stands for create, read, update, and delete. We'll be able to create new resources in our database. We'll then be able to read those resources from the database and display them on the UI. And then we'll be able to update or edit a particular resource from the database and display the changes on the UI, and also we'll be able to delete a particular resource. And for us to do all this, we'll need to set up React and Redux. And React and Redux are completely different libraries, so we will need another library called React Redux for us to bind React and Redux together. We'll also create a Redux store, and a Redux store will act as a single source of truth of our application state. So we'll have a central place where we'll store the state globally, and we can access this state from any other component in our application. And we'll also create some reducers, and a reducer is simply a function which have access to the state and the actions, and it can use the state, the current state, and the action arguments to update the application state. And for us to actually update the state in our reducers, we'll need to dispatch actions. Okay, so what will happen is that we will for example click on a button, e.g. creating a new to-do, and then we'll dispatch an action creator after clicking that button. And with the help of Redux Dunk, we will halt that dispatch, perform an async action, for example, access the database and save a particular to-do, and then get a response. Once we get a response, we'll be able to continue with the dispatch, and we'll dispatch an action which will have a type and a payload. And then we can check the type and the payload from our reducers with the help of this parameter. We can say something like action.type and update the state accordingly. So we'll see how we'll do all this in this particular video. Now we will be consuming some form of backend APIs, which are CRUD operation APIs. And we have already created these APIs using Node.js, Express, and MongoDB. So if you have no any information about it, you can go to my channel and then scroll at the bottom here, and you'll see this section where I have pinned this entire series. You can click on MERN Stack tutorial with Auth, and you land to a page like this one where we have all the videos in this series. And from #0 to #13 is where we created our backend. So we were able to create an Express server, we connected to MongoDB, we were able to create the endpoints for handling CRUD operations, so handling post request, get request, delete, put, patch. We checked at joy data validation and testing API endpoints using Postman. And then in this video, #13 is where we created our Auth API endpoints using Node.js and JWT, which is a 1-hour video. And then after that is where we got started with React. We learned about React router and created our UI using Material UI. So this is our UI here. And now it's time that we add logic to this UI so that we can create a new to-do and perform these other CRUD operations. So make sure you check this one out and go through these videos so that you can be up to date to where we are at this point. In case you're new here, my name is Charles. I am a JavaScript developer, a coffee lover, and I create coding content here on YouTube. Now that sounds awesome, so please make sure you subscribe and turn on post notification so that you don't miss any of my videos. In case you have a question, you can always leave a comment at the comment section below, or you can find me on Twitter at Chaoo Charles. Also, please make sure you leave a thumbs up if you like this video, and in the next section we'll be able to get started with setting up React and Redux. So in this section, I want us to set up React and Redux, and the first step that you'll take is to open a new terminal and run this command to install these 3 libraries. To install Redux, React Redux, and as I said before, React Redux will help us to bind React library and Redux library, and also Redux Dunk. And Redux Dunk is a middleware which will help us to perform async actions in our action creators. So we'll see how we'll do that later on. Once you install these 3 libraries, the next step is to make use of them. So I can close this terminal, and we can start by creating a Redux store. So to create a Redux store, we will import a create store method from the Redux library. So right here I'll say import create store, and I'll also import apply middleware so that we can configure our Redux Dunk library too. Okay, so you import create store and apply middleware, and this is from the Redux library, just like that. And now we can use this create store to create a Redux store. And a Redux store is where our application state will reside. So we'll have a central place where we'll have the entire state, and we can access the state from any other component in our application. So right here you can say const store will be equal to create store. We invoke this one, and the first parameter is a root reducer. And a root reducer is a combination of our different reducers that we will have in this application. So we will have a to-dos reducer and also an auth reducer, and a combination of these two reducers is what will be included in our root reducer. So right here I can say root reducer. We will create this one in a minute, so just pass root reducer. And then the second parameter is where we can make use of apply middleware and configure our Redux dunk. So right here I can say apply middleware. We invoke this, and in here we pass our Redux dunk. So let's import something from Redux dunk. We will say import dunk from Redux dunk. And then we pass this dunk just in here. Now let's create this root reducer. I'll come to the root of our application, and inside the SLC folder I'll create a new folder called store. So everything to do with Redux store will be included in this folder. That includes action creators and reducers. So inside this store folder I'll create a new folder for our reducers. And then inside the reducers we can now create a new file called root reducer. .js. And as I told you before, root reducer will simply combine our different reducers in this application. And since we are dealing with CRUD operations in this video, we will create a reducer called to-dos reducer, which will handle our CRUD operations. So right here I'll say to-do reducer.js. Later on, we'll add another reducer called auth reducer for authentication, but for now this will be good enough to set up our React and Redux libraries. Okay, now let's enter to the to-do reducer. And a reducer is simply a function which have access to state and also action, and we can use those two parameters to update the state. So right here all we will do is to create a function called to-do reducer, which will be equal to, we accept several parameters. The first one is the state, and we can default the state to an empty object or an array. And then the second parameter here is action, and we can use this to access the action arguments, e.g. action.type, action.payload, and update the state accordingly depending on those arguments. Okay, so we have state and action, and this is supposed to be an arrow function. And in here is where now you can update the state. But for now, we don't want to do anything complex, so we'll simply return the state, and then later on we'll come here and update the state depending on an action which was performed. Okay, so right here I'm simply returning the state, and then at the bottom here we should export this to-do reducer. So I'll say export default to-do reducer, just like that. I guess everything is fine. And now we can import this to-do reducer inside our root reducer. So I'll come to the root reducer and import our to-do reducer. So I'll say import to-do reducer, and this will be from, they are in the same folder, so to-do reducer. And then we need to import something from the Redux library, which is combine reducers, so that we can be able to combine our different reducers. Okay, so right here I'll simply say import combine reducers, and this will be coming from the Redux library. This is supposed to be from Now we can make use of these combine reducers. So I'll come at the bottom here. I'll create a constant called root reducer. We set it to be equal to combine reducers. We invoke this as a method and we pass an object in here. And this is where we can combine our different reducers. This is supposed to be const. So right here, I'll set our to-do reducer to be to-dos. Okay, so to-dos, to-do reducer. You can leave it as a to-do reducer, but to-dos sounds more fun. So we'll be accessing the to-dos state using this one. And now we have our root reducer set. All we need to do is to export it. So export default root reducer. Okay. Later on, we'll be able to import our auth reducer and include it in here. Okay. Now let's come back to our index.js file and we import that root reducer in this file. So I'll say import root reducer from, we enter the store folder, we access the reducers, and then root reducer. Just like that. So now we have our root reducer imported right here. Okay, and remember, root reducer is simply combining our different reducers. So we'll also add all the reducer in here later on, but for now we just want something simple so that we can create the store. Right now we are successfully creating the store, and what remains is to make our application aware of this store. And for that, we will use our React Redux library. So I'll import something from the React Redux library, which is a provider component. So I'll say import provider, and this is from the React Redux library. Okay, as I told you earlier, React Redux is acting as a binding layer of our React library and our Redux library. So this is a component, and we can wrap our app using this component right here. So I can say provider, and we need a closing tag. Okay, there we go. I move this app in here just to wrap it inside the provider component, and then I can indent nicely just like that. For our application to be aware of our store, we need to pass this store as a prop inside our provider component. So right here, I'll set the store to be equal to store. And that's it. That is how we set up React and Redux in our application. And now in the next section, I want us to try and create a new to-do in the database. So we'll talk about action creators and we'll talk more about reducers. Okay, but for now we can check if our application still works without errors. I'll check if it's compiled, and we have an error here, React Redux. So we need to wrap this one inside quotes. Yep. And let's see if we have any other error. And oops, combine reducer is not defined. So we made a mess again. So let me fix this real quick. I'll come to the root reducer. This is supposed to be combine reducers. So these are just typos. Make sure that you don't have these errors in your application. Okay, I hope everything is fine now. So our application still works. I can hit F12 to see if there are any errors in the console or warnings. So our console is clean and our application is working. So in the next section, let's see how we can add a to-do in the database. So in the last section, we were able to integrate Redux in our React app. And in this section, I want us to try and add a new to-do to the database. And to do that, we'll be working with our add to-do component here. And we'll try to read the values that we enter in our text field. We'll make use of useState hook. So at the top here, we can import useState from React library, okay? So useState. And then at the bottom here, we can set up some default state. And what we can say is use state. We invoke it and pass an object in here. Our to-do will contain a name, and we can set the name to be an empty string. And also we'll have is complete, which is Boolean. And by default, it will be false. So by default, a to-do will not be complete. So for now, we'll just have this default state, and I'll show you how we'll add the date, okay? And this use state hook will return an array, and we can destructure some properties from that array. So I can say const an array. We will have a to-do, which will represent this object or our to-do, and then we'll have set to do, which is a method for updating our to do, okay? So now we can make use of this 2 at the bottom here, and I should include an equal sign here, okay? First of all, I'll set a value which will be equal to do dot name. So this to do dot name, an empty string. So this is the default. And then we will use an onChange event to update our value. So we can say onChange, which will be equal to, I include an object here, and I pass a function which accepts E for event. And then this will be an arrow function, and we can now call our set to do right here to update our to do state, okay? So I'll call this one, pass an object. I spread the properties of our to do using the spread operator. So 3 dots and then to do. And then what I want us to update is the name. So right here I use a comma, and then I set the name to be e.target.value. So every time we type on that input field, our name will be updated to that particular value. And another thing that we can do is to set a date. So right here we can set the date to be equal to new date. And yeah, that's about the onChange. And once we click the submit button, we should include an onSubmit event at our form here, okay? So that we run a handler function. So right here at our form tag, I can include an onSubmit event, and this will run the handle submit function. So handle submit, just like that. Currently we don't have this function, so we can create it at the top here. So just at the top of our return statement here, we can create a function const handle submit, which will accept event. And then in here we can do something. The first thing that we will do is to prevent the page from refreshing when submitting the form by saying e.prevent default. And then we invoke this just like that. And then in here we can take the updated value of our to do and log it to the console. So right here I can say console.log to do. And then after we log this to the console, we can reset our values for the form. So we can say set to do to be the default values here, name to be an empty string, and the is complete to be false. And then I can include a comma here, and I'm not sure why this is bringing an issue. I am not sure. Okay, this is supposed to be an arrow function right here, that way. So we are preventing the page from reloading, we are logging the to-do to the console, and then we are resetting our to-do. So let's try and see if we can log a to-do to the console. So I'll come to the browser here, and date is not defined. So I'll come back here and then scroll at the bottom. We should change this date to have a capital D. Yeah, this is a global method which is available to us, so it should be defined. Now when I come back after the refresh, these errors should disappear. Okay, the value here, we should include this bracket so that it's not a string. We are trying to read this name. It should be this way. You include these curly brackets so that we can read this to do dot name. Not this one, but for right here, to do dot name. So yeah, and now let's try to create a to do here, maybe new to do. When we submit, we should get an output right here. So send, our form clears, and when I check my console, we have a date for our to do, we have is complete, and we have the name of our to do, which is new to do. Perfect. So we are able to get our to do. So what we will be doing is that we will be dispatching an action creator right here, okay, and then passing the to do to that action creator. So first of all, we need to create an action creator, and we'll do that inside our store folder. So I can expand this, and then I'll create a new folder inside the store folder called actions, and then inside the action folder I'll create a new file called to do actions, and this is where we'll have all our action creators for our to-dos. Press enter, and now in here is where we are going to create an action creator for adding a new to-do. Now before we do this, I need you to install a library which is Axios. So just run this in your terminal, npm I Axios, npm I Axios, and hit enter to install Axios in your application. I have already installed, and I'm assuming you already know how to install modules or libraries in your application. Okay, install Axios because we'll need it in this file, and then in your SLC folder you'll create a new folder called API. Okay, so this API folder, and then you create an index.js file inside the API folder, and what you will do is that you'll create a constant which is a URL and set it to this string http localhost 5000 /API, and this is trying to hit our backend endpoint or our backend API. Okay, and you also make sure that you export it because we'll also need this one in this particular file to do actions.js. So in this file, the first thing that you will do is to import Axios, assuming that you have already installed it. So import Axios from Axios, and we'll use Axios to perform HTTP requests. So you import Axios, and then you import the URL which is for our endpoint URL, and this is from the API folder. Okay, so I'll say stroke, and then we can access the API folder right here, and this should access our URL because inside the API folder we only have index.js and we don't need to include anything else at the front. Now that we have Axios and the URL imported, at the bottom here we can create an action creator for adding a new to do. So we'll say something like export const add to do, Now this is the name of our action creator, will be equal to, right here we'll be receiving a to-do from our add to-do component, so we can pass that to-do right here, and we set this one to be an arrow function, and we can do something in here. So remember earlier we configured Redux Dunk, which is a middleware in our application, and Redux Dunk, what it does, it allows us to return a function inside our action creator. So right here we can return a function, so return an arrow function, and this arrow function will have access to these parameters, dispatch, and this dispatch simply continues the dispatch of our actions, and we'll also have access to get state, and we can use this get state to read our application state from the Redux store in case we need it. So at this point in here we can be able to perform an async action using Axios, and this is why we used Redux Dunk in this application. If we don't have Redux Dunk, we wouldn't be able to return a function in here, and if we tried, we'll get an error. Okay, so right here what we can do is to use Axios and use the post method to post a new resource to the database. I can include this on a new line to clearly read it, and then the first parameter is our URL, and we have imported the URL here. And what I'll do is that I'll use the backtick so that I can read this URL and include something in front of it, okay, or simply merge a string. So use some backticks, and then use the $sign and the curly brackets. We read our URL, and at the front here we can include stroke to-dos, and now we are tapping on our to-dos API. Again, if you don't know how we created this to-dos API, make sure you check out the other videos in this particular playlist or this particular series. Okay, so this is the first parameter of our post method, the endpoint, and then the second parameter is our to-do, so you can simply say to-do. For this to-do, we can also include an author and a UID, and I'll show you how we'll do that once we add authentication in our application, but for now this is good enough. So this is an async action. It will take some time to process, so we can tap a .then method at the end here, so we can say .then, and our response which we will get is the to-do that we just created. So we can access this to-do and do something with it, and what we will do is that we will simply dispatch an action. We will continue the dispatch. So dispatch, I invoke this, pass an object here, and the type of our dispatch right here is add to do, and then we can also include the to do that we just got from the backend. So just a quick recap. Redux Dunk allows us to return a function in here, so we halt the dispatch, and then we perform an async action using Axios. We post a new to do using the post method, which accepts the first parameter as the endpoint, and then the second parameter as the body of our request or our to do. Okay, and then we tap a .then method. Since this is an async action, we get a to do as a response, and we continue the dispatch here, and the type of our action is add to do. We can be able to access this add to do from our reducers and be able to update state accordingly depending on the argument, and in case of an error we can catch that error. So right here we can also tap .catch. We have access to the error object. We set an arrow function, and we can log this error to the console. So console.log error.response, just like that. Now this is our action creator for adding a new to do, and to dispatch this to do from our add to do component, we need to make use of a Redux hook Initially we used to do some crazy stuff at the bottom here, map state to props and some other crazy things, but with Redux hook it is much easier to now dispatch an action from this particular file. So what I'll do is that I'll import use dispatch, which is a Redux hook, from Redux library. So right here I'll say import ID structure use dispatch, and this will be from React Redux library. Sorry, I had said Redux library, but it's from React Redux. Okay, so yeah, now we can use this hook at the bottom here. Just right here I'll create a constant, call it dispatch, and I'll set it to be equal to use dispatch hook, and I need to invoke our hook here, just like that. Now I can make use of this dispatch. So instead of logging a to-do to the console, we will dispatch an action creator. Okay, so right here we'll say dispatch, we invoke it, and we pass an action creator in here, which is our add to do action creator. So what we can do is to import this action creator in this file. So I'll come at the top, and then I'll import that add to do in here. So I'll say import ID structure add to do action creator, and this will come from the store actions. So right now we are inside the to-dos folder. We need to get out of these components, go to the store. Okay, that's a long way to go. Okay, let's do this. So right here double dots, and then another double dots, and from here we can access the store, and then we can access our actions, and then we can now access our to-do actions. Perfecto. So now we can dispatch this add to do action creator right here. Okay, right here we dispatch add to do, we invoke it, and we pass our to do, this one right here, in here. So let me create some spacing so you can see what is happening. So now let me take you through the series of events that are happening. When we type something to the field, we hit submit. This on submit event will be fired. We run our handle submit function, which is this one right here. We prevent the default action, and then we dispatch an action creator, which is add to do, and we pass our to do in there, and then we reset our form. So this add to do action creator will receive that to do, which is this one, and then in here with the help of Redux Dunk we can post the dispatch, perform an async action using axios.post. The URL here is the endpoint. We pass our to do to the body of the request, and when this is received on the backend, it will be added to the database, and then we get a response, which is the to do that was added to the database right here. We continue the dispatch, and now we can update our state in our reducers using this information, the type of add to do and the to do. In case of an error, we catch the error and log it to the console. Now the last step that we can perform is to update the state, and we do this in our to do reducer. So right here, initially we just returned the state, but instead of doing this, we can check the action types and then update the state according to the action that we performed. So for now, I'll remove this one, and then we use a switch statement to switch through the action types. And then right here, we'll just say action dot type. We include different cases, and the case right now is for adding a new to do. So right here, add underscore to do, and this must be the same as this one. Okay, if you have a typo, some things won't work as we want them to. And then for our add to do, we can be able now here to return the updated state. So we can say return. We want to return an array of our to-dos. So right here we can return an array. We spread our different to-dos available in the state, and then we add our new to-do which we are receiving. Okay, so here we should have a full colon so that that error disappear. So right here, what I'll say is action. We will have a property called data, and then we can access the to-do. And then I spread the state, so we add it inside the state. So yeah, just like that. So this is the case for adding a new to-do, and we should also have a default case. So right here we can say default full colon. We simply return the state. So return state. I'll save this file, and at this point we can test our application, but we need to have our backend server running, okay, because we are trying to access our backend when we perform this action using this URL. So I'll come to my folder here where we have our MERN application. I open the backend folder, and then at the path hit cmd, and we run our backend using NodeMon. Now our backend is successfully running, server running on port 5000 and Mongo connection established. So we can go to the browser, and yeah, we have an error here. I guess it haven't completely updated. It shouldn't display an error. So I'll refresh this one manually and see if everything will go along. So yeah, here we are. This is our application. We have added logic for our form here, and we want to see if we can add a to-do to the database. So first of all, I'll come to my database and confirm that it is empty. So collections here, and retrieving collections. We have our to-do database, and users are empty. We don't have anything actually. Okay, so let's try and add a to-do. So right here I'll enter new to-do, hit submit. We get undefined here from to-do actions, but let's check our database and see if we get something. I need to refresh. I'll hit refresh here, and now we have to-dos here. When I check our to-dos, loading documents, perfect. So you can see that we are adding a to-do to the database. Name new to-do is complete false, date, and this is awesome. We can add a new to-do to our database, and that I think meets the goal of this section. Now in the next section, we can see how we can read those to-dos from the database. So in the last section, we were able to use our form to add a new to-do to the database. And in this section, I want us to see how we can get that data from the database and add it to our application state. But before we do that, we made a mistake on our to-do reducer, and I want us to correct that mistake, and then we'll continue with this section. So I'll come to my code editor here, and this is where we made a mistake. We said action.data.todo, but in our action we don't have a property called data. If I come to do actions.js, you'll see that we are dispatching an action which will have a type and to do. So the properties that we have is action.type and action.todo. We don't have data. So what is supposed to be here is action.todo. And then inside our to-do is where we'll have a property called data. So yeah, that's it, and we can verify this by logging our action to the console. So just before our return statement, we can say console.log, and we log our action in here. So when we add a new to-do, we should be able to log our action to the console. So I'll come back to the app and manually refresh it just to make sure it have refreshed. I'll add a dummy to-do, new to-do, submit, and it should log to the console here. Yeah, there we go. So you can see we have an action which will have a property called type and another property called to do. And when I expand this one, you'll see our to do have more properties, and one of them is data, and the data carries the details of our to do. Perfect. Now you understand why we are doing action.do.data. So I'll remove this, and now we can figure out how we can get the data from the backend and include it in our application state. So we'll start by creating an action creator called getToDos, and we'll use this action creator to get our data from the backend. So right here, just like we did with our add to do action creator, I will export a function called getToDos. It will be an arrow function, and it will not be receiving any data in here. And then in here is where we will return a function with the help of Redux Dunk, and then we'll use Axios to get our to-dos. So I'll simply copy what we have here just to make our work easier and paste it in here. And we can customize this to fit our needs. We won't be needing the state in this one. And then we'll use a method called get instead of post. We pass in the URL for our endpoint, which is this one, and we don't have any data that we are sending to the backend. What we get back after this process is our to-dos, an array of our to-dos. So we tap a dot then, and then we get our to-dos, and then we continue the dispatch here. Type will be get to-dos. And then we pass our to-dos so that we can access it in our reducers and update the state accordingly. In case of an error, we catch it. So now I'll come to the to-do reducer. We include a case for get to-dos. A full colon at the end here, and then we return action.todos data, just like that. Now this will properly update our state with the to-dos array. Okay, but now we need to figure out a way of dispatching this action creator from our UI. For our add to do, it was super simple. We had a submit button. Okay, when we click the submit button, we called a handler, and in that handler function is where we dispatched add to do. So how will we do that in get to dos? I'll come to our components folder, go to to dos, and then list to dos component. And we will use a hook available in React called use effect. And this use effect hook will be called every time our component renders. And once it is called, we'll be able to dispatch our action creator from there. So let's come at the top here and import use effect from React. And we will also need the use dispatch hook from React Redux so that we can dispatch our action creator. So right here, I'll also import use dispatch. and this will be coming from React Redux library. And another thing that we will need from React Redux library is the use selector hook. So right here I'll also import use selector, and this hook will enable us to select a piece of state from the Redux store. And we need to also import our action creator from todoactions.js. So at the bottom here, let's import our action creator, which is get to dos. So this will be coming from the store. I go one level up, another level up, I go to the store, and then I access our actions, and then I go to the to do actions. Okay, so to do actions here. Now let's make use of these imports. So I'll come at the bottom here and I'll set a constant called dispatch, which will be equal to use dispatch, and I invoke that hook. And then we can select the state from the Redux store. So I can set the state const state will be equal to use state. We invoke this hook, and then right here we'll pass an arrow function which will have access to the state. Okay, and this is the state from the Redux store, and we can return this state just like this, just like that. So this state will be equal to this state which is being returned, and we can log this state to the console. So right here I can say console.log state. Later on I will show you how we will select the to-dos state directory so that we can make use of it in this component. But for now, this is good enough to see whether we are getting our to-dos from the backend and adding them to the application state. Now the last thing that remains is to dispatch our get to-dos, and we will do that by calling the use effect hook just right here. So I'll say use effect, invoke this hook, and in here I can pass an arrow function which will be called when the application renders. Okay, and right here we can use the dispatch, invoke it, and then we call our get to dos action creator and also invoke it. This is dispatch. Now this dispatch will be called when our component renders, because use effect will also be called when our component renders, and we'll be able to log the state to the console. So we can go to our app and see whether we are logging the state to the console and whether we are getting our to-dos in our state. Okay, so I am getting an error of use state is not defined. So I made a typo. This is not supposed to be use state, it is supposed to be use selector. Okay, sorry for that. This is the hook that we use to select the state from our Redux store, and we imported it at the top here from React Redux. So it is not use state, it is use selector. Our application is successfully running. I'll open the console to see whether state is being logged to the console, and I can already see that we have an error, and the error is saying failed to load resource. The server responded with a status of 4.1 unauthorized, and this is because we cannot access this endpoint. Okay, we can't get our to-dos from these endpoints, and the reason is because we had protected our backend with authentication. So how we can resolve this for now is by going to our backend code and make some changes so that we can be able to access it, and then later on we will make it private again when we get to authentication section of our application. So I'll come to my backend right here, I'll stop the server, and I'll open the code with Visual Studio Code. So if you don't know how we created the backend, I recommend you go to my channel, check the other videos in this series, and you'll see how we came up with our backend. We created the to-dos API and also the Auth APIs. Okay, so here is our get API endpoint, and you can see that we had protected it with Auth, unlike our other API endpoints. So that's why we were able to post a to-do to the backend, but we are not being able to get them from the backend. So we need to modify this for now, but later on we'll come and add it back. Also, that means that we don't have a user, so I'll remove the user, and I can comment this one out because we'll need it later on. Okay, so at this point we should now be able to get our to-dos from this endpoint. So now I'll close this file. Actually, I'll close the entire VS Code. That's what I meant. And then I'll rerun my backend using NodeMon. Now our backend is up and running, and I refresh the application so that we can see whether our to-dos will be added to the application state. So I refresh here, and perfect. We have these to-dos, and it's being loaded on and on and on and on. We don't want this behavior. We don't want this behavior at all. So to stop this behavior, we can come to our code, and in our use effect we can add a comma, and right here we can add some options. Okay, so we want this use effect to load the first time, and then to prevent the reload we will use a dispatch here. Okay, so it will load again when we have a dispatch of our to-dos. Okay, so it won't keep on loading and loading and loading. It will load the first time, and then the next time it will load is when dispatch changes. So we can do something like this. Okay, so let's see if this will fix that issue. And you'll see that it loaded the first time, but it is not loading again until this dispatch changes, and this dispatch is called a dependency. Okay, we'll learn more about this later on, but for now let's see what we have in our to-dos. I'll expand the to-dos here, and you'll see that we have this property called to-dos, and it's an array of two to-dos which are available in our database. And this property is here because in our root reducer, so if I can come to the root reducer here, we added this property to-dos in our root reducer, and we set it to to-do reducer, which is updating our to-dos state. So this to-dos is the one that is appearing just right here, and now we can directly access this piece of state from the store, just like this. So instead of loading the entire state right here in our list to-dos, we can set a constant to be equal to to-dos, and then we use selector. We get the entire state, but right now we select the to-dos state only. Okay, so later on we'll be having even the all state, but we only want to select the to-dos only. And now I can log the to-dos to the console. Okay, which is an array of those to-dos. So now I can come back here, and we have an error, state is not defined, line 23. I think we just changed that, so this should resolve. Now you can see that we are getting an array of our to-dos directory. Okay, now in the next section I'll show you how we can map through these to-dos and display them on the screen. Okay, in the last section we were able to get our data from the database and included it in our application state in form of an array. So this is very awesome because in this section I want us to take this data from the state and display it on our UI. And before we get started, I want you to install another library which will help us to format the dates. So you can see this is the timestamp of our date, and it is hard to read in this form. So I want it to be in a much more readable form, just like this one, and moment will help us to do that. So just go to your terminal and install moment, and you can see I have already installed mine. Just run npm I moment, and that should install moment in your application. Once moment is installed, now you can go back to your code editor, and we are still in the todos.jsx component, and this is how we are getting our to-dos from the state. So we use the use selector hook from React Redux. We have access to state, and we specifically get to-dos from the state. Okay, what we want to do is to conditionally render our to-do component depending on whether we have to-dos or not. And also we can conditionally render this this title right here. Okay, so let's start with the title. I remove this one, and we can do something like this. We can check the length of our to-dos. So you can say I'll include these brackets because we are writing JavaScript code in here, and then we can say to-dos dot length. So this will get the length of our array. Okay, right now we have 2 to-dos in our array, so the length will be 2. So if the length is greater than 0, we use this operator. Okay, if this is true, we will display the title that we had there, the to-dos. Else we will display this message, no to-dos yet. Okay, so how this operator is working is, if this is true, if this check is true, we will have the to-dos. That means that we have to-dos in our array. Else we will display this one. Okay, and that's all that we have for the title. And then we don't need to press multiple to do here, so I remove that. All we need to do is to use an array method called map. Okay, so we'll do something like this. I include these brackets because we are writing JavaScript code inside our JSX. I say to do's end. So this will basically check whether we have to do's or not. If we have to do's, we will continue with whatever we are doing next. Okay, else this process will just be terminated. Okay, so if we have the to do's, then we will do this to do's dot map, and this is an array method which will help us to loop over our to do's and display each to do at a time. So when we map, we will get each to do at a time. So in here we are using an arrow function, and then we can do something in here. Okay, we can include a return statement, and what we will return is this particular component. Okay, so if we have to to-dos, this component will be displayed twice. Okay, and for us to display the details of that particular to-do, we need to pass the properties of each of the to-do in this particular component. So right here, I'll just use a break so that we can clearly see what we are doing here. And the first thing that we can pass is our entire to-do. So right here you can say to-do will be equal to do, and we can be able to read the properties of that to do in this particular component. And then we also need to have a key. So key, and key must be unique, so we can make use of the to do ID as a key. So right here we'll say to do dot underscore id. So if I come to the browser here and check our id, you'll see it have an underscore id. Okay, and this id is unique and it was auto generated by our MongoDB. Okay, so you don't need to worry about how this id came along. So there we go. Now we have a to do and we have a key. Perfect. And these are the two props that we need so that we can display our to do in the UI. Now at this point we are done with the list to do's component, and the next thing that I want us to do is to jump to this particular component, our to do component, and do some changes. So I'll go to the to do component here, and at this point where we are creating our to do component, we can receive that to do that we passed as a prop right here. Okay, so this to do is the one that we passed here. Okay, this one. So we are passing it as a prop, and we can take it from the prop right here. So I am doing a destructuring right here, okay, using these brackets, and we get our to do. And now we can use this to do and read its property and display it on the UI. So instead of learn React, we can do something like this, to do dot name. So this is one of the property. This is supposed to be a small cap, to do dot name, and this will give the name of our to do. And then for the author, currently we don't have an author for our to do. When we add authentication, we'll come and fix this. But for our date, we do have a date. Okay, so right here we can say added, and then I use the curly brackets here because it's JavaScript, and right here is where we are going to use moment. Okay, and the moment will help us to format our dates. So the first thing that we need to do is to import moment at the very top. So right here I'll import moment, from moment, just like that, and then I can use it here, moment. We invoke it, and in here we pass the timestamp of our to do, which will be available in to do dot date. And then at the end we include a method from now. And there are various ways that you can format the dates in moment, and you can check its documentation by going here and searching for moment. Okay, moment.js, and you can see the different methods which you can use in moment. So we have dot calendar, and this is the one that we just used, from now. We have from now. Yeah, there are a lot of them. So depending on how you want to display your date, you can come to moment and check what is included in its documentation. Okay, perfect. Now this date will correctly display. Another thing that we can do is to conditionally render our buttons depending on whether a to-do is complete or not, and also we can conditionally render our name depending on whether a to-do is complete or not. So what we will do at this point is to add some styling at the top here, where we had the make style hook. So we can add a few styles so that we can conditionally render depending on whether a to do is complete or not. So right here you can say is complete, and this will help us to change the color of our button, and I'll set the color here to green. And then I can include a comma, and I'll include checked. So if it is a to do is checked, we can change the text decoration, and I'll include this style line hyphen through. Okay, now to make use of this, we can come right here and check whether a to-do is complete or not. So I'll use the curly brackets, and we have a property called is complete. So to-do dot is complete. If a to-do is complete, then we want to render a particular text, which is this one right here. So if it's complete, we want to render this. Okay, so what I'll do, I'll just include a spacing here, select this one and move it at the top, and I should wrap it inside these brackets like that. I remove this spacing. So if to do is complete, we will display this component, which is a typography to do.name. Else we will display this component. I'll include the brackets. So what I'll do, I'll just copy this one and paste it in here. Now the difference is in the styling. We want the first one here to have a line through because that to do is complete. So what we can do is to include a prop here called class name, which will be equal to oops, sorry, this is supposed to be this way. So we'll have a class name which will be equal to classes dot checked, and this is the styling that we just added here. So this name will have a line through, else we will display this component at our typography here, but it won't have a line through. Okay, the next one is to conditionally render our button, the check circle button. So we will do a similar thing. To do dot is complete. We used our question mark here, and then we display our first component, which is this one. I'll copy it. I'll actually cut it and paste it here. Else I include a full colon. We will display a similar component. I'll copy that and paste it here, but the difference will be in our color, and we included a style for the color, which is this one, is complete color green. So to do is complete. If a to do is complete, we display this, else it is not complete, so we display this. So this is the point where a to do is complete, so we should include our styling in this button. Actually it's our check circle we need to style. So right here I'll say class name, and I'll set it to classes.isComplete. So just like that, if I save, Prettier will auto format my code. Yeah, and I hope you have understood this. If a to-do is complete, we will have a green check circle, else it will be grayed out. And then we'll also have this name properly formatted. And this is how we can dynamically display our to-do. So for now, I think we have achieved our goal. All we need to do is to run our application and test it out and see whether we are correctly displaying our to-dos. So I restart my development server right here. So npm start. So you can see our application is loading, and currently we have no to-dos yet. When the to-dos loads, the title changes, and then we have our to-dos listed at the bottom here. So perfect. You can see now we have new to-do. This is from the database, and then added 20 hours ago. Then we have this one, new to do. So yeah, and we can try to see if our is complete functionality is working. So we can go to the database and change the status of one of our to-do. So I have my database here. Okay, let it load. So right here we have all our to-do set as false. So for our new to-do here, the first one, we can change the value to true so that we see whether it will change to something else. So right here I can set it to true and update. It have updated. When I come back, we don't see the changes immediately, but we need to hit refresh. And you see now this is green because the status of our to-do have changed and we have a line through. So our display is working perfectly, but for the other until we add authentication is when we'll come and display it correctly. Now I want to show you something. If I add another to do, another one like DJ CRUD, I submit, it should appear right here, and there we go, another one. Yes, and it's a few seconds ago. So this is happening because we are correctly updating our state when adding a new to do. So if we come to our reducer, to do reducer, you'll see that when we are adding a new to do, we took the existing to do's, which is this one, we spread them and add the new to do to the state, and once it's added to the state, it can correctly be displayed on our UI. Okay, so that's why we did this. Okay, perfect, and I hope now you understand why. Now in the next section I want us to see how we can update a to do. Okay, so far we can be able to add a to do to the database and also fetch that to do and display it on the screen. Now in this section I want us to see how we can edit a to do. And this will be a tricky one because we'll be using the same form for adding a to-do to edit a to-do. So when we click this edit button, I want us to populate our form here with the data of our to-do, and then we will need to figure out how we can differentiate whether we are adding a new to-do or we are updating a to-do. But don't worry, I'll try to go step by step so that you understand everything, and I am hoping everything will work out. Okay, so we will start by creating an action creator for editing a to do. So let's go to our code editor and open the to do actions. Now at the bottom here is where we can create an action creator for editing a to do. What I'll do is that I'll just copy this one, the whole of this, copy, come at the bottom and paste it here. And then we can customize it to fit the update to do action creator. So here we'll say export const update to do. And then right here we will receive an updated to do, and also we will need to have an ID of that to do. So we will also have an ID, and then we will return dispatch, and I don't think we'll be using get state in this one. And then right here we'll have Axios, and the method that we will use is put. And then we tap our endpoint, so we will have URL stroke to do's, and then for updating a to do we'll also need to pass the ID of the to do that we are trying to update. So right here I'll say stroke, I use the $sign and the curly brackets, and then I pass this ID of the to do that we are trying to update. So I press the ID there. So now this will be the endpoint for updating a to-do. And then right here, we will include the data of our to-do, which is the updated to-do. Updated to-do. Okay. And what we will get back is a to-do. And then the dispatch will have a type of updated to do or update to do. So this is an action. We can say update to do, and we can read the data of our to do on our reducers and update the state accordingly. Okay, so this to do will be different from this one, and that is because the action type will be update to do and not add to do. So don't worry about the similarity here, it won't affect our operation. And then in case of an error, we'll simply catch the error and log it to the console. And that's it. This is an action creator for updating our to-do. Perfect. Now let's go to the next step of updating the state in our to-do reducer. So just after our case here for adding a to-do, we can include a case which will be update to-do. And then at the end here, a full colon, and we return something. So what I want us to do is to map through the to-dos that are available in our to-do reducer state. Okay, so this state is specifically for the to-do reducer, which is an array of our to-dos. So return, we read the state which contains an array of our to-dos. So we'll say state.map, and then when we invoke this, we will loop through each to-do. Okay, so remember this state contains an array of our to-dos. Okay, and we can perform a check to see whether we are updating any to-do in that particular array. So this is an arrow function, and we can do something in here, and what we will say is perform a check if to-do dot underscore id, and this is from our state, and an already existing to-do is equal to action dot to do dot data dot underscore id. Now this to do is the one that we have already updated in our action creator. Okay, so remember when we perform a then method here, this to do is the already updated to do, but it will have the same id as the to do that already exists in our state. And remember what we are trying to do here is to update our state so that our UI can correctly also update. Okay, so if to-do.id underscore id is equal to action.todo.data underscore id, we can use the question mark here, which is our ternary operator. So if this is true, it means that we are trying to update a particular to do, or we have already updated a to do, which is this one. This is the updated to do. So if this is true, we will return the updated to do to our state. So right here we'll say action dot to do dot data, and this is our updated to do. So we will return that to do instead of the old to do. It's like replacing the old to do with this new to do. Else it means that we are not updating any to do. Okay, everything is remaining the same, so we will simply return our old to do. So right here we'll simply say return to do, and this is the to do which is available in the state. So just a recap, what we are doing here is that in the state we have an array of to-dos, and we want to select a particular to-do which we are updating and replace it with the new data. Okay, so right here we will map through each to-do, and then for example, if this is the first to-do, we will check it right here. We'll check its ID, and then we'll check the ID of the updated to do. If the ID does not match, we will return the old to do. Okay, so we won't change that to do, and then we will check the second one, maybe this one. Now maybe this one is the one that we actually updated, so we'll check its ID here, and we'll check if it's equal to the updated to do, and because it's the one that we have updated, the ID will be the same. So we will update that to do by replacing this old to do with this new data. Okay, and this one will be ignored. So we will replace that specific to do, and then the rest of the to do's will remain the same. And this is what is happening in this line, and hopefully you have understood what I have said. Okay, now this will correctly update our state, and then in our to do actions, this will correctly update our to do in the database. Now what remains is to figure out how we can dispatch this action creator from our UI. And the first thing that I'll do is that I'll come to the add to do component, and this is where we were adding a new to do. Okay, and for your information, we'll be making use of this same form right here to update our to do, because this is the same input field right here. But this component, this add to do component, will be somehow connected with our to do component, which is displaying the data. So when we click this button, we need to autofill this field with this data. And how we can do that is by using our set state right here, set state method. But when you look at our component tree, this todos.js is the parent of add to do and list to do's. Okay, this is the parent. So add to do and list to do are child of to do's, and that is how these two are related. And then to do is inside the list to do's. So what we can do, because we are making use of the same set state, this set state will update our field, this particular field, which is available in our add to do, and we need to make use of it in our to do component so that we can correctly autofill our form here when we click that button. So what I'm trying to say is that we need to perform something called raising the state. So we need to take this code out of here and take it to our parent component so that we can use set to do both on our to do here and also on our add to do.jsx file. So I'll copy this, actually not copying, I will cut it. Okay, so I'll cut this, and this is called raising the state, taking the to do from a child component to a parent component. And then we'll go to the todos.jsx file, and just before the return statement here is where we will define our state, just like that. But now we need to use this to do and set to do in these both components, and we'll do this by passing them as props. So right here in our add to do component, we will pass to do as a prop. So to do will be equal to do, and then set to do will be equal to set to do. Just like that. And we'll reuse this one, so I'll copy it, and we'll also need it right here. Actually what we need in our list to do's is only set to do. I don't think we'll need to do right here. So let me just remove that, and we pass only set to do to this list to do. Now in our add to do component, we will receive to do and set to do as props. So I'll come back to the add to do component, and I'll receive them as props. So I'll destructure them. Right here we'll have to do, and we'll also have set to do. And with this we can correctly spread the to-do, and also right here we can set to-do and also spread it and add new values. So yeah, now the next step, I'll come back to the todos.jsx file. So the next step, we need to go to this reach-to-dos component where we are receiving set to do as a prop. So I'll come to list-to-dos.jsx file, and we receive set to do as a prop. So right here, set to do. Okay, now we have that, and we also need to pass this set to do as a prop to our to do, because in our to do is where we have a button for updating a to do. So right here, I'll pass set to do as a prop. So set to do will be equal to set to do. Just like that. And now we can come to the to do file and do some state update. First of all, we destructure set to do from here. So set to do. Okay, perfect. And this to do was coming from mapping all our to dos. And yeah, now let's come to this to do file here and make use of set to do. Now at the bottom here, where we have our button group, this is where we are having a button for for editing a to do. This create icon button is the one for editing a to do. We will add an on click event, and then we'll call a handler function, and we can call this handler function handle update click. Okay, here we'll have an arrow function and handle update click, and we invoke it. Okay, now when we click on this icon or this button, we will call the handle update click. So let's go ahead and create this function at the top here. I'll say const handle update click. It will be an arrow function, and then in here is where we can update the state of our to do. So we can make use of set to do, and we invoke it, and what we will pass here is the current to do that we are trying to update, and it is this to do right here. And remember, this to do was coming from our list to do component after we map through all the to dos. So we will get each to do at a time, and when we click on a button for that to do, we will update the state with it. Okay, so this should correctly update the state of our to do, and we can scroll at the top every time we click on that button by using this method. So we have access to the global object called window. So I can say window, and then dot scroll scroll to use an object in here, and we can set top to 0, and then left to 0. This is a comma, not a semicolon. And then lastly here, behavior smooth. So we want it to be a smooth scroll. So behavior to be smooth, just like that. Now when we click that button, we will set the state to this, and we will scroll to the top. Now the next step is to come to our add to do component and perform a check whether we are creating a new to do or we are updating the to do. Remember, when we update the state of that to do, the value will be taken from that to do right here. Okay, because it's the same state. So and I can see here we had use state and we removed it. So I can remove this use state. Actually, I can just cut it and then go to our todos.jsx file, and we need to import it here because this is where we are using use state. Okay, perfect. So what I'm saying, this state is the same for add to do and rest to do. So when we update the state from here, this state is the one that will also be passed to our add to do component. When creating a new to do, this to do will not have an ID, but when we click the update button, this to do will be coming from the database and it will be having an ID, and that ID was auto-generated by MongoDB. So that is what we are going to use to differentiate between whether we are creating a new to do or we are trying to update a to do. So let's come to our add to do component, and where we are submitting the to do, we will perform a check and then perform a dispatch depending on whether we are adding a new to do or we are updating a to do. So right here I can just say if to do dot underscore id exists. If it exists, it means that we are updating our to do. If it does not exist, it means that we are trying to create a new to do which does not have an ID yet. Okay, so we'll do something in here. So in here is where we can perform a dispatch of updating the to do. Else we will dispatching this to do right here. Okay, so you can see the difference. Now we need to import our action creator for updating a to do, and the action creator was update to do, and they are coming from the same file. So just use a comma and then update to do, and right here we can reassign to do.id to be simply id. So I can say const id will be equal to do dot underscore id, and then we can define the properties of our updated to do. So right here we can say updated to do. Actually I can just say const updated to do will be equal to, we set the properties of our updated to do, and an updated to do should have all the properties that we included on the backend so that it does not throw an error. Remember, updating a to do means that we are replacing the entire to do, specifically when we use the put method, okay, instead of patch. So I can set the name to be to do.name, and then is complete will be to do dot is complete. Date will be to do dot date, and then author, in this case we can manually set the author to be a string because we don't have an author yet. I can set it to Chaoo, and later on we can also add a UID when we add authentication in our system, but for now this will do. And you might be asking yourself, why can't we just pass this do right here? Now this to do have a property called version, and in our backend we did not include a version property that was automatically added by MongoDB, and that version might throw some errors. So that's why I did this, and yeah, it will work when we do this. When we pass it directly, it will throw an error. Now the only thing that remains is to just dispatch our updated to do using the dispatch right here. So right here I can just say dispatch. We can just say dispatch we invoke it update to do, and in here we pass updated to do, updated to do, and also we pass the ID of our to do, which is this one here, ID. Okay, so our action creator will receive the updated to do and the ID, and then we will correctly update the to do. And when I come back to add to do.js, .jsx, I also want us to change some things, and it is right here, the date. So when we are updating a to do, I don't want us to set a new date. I want us to reuse the old date. But when adding a new to do, I want us to set a new date. So what I'll do, I'll just cut this just like that, and I'll update the date right here when adding a new to do. Okay, so right here I can just say const new to do will be equal to, I spread the properties of our to do, and then I use a comma and I set the date. Okay, sorry, I use a comma and I set a date to be new date. Now with this implementation, this date will be the old date of our to do. Maybe you can add a date for when the to do was updated, but for now this works. And then this one is the date of adding a new to do. And the way we are differentiating whether we are adding a new to do or we are updating the to do is by using the ID. Okay, remember when you click the edit icon, okay, we will populate our form with the existing to do, and that existing to do will have an ID, and then we can check if the ID exists. If it exists, we know we are updating the to do, and we'll perform a dispatch of this action creator. Else it means that we are creating a new to do and we haven't gotten an ID yet, because that to do does not exist in the database. So we create a constant here called new to do. We pass the data of the to do, and this is the new to do, so it means that it will only have the name. Okay, so it will only have the name and is complete, which was the default. So we will have that, and then we'll add a date, and then when we send it to the backend, an ID will be automatically assigned to it. And then right here we dispatch the to do, and we have renamed this one to new to do, so we need to also rename this to new to do. And in our to do actions, I'll come at the top and rename this one to new to do. But if you left it as to do, it would also work, but for consistency we can rename it to new to do, and we add the new to do to the database just like that. Now one more thing that we might have messed up is in our to do reducer. So this was correct, the implementation here is correct, but we should directly return this without these curly brackets, otherwise it will throw an error. Okay, so remove that, and we should have something like this. We are directly returning this line, and that's it. At this point I am hoping this should work. It should correctly update our to do. So I'll run my development server and test this application on our browser. Now our application have loaded. When we hit one of these buttons, we should populate this form with our to do. So let's try this one. I hit it, and perfect, we are populating the data with this to do, and the data here now will have an ID. And when we try to submit this, what will happen is that we will check if there is an ID, and then we will dispatch the appropriate action creator. So let's try to perform an update maybe old to do, submit, and you can see that the data here changed to old to do. So perfect, we are perfectly updating our to do with this implementation. So when I click this one, you can see another one, and maybe we can change to something like learn Redux. I submit, and this should update to learn Redux. So we are perfectly updating our to do. Now that's it. That's how we can update the to do. I hope everything was clear, and I'll see you on the next section, where maybe we can move from the logic section and try to add the React Toastify, so that we can see messages of actions we perform in our application. And then after that, we will quickly perform marking to do as done and also deleting a to do. In this section, I want us to do something fun, which is adding some toast messages in our application. So all you need to do is to come to your terminal, and then you run this command npm I react toastify, and this will install React Toastify in your application. You can see I have already done that, and I'm using version 7.0.3. Now let's make use of this library. The first thing that you'll need to do is to go to app.js, and at the very top we will import a component from React Toastify called toast container. So just right here I will say import toast container, and this is from React Toastify. Another thing that we need to import is the React Toastify CSS file, and this is how we import it. You will say import, you use these quotes, and then React Toastify stroke dist stroke React Toastify .css. Now let's load this component just right here after our browse router. So right here you'll say toast container, just like that. Okay, and then now we can make use of a toast object to display different messages in our application. So what we need to do is to jump to do actions.js, and in addition to logging a message to the console, we will also toast an error message. So right here we will toast an error message, but before we do that we need to import the toast object from React Toastify. So let's go at the very top and import it. So I'll import ID structure toast from React Toastify, and then now we can make use of this toast. And I want us to toast error messages for add to do and also for update to do when a user performs an action. So for add to do, when we log the message to the console, we can also toast an error. So we'll say toast dot error, and then the error message will be available in error object dot response. And then we have another property called data. Okay, and with this we will get the error message which we customarily added on our backend. But sometimes this response may not always be there, and it may take some time to process. Now to safely load this error message, we can use something we called an optional chaining operator. So right here we will include a question mark and then a dot data. Now when the response is available in our error message, we will safely load the message, else this will be just undefined and no errors will be thrown. Okay, and this is called optional chaining. You can read more on it, and also we can change the default position of this error message. So right here I can include an object and then I set a property called position and a full colon. We say toast dot position and then dot bottom. You can see the different options that are there: bottom center, bottom left. What I want is bottom right. So yeah, this is it. So I can just copy this and paste it right here. It's just the same thing, but it will load different error messages. Now this is in case of errors. In case of a successful operation, we'll go to our reducers. So to do reducers or to do reducer, and we will toast a message here. So first of all we need to import the toast. So I'll come to the to do actions again and copy this line, and then in our reducers I'll paste it at the very top. Now for our add to do, we can say toast dot success, and then we can enter a custom message, and all we will say is a to do was added. And I can include 3 dots, and then we can position this at the bottom right. So position full colon toast dot position, and then dot bottom right. And now if we successfully add a to do, this message will be shown. So I can copy this and paste it on our update to do, and the message will be now a to do was updated. Okay, now we can test our application and see if these toast messages will appear. Okay, now I'll go back to the browser, and I'm hoping that it have refreshed. Let's try to add a new to do, maybe learn CSS, submit, and perfect. A to do was added, a green toast message, and you can see learn CSS here. Let's try to edit. Maybe we wanted to say learn JS, submit, it's updated, a to do was updated. Let's invoke an error. When we enter like 2 characters, this won't go through because on our backend we had set a minimum of 3, so we should get an error. Submit and name, length must be at least 3 characters long. So you can see we are getting this message from the backend. Now in this section I want us to mark a to do as done or not done, or checking a to do. But before we do that, if you want to avoid these outputs, you can come to list to dos component and remove this console.log message. Okay, and that should do it. And to mark a to do as done, we need an action creator for that. So I'll come to do actions.js, and I'll scroll at the bottom here, I'll just copy the whole of this action creator and paste it at the bottom, and then we'll customize it to fit our needs. So this, we can call it check to do, and all we will have is an ID of the to do that we are trying to mark as done or not done or to toggle, and then we'll return a dispatch and we'll use Axios. This time the method is patch, and this will be our endpoint together with the ID, but we won't be sending any to do to the backend. We will simply send an empty object, but we won't be using it on the backend. We will be using the ID to access the to do from the backend, and then updating the is complete property by doing a toggle. And then right here we'll tap a then method, and we will get a to do that have already been updated, and the only thing that will be updated is that is complete property. And then we will dispatch a type of maybe check to do, and then we will also pass this to do together with the type. Okay, and we can use these two properties to correctly update the state, and this will remain as it is to display the error. Now let's go to the reducer, which is right here, and how we will perform an update for that check to do is the same way that we did for this case. Okay, so all I'll do, I'll copy the entire of this case and duplicate it at the bottom here. I'll use Alt Shift and the bottom arrow, and then right here I'll just change the case to check to do, and then we can send a message here of a to do status was changed. And then the position of our toast will be there, and this will remain as it is. Now the only thing that remains is to dispatch our action creator from our UI, and we'll do this in our to-do.jsx file. So when we click the check circle button, we will call a helper function which will dispatch our action creator. So I'll come right here, and this is where we performed a check, and I want to change something so that we can easily do this. Okay, instead of adding on click event on two buttons, we can remove this button. We can also remove this one, and then I can take this at the very top before our check here, and I can take this at the bottom after our check. And if I save this, it will be properly auto formatted, so you can see what is happening. We only have one button, but the icon is the one that will be conditionally be rendered. And now we can only add one on click event on this one button. So right here I can say on click, which will be equal to, I use this curly brackets, an arrow function, and we can call our helper method handle check, and we should pass the ID of the to do that we are trying to check. So I can say to do dot underscore ID, and now we can create this function real quick at the top here. So right here I'll say const handle check, and this will be an arrow function, and right here we will receive the ID, and then in here is where we dispatch our action creator. So we don't have dispatch imported in this file, so we need to import use dispatch hook from React Redux. And then I can make use of use dispatch right here, which will be equal to use dispatch. We invoke that and we dispatch our action creator right here. Actually, we should also import our action creator. I'll just import it at the bottom here, which is check to do, and this will come from our store stroke actions stroke to do actions, just like that. Now we can dispatch it, and I invoke it. So now when we click this button, we will call, where is it, this one. When we click this button, we will call handle check. We'll pass the ID of that to do, and we are receiving that ID here. We can rename it to be just ID. We dispatch the check to do action creator, and we should also pass that ID right here, so that in our action creator we will receive that ID and properly update our to do. Okay, and it will only update that one property of is complete. So at this point we can test our application and see if everything works. So I'll come back here and maybe do a manual refresh. Let's try to mark Learn.js as done. So I'll click check, and a to do status was changed, but you can see this icon did not change. Okay, so if I mark this as done, a to do status changed, but this icon did not change. What about if I refresh? So you can see that they were actually updated at the backend, but our state is not properly being updated. So I have taken a look as to why our UI is not updating correctly whenever we press this check icon. Okay, so when I check, the to-do will actually update, but our UI is not updating correctly until we refresh, and that is a bad user experience. So I have checked at my front-end code right here, and everything is fine. There is no issue with the front-end code. The reason why it is not updating correctly is because what we are getting here from the backend is still our old to do instead of the updated to do. So in our to do reducer, when we try to update the state here, we are updating the state with the old to do instead of the new to do. So the issue is on our backend. So you can open the backend code and then go to todos.js, and at our router.patch, this is where we were marking a to do as done. Let me expand this because it's looking weird. Yeah, perfect. So this is where we were marking a to do as done. We were taking the ID and getting that to do from the database. So this is the to do, and then we performed an if statement if the to-do does not exist, we return this message to the client, else we update the to-do using these lines of code. So we await to-do.find by id and update. We use the id, which is request.params.id, this one which we pass in our URL, and then we change the is complete, okay, by negating this one. So if to-do.isComplete is false, we change it to true, else we change it to false, okay. But what we are missing is that we miss this kind of a flag, new to true, and this flag will enable us to return the updated to do instead of the old to do. So this will be the old to do instead of the updated to do. For this to be the updated to do, we need to pass a new flag just like this one. So we will include a comma here and then paste that flag, okay. And this flag, we included it here when we were editing a to-do. So this is our put request endpoint. And if you don't know how we did all this, go back to this series and watch some of my previous videos in this series so that you can get to understand how we created these endpoints. And this should fix it, okay. So if I check my server here, it's restarting, and I think I can cross this one because I'm not using it. So once this one starts, we can test our front end right here. So now I will refresh this one so that we can get our application state correctly. And now let's try to mark this as done. We should correctly update our state. I mark it as done, and there we go. Now it's going through. I mark this one as not done, and there we go. So now everything is working for marking a to-do as done. In the next section, we are going to delete a to-do. So in this section, we are going to try and delete a to-do. And the first thing that we are going to do is to create an action creator. So I'll open the to-do action creator. And what I'll do is that I'll copy the whole of this code and paste it at the bottom here. We change the name of check to do to delete, and here we will receive the ID of the to do that we want to delete. We return a function. We use axios.delete method, and right here we'll only pass the URL. We don't need this empty object, so I'll remove that. And then right here we will just dispatch an action of type delete, okay. So we don't need to pass any to do here, so I'll just dispatch an action of type delete, and then I'll pass this ID of that to do right here, and then we catch the error, okay. And this is the action creator for deleting a to do. Now let's go to our to do reducer and update the state. So right here I'll copy this code for checking a to do and paste it at the bottom. I will save so that we can correctly auto format it and change the name of the case here to delete to do. Right here we will toast a message, a to do was deleted. And then for updating our state, we will use an array method called filter, okay. So right here, instead of using map, we will use filter dot filter, and then right here we will filter our to-dos and exclude the to-do that we just deleted. And how we will do that is by doing this to-do dot underscore id, and this is the to-do that is available in our array of our to-dos right here. This is the state of our to-dos, and it's an array of those to-dos. So we'll get the to-do from the array, and we'll exclude a to-do that we just deleted. So right here I'll say if to-do.id is not equal to action.id, just like this, and I remove this part just like this. So what this code will do is that it will exclude the to-do._id that matches action.id. Okay, it will return all those to-dos that does not match with this particular id, and this action.id is the one that we have included in our action creator here. So action.id, and this code should correctly update our state. So for now, we need to figure out a way of dispatching our delete to do, and we'll do that on the UI, where we have an icon for deleting a to do. So right here, first of all, we will import the delete action creator right here, which is delete to do, and then at the bottom here, where we have our delete icon, we will add an onClick event, which will be equal to an arrow function, and right here we can call handle a delete helper function. We currently don't have this function, so we can create it here. Actually, I'll just duplicate this. So this function will be handle delete, and then it will receive an ID. So we need to pass the ID of the to-do that we are trying to delete here, like we did in handle check, to do dot underscore ID, and then at the top we dispatch the delete action creator, just like that, and then we pass the ID. So that ID will be received right here. We will perform an axios.delete, and then this is the endpoint where we pass also the ID, and then we'll dispatch an action of type delete, and we pass the ID here. And when we come to our reducers, we will use the filter method to exclude that to do in our state, so that we only have those to dos that are not deleted. Now, yeah, that's it. Now we can test this application. So let's try to delete a to do, this one. A to do was deleted and it's gone, it's not here. Let's try to delete old to do. It's gone, it's gone, it's gone, and our delete functionality is working. We can confirm this by going to our database. Now we should not have any to dos. So I'll come here and hit refresh, or at the top, and the query result is 0. We don't have any to dos in our database. And I guess now we have achieved the goal of this whole video, which was about CRUD operations. we can create a new to-do. We can update this new to-do using this icon. We can mark a to-do as done, and also we can delete a to-do. Now in the next video is when we will handle authentication. So we'll see how we can sign in a user, sign up a user, sign out a user, and also perform other auth functionalities in our application. So thank you for watching. If you like the video, please leave a thumbs up and remember to subscribe. Hey, what's up guys? So in this video we are going to perform authentication in React and Redux. So we'll have a form where we can sign up new users, and then we'll have another form where we can log in registered users, and once you are logged in you can be able to sign out from the application. We will also be making use of JWT, which stands for JSON Web Tokens, and local storage for persistency. So we'll be able to get a token from the server and then store it at the local storage and the application state in order to know the currently logged in user. And then we'll be able to perform conditional rendering depending on whether a user is logged in or not. Now, in case you are not aware, this video is a continuation of the ongoing MERN Stack series in my YouTube channel. So I leave a link at the description section below to this particular series or playlist, so that you can see how we created our backend using Express, MongoDB, and also Node.js. So we were able to create all the CRUD operation API endpoints and also the Auth API endpoints in this particular video. We also created the UI using React, React Router, Material UI, and we were able to perform CRUD operations using React and Redux hooks. So right here I have the live version of the application where you can go to the sign up form and also the sign in form and sign in a new user, and I'll also leave a link at the description section below to this live version of the application so that you can test it out. Okay, in case you're new here, my name is Charles. I am a JavaScript developer, a coffee lover, and I create coding content here on YouTube. Now that sounds awesome, so please make sure you subscribe so that you don't miss any of my future videos. So in case you want to reach out to me, you can do so through my Twitter, which is @ChaooCharles, or you can leave a comment at the comment section below. Now to start with, we are going to create an action creator for handling sign up. Okay, remember we are using Redux, and right here we had our to do actions up to where we reached, and we were able to perform all the CRUD operations. But in this video I want us to move on to authentication. So from our actions, I'll be creating a new action creator for signing in the users and also registering the users and performing all those auth operations. So I'm going to say auth actions.js, and I'm going to come to the to do actions and copy this first portion of the to do actions up to this get to do's action creator. I will copy that and then go to the auth actions and I'll paste everything in here. So we will need to make use of Axios to perform HTTP request. We'll make use of this URL, which is coming from the API folder right here. If I click this index.js, you'll see that the URL is simply our server endpoint, which is localhost 5000/API. So I'm grabbing this and then coming to the auth actions and importing it here. We'll make use of React Toastify for toast messages, and then we need to customize this action creator to fit our needs. So the first thing that we can do is to rename it to sign up. So right here I'll say sign up, and then with the help of Redux Dunk will be able to return a function in here and be able to perform a HTTP request or a network request. We'll have access to dispatch for continuing the dispatch of our action, and then we'll use axios.post. Okay, so this time we are using the axios.post because we are creating a new resource to the database, which is a new user. So right here we'll say axios.post, and then the URL here will be the URL, which is this one here, http localhost 5000/API, and then we will add something on the front end so that to hit our Auth API endpoint for signing up the users. So instead of stroke to dos, we will say stroke sign up. And right here we will be getting in a user when we dispatch this action creator from our sign up form. So right here I'll get in a user, and then we can store this user now to the backend. So right here when I say user, this user will be received by our API endpoint and the user will be saved in the database. And then once the user is saved, we will be automatically get logged in to the system by getting back a JWT token. So what we get back from this post request is a token, which is a JWT token. So right here I'll say token, and then we can dispatch an action here, and the dispatch here will be sign up. So sign up, and now we can access this sign up from our reducers and update the state accordingly. But right here we also need to dispatch the token itself. So right here I'll say token, and I'll use a full colon because the token will be actually available in token.data. So right here I'll say token.data, and that token will be stored in this particular property called token. Okay, in case there is an error, we'll be able to catch that error and log it to the console, and also we can toast it right here. So I can use React Toastify. I'll say toast dot error, and I'll say error dot response dot data. So right here I'll use this question mark in case we don't have the response. There will be no error that will be thrown. Okay, so this is a safe way of loading the data from our error. Okay, and then we can position our toast right here. I'll say position a full colon, I'll say toast dot position, which is this one, and then dot bottom right. We have a suggestion there. So yeah, this is it. But for persistency, I want us to also save this token which we are getting from the backend to the local storage. Okay, so in JavaScript we have access to an object called local storage. So just after this one, before we dispatch the action, we will say local storage, and we have a method called set item, just like that. And then when I invoke this method, the first parameter here will be the property of whatever we want to store at our local storage. So the key and value pair is what is happening here. So right here we'll have a token which is our key, and then the value will be token dot data, just like we did here. Okay, the token string is available in token.data. So right here we pass token.data, and now when we successfully get a token, this token will be stored at our local storage. And this is an action creator now for signing up a user. Okay, this is all we need to do. The next thing we need to do is to dispatch this action creator from our sign up form. So what I'll do, I'll go to the sign up form. In our components, I expand auth and then go to sign up. So for the sign up form, we need to make use of state and also our action creator for us to successfully get the values here and send them to the backend. So to start with, I'll import use state from React right here. So I'll say use state, and this is not uses, it's use. And then after we declare our component here, inside here we'll make use of the use state. So I'll say const we destructure user from the use state here, and then set user, and this is the method that we'll use to update our state here, and we set it to use state. I invoke this, and in here I can pass default values for our user state. Okay, so we expect a user to have a name, so I can default that to an empty string. We also expect a user to have an email, and I'll default that to an empty string. And also we expect the user to have a password, and I'll default this to also an empty string. Okay, now I can come to each of these fields and update each of these values depending on the field. Okay, so the first thing that I'm going to do is that I'll set a value prop here. So I'll say value will be equal to, I use these curly brackets and access the name, so it will be user.name right here, user.name. And then now we can update the name using onChange event. So right here I'll say onChange will be equal to, as these curly brackets, we get an event here, and then I make use of set user. I invoke this, I spread the values of the already existing user, which are these values here. So in here I'll spread the values for the user, but we want to update the name, the name field. So right here I'll set the name to be e.target.value. Yeah, I guess that's correct. Okay, when you type on this particular field, we will update the name to be equal to that particular value that you type in. Okay, so we will do a similar thing for these other fields, and I like copy pasting to make my work easier. I'll copy that, paste it here, change this to user.email, and then we use the set user. We spread the properties, but the thing that we are changing here is the email property. I go to the password. After this I paste this one, and then I use the user.password, and then I update the password right here, just like that. So all our fields are set. Now I need to create a helper method which will be called whenever we submit this form. Okay, so right here I'll have an onSubmit event. So onSubmit, and we will call a helper method, and we can call it handle submit, just like that. We haven't created this method yet, so let's come at the top here and create the method just before our return statement. I'll say const handle submit, which will be equal to, it will accept an event, and this is an arrow function, just like that. And the first thing that we will do is to prevent the default action of submitting a form. So right here I'll say e.prevent default. So this will prevent the browser from refreshing or the page from refreshing, and I invoke that. And then after this is where we can perform a dispatch of our action creator. So to dispatch an action creator, we will need to make use of some Redux hooks, and the specific Redux hook is the use dispatch hook. So right here we can import use dispatch, and this will be coming from React Redux. So I import use dispatch, and also I import the use selector hook. So we'll use this use selector hook later on when we want to select some piece of state from our Redux store. So use selector, and all this will be coming from React Redux. React-Redux, and I forgot a from here and the spelling for this one. I guess that is right. Okay, so this is what I am interested in, the use dispatch hook. Okay, and it's coming from React Redux. So I'll come just after our classes here, and I'll set a constant called dispatch, and I'll initialize the use dispatch hook. Dispatch, I invoke it just like that. Okay, now we can make use of this dispatch inside our handle submit helper method. So right here I'll say dispatch, I invoke this, and we should now dispatch our action creator just right here. Okay, but we need to import that action creator from our auth actions. So right here, let's import our action creator. I'll say import the sign up action creator, and I need to wrap this inside the curly brackets because these are named export. So if I come to the auth actions here, you can see export const sign up. So it's a named export, and we should use these curly brackets to destructure it. Okay, I'm lost. We are here. So all this will come from our action creator, which is very far. We need to get out of the components folder so that we go to the store. So I'll use this app, one directory, another directory. We go to the store, and then we go to actions, and then right here we should get a suggestion for auth actions. If we don't get, something is wrong. Yeah, auth actions, that's perfect. And then now we can dispatch this action creator in here where we are performing a dispatch. So I'll say dispatch sign up, I invoke it, and it expects a user. So right here I'll simply pass the user, which is this user, and once we type at our fields, this set user will correctly update the properties of our user. So when we perform a dispatch, when we click the submit button, this function will be called, sign up action creator will be dispatched, and then it will receive that user right here, and then we'll use adjust.post, and then tap the endpoint right here and pass the user to the body of the request so that our backend can save that user to the database. Once we successfully save the user, we then sign in from the backend using JWT, and what we get back is a token, and then we save this token to the local storage, and this will help to have persistency for authentication in our application. And then after that, we continue the dispatch by dispatching an action of sign up and then the token, and we can access this now at our reducers. and correctly update the state. Okay, but before we go to our reducers, I want to come back to the sign up form. Once we perform a dispatch, I want us to reset the form values by changing the state to the default state, and this will affect each value right here. Okay, so if we set the name to an empty string, the value will be empty. So right here, I'll make use of set user, and I invoke that and pass these values in here. So I'll just copy them and paste them in here. This will just reset our form. So I will save this, and Prettier will correctly format my code. I guess this is okay for this form at the moment, and all we need to do now is to update our state using the auth reducer. So in our reducers, we have root reducer and to do reducer. So we can add a new file for auth reducer. So right here, I'll say auth reducer, just like that, but .js. And then this auth reducer is supposed to be just a function. So right here, we will import toast from React toast file for our toast messages, just like that. And then we will import JWT decode. So this is something that you'll need to install. So if I come right here, I had already installed it, and let me see. Yeah, I am at my front end, and I perform this action npm I JWT decode, and this JWT decode will help us to decode our JSON web token, which we are getting from the backend. Okay, so please install this, and then we need to import JWT decode right here. So I'll say import JWT decode, and this is from that package which I am assuming you have now installed, JWT-decode, just like that. And I think I made a mess. Did I install this package correctly? Yeah, it's JWT-decode. Okay, it should be that way. Now you can import JWT decode from JWT decode. Now right here we should have a function which is our auth reducer. So I'll say const auth reducer will be equal to, it have access to the state, and the state we can set the state to have an initial value. So this one will be equal to, let's call it initial state, and we'll also have access to action, and then this will be an arrow function. So we pass it just like that, and we don't have this initial state at the moment, and I misspelled it. Initial, I think it's written that way now. So let's set this initial state, which will be an object for our default state. So right here I'll come and set a constant, call it initial state, and then I'll set to be equal to an object. So for our state, our auth state, we expect to have a token, and we'll get this token right here from our local storage. So remember right here we saved a token at the local storage, and now we can access that token from the local storage and store it in our state by default. So this will have some persistency whenever we refresh the page, or whenever we come back later and try to access our application, we'll already have a token at the local storage, and we can get that token and set it to our state. Okay, so right here I'll use the local storage object and then access the get item method. And now right here we only need to pass the key for that item. Okay, and we set a key of token. So if I come to auth actions, we set a key of token which will be equal to this token.data. So this is the token, and then we will have the name. I'll set this one to null. We'll have an email. I'll also set this one to null, and we will have an ID. So I'll say underscore ID, and this will be the user ID. Okay, I'll also set it to null. Now this is the initial state. Okay, this is the initial state for our application, and we are setting it to be the default state right here, state to be equal to the initial state, and then we have access to action. Now we can switch through the different action types and update the state accordingly right here. So right here I'll say switch action dot type, and then in here is where we can go through each case, and the case I am interested in right now is the sign up case. So sign up, and that case is the one that we dispatched right here. Yeah, I am a copy paster. I'll come here and paste that right here. So this should be the same as that action that we dispatched from Auth actions. So for the case sign up, I will use a full colon, and then we will toast a welcome message. So right here we can say toast, and we can enter a message here, welcome. And then I can position this to be at the bottom right. So position toast dot position. It should give me a suggestion, but it's not. Okay, bottom right. But we also want to include our user to the auth state. So what I can do at the bottom here, I'll now make use of JWT decode. Okay, and I'll say const user will be equal to JWT decode, and then I'll pass the token, which is action dot token. Okay, so this action dot token is the one that we passed right here, action dot token, which is equal to our token. And once we decode that token, we will get a user, and I'll show you how this is working on the JWT website so that you can correctly understand it. But the user will have these properties: name, email, ID, and whatever property we included at our backend. Okay, and now that we have that, we can update our state like this. So we can return an object. We spread the initial state, which is this one right here. We spread the initial state, comma, and then we can update each of these properties. Okay, so let's start with the token. So the token here, we will update it to the token that we are getting from the backend. So we'll say action dot token, and then we update the name, which will be user dot name. We update the email, which will be user dot email, and also we update the ID, which will be user dot underscore ID. Just like that. So if I save this, I think pretty should format the code, and this is more readable now. So let me take you through what is going on. Once we submit this action, sign up, our auth reducer will check for case sign up, and then we toast a welcome message. We decode the token action.token and get back a user with these properties, name, email, and ID, and then we can update our state from the initial state here to this particular state, where we can now have these properties in our auth state. Okay, and then after this we should also perform a default case right here. We can say default a full colon, we simply return the state, return state. Now we need to export this auth reducer right here, so I'll say export default and then auth reducer. And once we export it, we need to use it in our root reducer so that our application is aware of it. So I'll come to the root reducer and import our auth reducer. I'll just duplicate this one using Alt Shift and the bottom arrow, and then I'll import auth from auth reducer. And then right here we will add auth to the state, so I'll use a comma and then auth, and right here I'll say auth reducer. So our auth here will contain the state of our auth reducer, which is this one now, token, name, email, and ID, and we'll be able to access this state from any other component in our application, because now this one is in Redux store. Okay, so yeah, that's it. That is how we can perform sign up, and the only thing that remains is to test our application and see whether we'll get a token and add it to the state and also to the local storage. So I'll come back here and start my application using npm start, and this might take a while, so npm start. And then another thing that I want you to have on is the server. Server should be also running. So whenever you have your backend, run your server using nodemon, okay? Because we need to access the server using this API right here, index.js. You need to access the server on localhost, okay? So make sure your server is also running. So the app failed to compile, and it's because we have two errors. One is in our auth actions and the other one in our auth reducer. So to fix this error, we can go back to the code editor, and the error is because of our toast.error method here. The first parameter should be our response or our error message, and then the second parameter is our option for positioning the toast message. So I should cut the entire of this section and include it inside our error method brackets. So I'll create a space and paste everything right here. So this is what we have. This is the first parameter and this is the second parameter. I'll save that, and then the second error is in our auth reducer. So right here, instead of user, I wrote use, so I should change this one to user, and that should fix the second error. Also, I would like to log the state to the console so that we can see whether we will get the user at our state. So I'll go to the sign up form, and I'll make use of this Redux hook which we had imported earlier called use selector. So just after our dispatch, I'll say const state will be equal to use selector. I invoke this. What we get right here is the state, and we can return this state so that it is stored in our constant here. So state and then an arrow function, and we return the state. So now we can log this state to the console. Right here I'd say console.log state. So let's test our application. I'll come back to the browser and refresh this page. So now our application is running, and when I open the console right here, I can come to these arrows and then go to application here, and you'll see we have a section called storage, and we can see whatever is stored in our local storage. So at the moment we don't have anything stored at our local storage, it's empty. But because we used our local storage in our application, once we sign up, a token should be added right here. And when I look at my MongoDB database, you'll see at our users we currently don't have any user. So let's test the application. I'll enter a name, an email, and also a password, and then click sign up, and you'll see we get this message, welcome message, which we included in our reducers, and then a token is added right here. So if we copy this token and go to JSON Web Tokens website, we can be able to decode that token at the bottom here. We just replace the entire of this token with what we have, okay? And when I paste it here, you can see at our payload we have the decoded token, and so we have a user ID, a name, an email, and when the token was created. And this is what our JWT decode is doing at our auth reducer. So this JWT decode, we call it and pass the auth token right here, and we get back a user. So this user will have an ID, a name, and also an email. So this is what was happening with our JWT decode, and we can be able to add the user now to our application state. So we had logged the state to the console. So if I come to the console right here, you can see we have some log messages. All these log messages were happening when we enter a value in our form, because each time we enter a value, the application state changes. But when we expand this and then expand auth, so we have two parameters in our state, auth and to-dos. So if I expand auth, you'll see that we have an email, we have a name, and also we have an ID and a token. So we are successfully signing up a user, and we are also signing them in by receiving a token. And when we go to our MongoDB database and refresh this section, we should see that a user was added in our database. So let's see, and there we go. This is the same user that we just added using our sign up form, and you can also see that our password is being hashed, and this is happening from our backend. Okay, so we would like when a user successfully signs up and gets signed in the application, we redirect them to our to-dos right here. So to do that, I'll go back to the sign up form and I'll import something from React Router DOM, which is our redirect component. Right here, I'll import redirect from React Router DOM. And then we can make use of it just before our return statement, and we will perform a check if auth._id exists. Then we want to redirect the user to the home page. So right here we'll say return the redirect component, and we include the to plop, which will be equal to a path, which is our home page. So if a user is logged in or signed up, we will have an ID at our state, and if we have an ID, it means that the user is logged in, and therefore we will redirect the user to the home page instead of showing them the sign up form. So right now we haven't defined auth, and we should get auth from the state. So instead of returning the entire state here, we can say state.auth and store that in a constant. So auth, and then I can get rid of console.log. So right now when we sign up a user and we are automatically logged in, we should be redirected to the home page. Okay, and we can test the application. So the application has loaded, but when I try to go to sign up, I'm getting an error, failed plop, where the plop2 is marked as required in redirect, but the value was undefined. And the issue is right here. I don't know how this was added, but this should not be here. So make sure this is empty, and also at the bottom we don't have that redirect. The redirect should only be here, and we pass the plop2 and the path. So now when I refresh this one, we can go to sign up and test whether we will be redirected to our home page. So I'll sign up for a new account. I'll enter a dummy email, and then create a password and sign up. So welcome, and we are redirected to our home page. Okay, when we try to visit sign up right now, you'll notice that we can't go to sign up because we already have a user in our state, and also we have a token at our local storage. But when I refresh the page, the auth state will be lost, and we can be able to visit the sign up page. So we added the token at the local storage so that we can add some persistency in our application in terms of authentication, so that even if we refresh, as long as we have a token at our local storage, we'll still be logged in if we have that token right here. Okay, so to add that persistency, we'll need to make use of this token by loading the user, and that is what we are going to cover in the next section. So right now we have successfully signed up a user, and we are also automatically logging them in. In this section, I want us to load a user from the local storage and include them in the application state. So if I come to the auth reducer, you'll see that we are already loading a token from the local storage, and this token we had added earlier using our sign up. So right here we set a token, and then we can load that token from our local storage. So once we sign up, this token will be persistent even if we refresh the page. So this token remains at the local storage, and we can make use of it in this particular video, where we'll take it from the application state and then dispatch an action of load user, and then we can decode that action in our auth reducer using JWT decode, and include the user, that is the name, the email, and the ID in the application state. So I'll come back to the auth actions, and I'll create a new action creator called load user. So I'll say export const load user, and this will be an arrow function. Right here, with the help of Redux Dunk, we can return a function, So I return a function, and we will have access to dispatch for dispatching our actions, and also we will have access to get state, and we can get the application state from the Redux store. Now right here I'll get the token, so I'll say const token will be equal to get state. I invoke it, and then we access the auth state, and the property that we want from our auth state is our token. So now this token is coming from our state, and it was added to our state through our local storage.get item. So we added here the token to our state, and we can get it from our state just like this. Okay, now we can make use of this token by dispatching it so that we can use it in our auth reducer. So right here I'll perform a check if token exists. If token is not null, then we will perform a dispatch, and I misspelled this one. I invoke this, pass an object, and then the action will be type of user loaded, user underscore loaded, and then the payload will be our token. So this is an if statement. We need to also include an else. Else will simply return null. Now we have an action creator for loading our user, and we are getting this token from the state, and it was added to our state using this particular method right here. So local storage.get item token, and we add it to the state, and now we can perform a case of user loaded. So I'll simply copy this user loaded, and then the case will be similar to our sign up here. So all I can do is say case user loaded, and then I include a full colon. So if this action is dispatched, our auth reducer will perform a check, and it will see that we have user loaded, and therefore it will perform this action. First of all, it will toast a welcome message, and then it will decode the user from action.token. So remember, we are passing that token right here. So it's action.token, and then once it decodes that token, it will get those user properties. So we will have a name from user.name, email from user.email, and an underscore ID from user._ID. And when we perform a check whether an auth._ID exists in our application, will notice that the user have been loaded, and they will log the user in. So all remains is to dispatch this action creator from our front end. So how we are going to do that is in our app.js file. Now in our app.js, we'll make use of the use effect hook. So we can get it from React right here. And then we'll also need to make use of use dispatch. So we can import it from React Redux. And the last thing that we will need in order to dispatch that action creator is the actual action creator. So I can import the action creator just right here. I'll say import load user, and this will be from our auth actions. So I'll go inside the store because they are at the same level, and then actions, and then we go to the auth actions, just like that. And now we can come to our app. I'll create a constant called dispatch, and we will load our use dispatch hook. I invoke that, and then just below here we can make use of our use effect hook. Now this use effect hook will be loaded after our application renders, okay? And once it renders, we dispatch our load user action creator, and then our load user action creator will get the token from the state and will dispatch an action of user loaded, and then our auth reducer will perform this check. It will see user loaded, and it will decode the token and add these properties to our application state. So let's make use of use effect in our app.js. So I'll say use effect. I invoke it and pass a function in here. So this is an arrow function, and then in here is where we can perform a dispatch. I invoke it and we dispatch our load user action creator. We also need to pass our dependency array here. So I'll use a comma, and then I'll pass dispatch in here. So every time we have a dispatch, this use effect will be called, okay? So yeah, that's it, and now we can test our application. So I'll come right here and start my front end, and also make sure that your backend is also running, okay? So backend node and it's running on port 5000. Now our application has loaded, and you can see we already have a token at our local storage. So if I try to go to sign up, I can't, because we are already logged in our auth state. We have an auth ID, and if I try to refresh this, you'll see now that we have some persistency with authentication. As long as there is a token in our local storage, we are automatically signed in, okay? So now the only way of logging out the user is by deleting this token from the local storage, and that is what we will do later with our sign out button. We'll be simply deleting this token. So if I create this token and try to refresh this page, now you'll see that we can visit our sign up component. Not unless now we sign up the user again and they are automatically logged in and we have a token in our local storage. So now we are successfully loading a user, and in the next section we'll see how we can sign in a user using this sign in form. In this section, I want us to sign in a user using our sign in form, and our sign in action creator will be so similar to our sign up action creator. So all I'll do is that I'll copy this action creator and duplicate it at the bottom using Alt Shift and the bottom arrow. So now right here I can create some spacing and customize this action creator to fit our sign in action. So first things first is to rename this action creator to sign in, and then right here we'll be getting creds or credentials, that is email and password. I'll simply call it creds, and then we can return dispatch, use Axios to perform a post request, and the endpoint in this case is sign in, not sign up. And then we pass creds to the body of the request, and this now can be received by the Backend API, and the user will be signed into the system. What we get back is an auth token, which is a JWT token, and we simply set this token to our local storage or save it to our local storage. The key is token, the token data is token.data, or the token itself is token.data. And then we perform a dispatch of an action. Type will be sign in, and we also pass a token which will be in token.data, and we can access this from our reducers and update the state accordingly. And then right here we catch any error, we log an error to the console, and also toast the error as a message. Now this is all we need to do for the sign in. It's just so similar to our sign up. All we need to do is to change the path, the name, and what we dispatch right here. Now we can go to our auth reducer and perform a check of this action, which is sign in. Now in our auth reducer, all we need to do is to add this case right here. I'll simply say case sign in and a full colon. If I save that, this should be automatically formatted, and if it's not, I can manually format it. So this case sign in will also be similar to our sign up. This is what will happen. We'll toast a welcome message, and then we'll decode the user from the action.token, and then we'll add the user to the state. So you can see sign up, sign in, and user loaded all are doing the same thing here. All the functionality or the logic is the same. Now all we need to do is to dispatch our sign in action creator from our front end. So we will go to the auth folder and go to the sign in component. So from here I'll import everything we need to make use of our sign in action creator, or to dispatch our sign in action creator. So first of all, in this component we may need to use the state. So I'll say use state. I import use state from React, and then we'll make use of use dispatch and use selector. So I will import use dispatch and also use selector, and all this will be coming from React Redux. So use dispatch will help us to dispatch the sign in action creator, and then use selector will help us to select a certain piece of state from our Redux store, and then the use state will help us to get our form values, and we can then dispatch them. Now the other thing that we will need is the actual action creator, so we can also import it here. Which is sign in, and this will be coming from our auth actions. One level up, another level up, I access the store, I access actions and then auth actions. So we have imported everything we need, and we just need to make use of them. So inside our sign-in component, before our return statement, we can include the default state right here. So I'll say const, we will have creds and set creds. So set creds will simply update our creds state, and then this will be equal to use state. I invoke it and pass some default state. For our sign-in, we expect a user to have an email, so we can default it to an empty string, and we also expect the user to have a password, so I default it to an empty string. Now we can update our creds.email and creds.password from our form when we type something in our form. So right here, first of all, we will have a value prop, which will be equal to creds.email. And then to update this value, we will have an onChange event. So this will be equal to, right here we pass an arrow function which will accept event, and then we can make use of set creds to update the creds. So I'll say set creds, I invoke it, and then in here I'll spread the creds using the spread operator, and then all we need to update is the email, which will now be equal to e.target dot value. Okay, I think this is correct. So we need to do the same for our password. I'll just copy this and paste it right here. So this will be creds.password, and then for our set creds, we'll accept an event, spread the creds, but this time we'll only update the password. So now we are correctly updating the values for email and password, and when we submit the form, we will fire an onSubmit event. So right here I'll say onSubmit, which will be equal to a helper method. I'll call it _submit, and now we can create this helper method. I think I messed up something. Oh yeah, it's okay. If I save that, I think it should be automatically formatted. So we have an onSubmit, _submit, and we can create this _submit just before our return statement. So right here I'll say const _submit, which will be equal to an arrow function. It will accept an event, and we can prevent the default action for submitting a form. So e.prevent default, this will prevent the page from refreshing whenever we submit the form, just like that, and I invoke it e.prevent default. And then right here is where we can dispatch our action creator when we are submitting the form, and we need to load the use dispatch hook. So I'll say const dispatch will be equal to use dispatch, and I make sure that I invoke that. So right here I can simply say dispatch, I invoke it, I call sign in, and I invoke it and pass the CRUDs. So this CRUDs is this one, which will have our values from the state. And then after that, I simply want to clear the form values, because our form values depends on the value of the state. So if we clear the state, we simply clear the form values. So right here I'll say set CRUDs. I invoke it and pass the email to be an empty array. I also pass password to be an empty array. Okay, now at this point we should successfully log in the user, but I also want to redirect the user to the home page in case an auth ID exists, like we did with our sign up form. So what I'll do is that I'll load the auth state right here. So I'll say const auth will be equal to use selector. We had imported use selector area from React Redux. I invoke use selector. So what we get here is the state, and we will directly return state.auth. Now we have the auth, and all we need is to perform a check. So right here I'll say if auth dot underscore id exist, all we need to do is to return the redirect component. So right here I'll say redirect, and then we have a tool which is a prop, and we pass this path, which is the home page where we have the list of our to-dos. And then now we can cross our redirect component, and yeah, this way. Also make sure that it was not added here. I saw that that behavior. Okay, you can see it was added here, but we don't want it here. I saw this behavior when working with our sign up, so make sure it's not there. And we need to import this redirect component from React Router DOM. So at the very top, let's import redirect, and this will be coming from React Router DOM, just like that. So right now we should be able to log in and redirect the user to the home page. And I think we can also log auth to the console. Maybe what we can do, so that we also see the application state, is to come to our app.js component and log the state to the console from here, or rather from our navbar, because the navbar is in every component, like it's a shared component. That's what I meant. I think from here we can import use selector, so that we also see our application state use selector. Okay, and this will be from React Redux. React Redux. Now we can make use of use selector right here, or I'll do is that I'll say const state will be equal to use selector, and I invoke this. What we get is the state, and we directly return this state. Oops, this is so bad now. State, we directly return the state, and we can log this state to the console. Console.log state. So at this point now we should also be able to see our application state in any component, because our navbar is kind of shared. Now I run the application and we can test whether everything works. So at the moment we don't have any token at our local storage. So let's go to sign in and try to sign in the user. So I'll say Chaoo2 at gmail.com. I'm not sure whether I remember the password, but let's try. I'll click sign in, and there we go. We are successfully being redirected to the to-do home page, and then we have a welcome message and a token was added at our local storage. So if we go to console, right here we log the state to the console, so we can see we have the state, and when we check our auth state, we have the email, we have the name, token, and an ID. If I try to go to sign up, I can't because I am logged in. If I try to go to sign in, I can't because I am logged in. So we are successfully signing up a user, signing in a user, and also loading a user from the application state. So loading a user is important because now when I refresh the page, because we already have a token at our local storage, will still be signed in. Okay, so yeah, that's perfect. Now in the next section we'll see how we can sign out a user. In this section I want us to handle sign out, and if I come to the NavBar component where we have our sign out button, I can see that we had started to implement the sign out functionality. So just right here where we have our sign out button, we had added an onClick event where if you click that button, this handle sign out method is called, and then in the sign out method, this is where we will dispatch an action creator for signing out a user, and then right here we push the user to the sign in route. So to complete this functionality, we can import use dispatch and also an action creator from our auth actions. So we haven't created the action creator yet, but since we know where it will be, we can still import it. And right here I'll say use dispatch, and then right here we can make an import of our action creator. And note that we haven't created this action creator yet, but we will call it sign out, and it will be coming from our auth actions. So I go to the store, I access the actions, and then I access the auth actions, just like that. And then we can initialize use dispatch right here. So I'll say const dispatch will be equal to use dispatch. I invoke that, and then right here is where we will dispatch our action creator. So dispatch, I invoke it, and then sign out. I also invoke this, and this time round we are not passing any parameter to our sign out action creator. So let's go ahead and create this sign out action creator. So I'll go to the auth actions, and then we can create it at the bottom here. So I'll create the sign out action creator, export const sign out. This will be an arrow function, and then we return a function with the help of Redux Dunk, and this function will have access to dispatch so that we can dispatch our actions. And then in here we can dispatch an action of type sign out. So this is all we need to do in this particular action creator. All you are dispatching is an action of type sign out, and this is it. This is all we need to do for our sign out action creator. It's an arrow function which have access to dispatch, and then we dispatch an action of type sign out. Now we can go to our reducer where the magic of signing out a user will happen. So after our case here, now we will include a new case because this is now a different implementation. I'll say case sign out, so this is supposed to be underscore sign out and then a full colon, and below here to sign out a user, the first thing that we need to do is to remove the token from the local storage. So right here I'll simply say local storage dot remove item, and then I pass in the key for our item, which is token. So this will remove that token from the local storage, and then we can toast a message. So all I'll do is that I'll copy this one and paste it here, but we can change the message to goodbye because now you are logging out. We position it at the bottom right, and then after this we need to clear our state. Okay, so in our state we need to set everything to null, even the token itself. So all I'll do is that I'll say return an object which will have these properties. So it will have a token, name, email, ID. I'll copy that to make my work easier, paste it here, and the token will also be null now that we have removed it from the local storage. So I'll save that and it will be properly formatted. So yeah, this is it. This is where now we are signing out a user. When we click the button from our navbar, we will dispatch this action creator sign out, and then this sign out will dispatch an action of type sign out, and then this action we can check it here where we remove the token from the local storage, we toast a message, and we clear the state. So this way the user should be successfully signed out. Now I want to note out that since we are not performing a massive functionality here, we can directly dispatch an action just in our navbar. But just to follow our trend where we create action creators right here, and then we use Auth reducer to update the state, we can do it this way for consistency. Now let's test the application and see whether our sign out functionality works. So now currently we are logged in. If I expand the state here, you'll see we have a token at our state, an email, name, and ID. And when I check the application here, we also have a token at our local storage. Now let's see if our sign out functionality works. So I'll click sign out, and you'll see that this token have been removed from local storage. And when I come to the state, so I'll come to the console, which is here. I expand this. Now you'll see at our auth we are clearing the state, then the ID, token, name, email, and we are redirected to the sign in component. So now we can sign up, we can sign in, and when we come to our to-do app right here, we can also be able to access our to-dos at the moment. but we'll perform conditional rendering later on, and also redirecting the users if they are not signed in. But in the next section, I want us to protect our API endpoints, since now we have authentication such that only the logged in users can be able to delete a to-do, add a new to-do, and perform all those actions. So right here, right now I can add a new to-do even if I am not logged in, okay? And that to-do is appearing here. I can mark a to-do as done. I can edit a to-do, and I want this functionality to only remain to authenticated users. So in the next section, we'll protect our API endpoint so that only authenticated users can perform these actions. And then we'll perform conditional rendering, where we can hide some buttons here, show the correct name of the logged in user, and also make sure that we can't access our to-dos if we are not logged in, okay? In this section, we are going to protect our API endpoints, and we had created this middleware function at our backend, which will help us to check whether our user requests have a valid token, and if the token is valid, then we'll go ahead and allow the user to access our to-dos API endpoint. So how this function works is that it expects our request to have a header, and at our header we are expected to have a key called XAuth token, which will contain our JWT token. And then if the token does not exist, we return not authorized to the user. And if the token exists, then we will verify the token using JWT verify, where we pass the token here and also the secret key from our environment variable as the second parameter. And what we get back is the decoded or the payload of that token, and it will contain properties of our user, that is the username, the ID, and also the email. So we add the user to our request, so that now we can access this user from our to-dos APIs, and we can perform further authorization. So to start with, we are going to create a function which will allow us to set this XAuth token together with a valid token of the logged in user. So I'll go back to my frontend folder here, and then inside the API folder we will access this index.js file. Right here we were exporting a URL which targets our API endpoints, and we'll also export a function which will help us to set the headers of our request. So right here I'll say export const set headers, and this will be an arrow function. And then right here I'll say const header will be equal to an object, and inside this object now we can set the headers with the small cap. So this is a property inside this object called headers. I use a full colon, and then we can set a key and a value. The key will be this one, XAuth token. I'll just copy that and then paste it here. I use a full colon, and then the key, it will be our auth token, and we'll get this auth token from the local storage. So I'll say local storage dot get item, and inside here we can pass the key of the item we are getting, which is token. So now when we call this function, we should return this header, which will contain our XAuth token, and the XORG token will contain a token from our local storage. So right here we need to have a return statement, and I'll simply say header. Now we can access these set headers from our to-do actions, where we are performing requests and set the necessary headers. So right here we will import URL from the API, and also we will import set headers. And when performing each request to our to-dos API, we'll need to pass this set headers function, and it will set our headers to contain our XORG token. So to start with, we can start with the get to-dos action creator. This is where we are accessing the API endpoint as the first parameter, and then the second parameter we will call set headers. I invoke that, and now this will set our headers to be exactly this one, an object which have a property called headers, and then inside that property we have another property which is a key which contains our token. So just to mention, you can pass this object directly to our get method here as the second parameter, but for simplicity we are using a function so that we can call this function from each of our requests to avoid this repetition. Okay, so we'll go ahead and set headers for our add to do. So right here I can include a comma, and we set the headers as the third parameter. I invoke this one. So for adding a new to do, we are expected to have a URL and then the body of the request, and then this is the third parameter where we are supposed to set our headers. For our get, we only have two parameters, the URL, and then the second parameter is our headers. We don't have a body of the request right here. Now for adding a new to do, we can continue and add an author when adding a new to do, so that this is now complete, such that when we add a new to do, we also get to know the author of that to do and also the UID of the person who created that to do. So what I'll do is that I'll use an object here, and then I'll spread the properties of new to do, and the second parameter here will be author, and the other one will be UID. And we can get this directly from our state. So we have access to get state, and before we perform axios.post, we can get our author and also the UID. So right here I'll say const author will be equal to get state. I invoke this. We say .auth .name. So remember in our state we have the auth state and also the to-dos state. Now we are getting the name of the author, and then we can also get the UID of the author. So I'll set the UID to be equal to get state. I invoke this, and then we say .auth ._ID, and this is now the user ID, and we attach the author and the UID to our to do, so that now it will have the to do's properties and also the person who created that to do. And we are also setting the headers so that we send the token at our backend. Now let's go ahead to our update to do. So right here we will have the URL, and then we will have the body of the request, and now we can have the headers of the request by simply saying set headers. I invoke that. and then we can go to our delete or rather check to dos. So this is supposed to have the first parameter is the URL, and then the second parameter is supposed to be the body of the request. But since we are not sending anything to the body, so this is just an empty object as a placeholder. And then the third parameter is set headers, and we invoke it to set our headers. And lastly, we have delete, which will have the first parameter as the URL and the second parameter as the headers of the request. So we'll just invoke our set headers function. Now for each of our to-dos requests, we are sending headers to the backend, and when we receive these headers, which is this one, it will have this key XAuth token, and we will perform a check whether this XAuth token exists. If it's null, we will send back not authorized. Else, we will perform some verification here and add a user to our request. Okay, so in our request we will have user, and we can access this user from our to-dos APIs. So I'll go to the to-dos API right here, and we need to uncomment this one. So how we are going to protect our routes is passing this middleware function. So we are getting, this is the middleware function, this one, where we are checking whether we have a valid token. So we'll send this one as the second parameter. After our path, we include auth and then a comma, and then the next in our middleware function, this one here, will pass functionality to our async function here, which will get our to-dos from the backend. So when we pass this auth, the user must be authenticated in order to get the to-dos. So if the user is not authenticated, we will either get not authorized or invalid token from our middleware function. Okay, so from our to-dos API, we should pass this auth as the second parameter for each of these requests. But for further authorization, we can make it in such a way that a user only get the to-dos that he or she added. So we can perform a filter, since in our auth here, it gave us access to the user via our request. So what we can do is to filter our to-dos just like this. So I'll say const filtered to-dos will be equal to, we take this to-dos array, which is the entire array. So I'll say to-dos dot filter. I invoke this, and in here we will get each to do at a time, and we will perform a check. So we will say if to do dot uid is equal to request dot user dot underscore id, then we will return that to do. If to do dot uid is equal to request dot user dot underscore id, we will return that to do, and it will be added in our filtered to dos array. So remember, this to do dot uid is coming because we added a uid in our to do actions, just right here. This is why we added the uid. And then for request.user.underscore id is coming from our middleware function, where we verified the user and added the user to our request. Okay, so now we can do request.user and then access a property of the user, which is ._id. So this is what is happening there. And then right here, instead of sending all the to-dos to the user, we can send only the filtered to-dos. So right here, I'll say filtered to-dos. So now a user can only get to-dos that he or she added and not other users to-dos. Okay, now this is for get. Let's go ahead to our post. So right here we need to pass auth as the second parameter, and this is our middleware function which checks whether our headers have a valid auth token. And right here we are adding the author, the UID at our new to-do. So we were getting it from request.body, and this is all we need to do for adding a new to-do. We only need to pass auth. We don't need to do anything else. So we can go to the next one, which is editing a to-do. So we need to pass auth right here, and then after we perform this check whether a to-do exists or not, we can also perform a check whether this is a valid user or not a valid user who is making the request. So we want users to only edit to-dos that they added in the database and not other people's to-dos. So what I'll say is that if to-do .uid, so right here we have checked the to-do is exists. If it exists, then we can say to-do.uid. If to-do.uid is not equal to, we have a user in our request, is not equal to request.user ._id, then what we will do is that we will return, we will say res.status, and the status code for this one will be 41. So right here I'll say 41, which means not authorized, and then we can send this message .send. I invoke it and I'll say to do update failed, and at the end here maybe I can minimize this one. I can also tell them it's because they are not authorized to edit that to do, so not authorized, and maybe I can include 3 dots. I'll save this to properly format this code, that way. So this is for our edit. We fetch the to do right here. If the to do exists, we'll proceed to this line. We do a to do, I missed the spelling here, to do .uid. If it's not equal to request.user ._id, now this is the person making the request or the currently logged in user, then we'll tell the user that oops, to do update failed, not authorized, and the code is 41. And then now we can do the same for our delete. Actually, I think I'll just copy this, and then for this was for put request. Okay, we also have a patch request. I'll include auth, which is our middleware function for checking the headers. Then we check if the to-do exists. If the to-do exists, then we'll perform this check, the same as the above. So only the message will change, maybe to do check stroke uncheck failed, not authorized, and then we can go to our delete. I pass auth here. We check if the to-do exists. If it exists, then we also perform this check, and we'll change the message to do deletion failed. Not authorized. So now we are correctly protecting these routes. First of all, if you're not authenticated, you won't be able to delete a to-do. Then if you're not authorized to delete that to-do, you won't be able to actually delete it. And we are doing this for these other API endpoints for our to-do. And now the only thing that remains is to test whether our application works. Okay, just to take you through the thought process of what we have done. First of all, we started by creating a set headers function, which includes a key in our headers called Auth token, and we set the token to be from our local storage. And then with every request, we are setting the headers for each of these requests. So when we make a request, what will happen is that for example, if we are getting a to-do, we will get to this path, and then this is the function that will be executed first. So we'll go to auth.js, check whether our request have a header, and inside the header we have xauth token. If the token does not exist, we'll tell the user, oops, you are not authorized. Else we will verify the token and include a user to our request. Else we'll say invalid token. So if this succeeds, we pass functionality to the next middleware function, which is our function here, right here. So when we get to this point now in our request, we will have a user, and we can do something like request.user._id, and we can do a filter for these to-dos, where we get to-dos which we ourselves added and not other people's to-dos. And then for post, we only need to check whether the user is authenticated to post a new to-do, but we'll also add an author and a UID to that to-do. And then for put, we check whether the user is authenticated, and then we also check whether they are the one who created that particular to-do, so that they can actually edit it. The same happens for patch, and the same happens for delete. Now there is one last thing that we need to do. We need to go to our to-dos folder here, and then add to-do component. And when we update a to-do, we need to include all the properties that are required. We need to include a valid author, the currently logged in user, and also a UID. So I replace this line with these two lines, okay, where we have the author as to-do.author and UID as to-do.UID, and this will properly update a to-do. Now we can go ahead and test if everything works. So I'll go back to the browser here, and at the moment you'll see that we can't get our to-dos because we are not logged in. If I try to refresh this one, you'll see that we are still getting an error, and if I expand this, you'll see that at our auth everything is null. And when I check the application here, we don't have a token. Okay, so if we try to add a new to-do when we don't have a token and submit, you'll see that we are getting an invalid token and we can't actually add a to-do. So we are correctly protecting our API endpoints, and to confirm this, we can sign in as a user, enter a valid password, sign in, and once we are signed in, we can now add a new to-do, and you can see it was added here. We can try to add another one, and we can mark the to-do as done. We can edit it, and also we can be able to delete a to-do. As long as we are logged in, we can be able to perform all these actions. Okay, so if I sign out, we will be redirected to the sign in component. If I go to the to-do right here, for some reason we still have this in our state, but when we try to mark it as done, you can see invalid token. If we try to edit it, we can't be able to edit it. If I try to delete, also we can't delete. And if I refresh this page, you'll see that we can't get that to do from the backend. So right now we are correctly protecting our API endpoints, and in the next video I want us to perform some conditional rendering, such that if you are not logged in, you cannot access our home page. So you won't be able to see a sign-in form, you won't be able to see the to-dos, and also you won't be able to see some of these buttons. So if you are not logged in, you'll only see sign in and sign up, you won't see sign out. Else, if you are logged in, you will see sign out and you will not see sign in and sign up. And also we'll update the name right here. In this section, I want us to perform some conditional rendering, and we'll go to the todos.jsx component, and this was the parent component for our add to do component and for our list to do's component. So we don't want to see these components if we are not logged in. Okay, so we must be logged in for us to see our to-dos. So I'll import use selector from React Redux, and also the redirect component from our React router DOM. So right here I'll say import redirect, and this is from React router DOM. And then I'll import use dispatch, not use dispatch, use selector, from React Redux, and then we can use redirect and use selector to redirect a user. So first thing we will do is to load our auth from state. So right here I'll say const auth will be equal to use selector. I invoke this. What we get is the state, and we can return the auth state by saying state dot auth. And now before our return statement, we can perform a check if we don't have an auth dot underscore id. We should redirect the user to the sign-in page. Okay, so right here I'll say return the redirect component. We use the to plop, and we set it to be equal to stroke sign-in, and then right here I cross our redirect, and this should not be here. So just like that, we are getting auth from the state. If there is no an ID in our auth, that means that the user has not logged in, and therefore we redirect them to the sign-in page. Else our components here will be returned. So now let's go to the NavBar component, and we want to hide some things depending on whether a user is logged in or not. So right here I will load a user from the state. I'll just duplicate this one, and then instead of returning the state here, I return state.auth, and I can get auth right here, or the user, and then I can use this auth to perform some conditional rendering depending on whether a user is logged in or not. So we want to display this message logged in as that user, and also we want to display sign out if the user is logged in. So we can display the correct name here by using the curly brackets and then using auth dot name. So this is the name of the currently logged in user, and then I can use these curly brackets and perform a check. If auth dot underscore id exists, that means that the user is logged in, and therefore we should display these two, this message and the sign out button. So I'll use a question mark and these brackets and include these two components in here. Else we should display the sign in and the sign up buttons. So right here I should use a full colon and then add brackets and display these two buttons. So I'll cut that and include it here. So this should be wrapped in a single element. So I'll make use of React fragments, which is an opening and a closing tag, and move them in those two elements. And the same should happen for these ones. So where we are performing a check brackets, we should have these two. So these are just React fragments, and then we move the typography and the sign out button in our React fragment. So I'll save this to correctly format it, and this is what is happening. If we have an ID, it means that we are logged in, and therefore we'll display this message and then the sign out button. Else we'll display the sign in and the sign up button. Now we can test our application. So now our application has loaded, and you can see we are not seeing the sign out button and the message that we were seeing here. So we can try and log in. We enter a password, I sign in, and once we are logged in, you can see we are displaying the name and also the sign out button, but we can see the sign in and the sign up button. So if I try to sign out and try to access our to-dos here, we can't because we are already logged out. So at this point, I think we have achieved our goal of creating a to-do app with authentication and performing all the CRUD operations in our application. And in the next video, we'll see how we can deploy our application so that you can access it online. Hey, what's up guys? So in this video, we are going to deploy our Node.js application to Heroku. So Heroku is a cloud platform which supports several languages, and these are the languages which are supported by Heroku. So if you have an application written in any of these languages, you can deploy your application to Heroku. We are most interested in Node.js. So the first step is to visit heroku.com, and then you can create an account if you don't have one by clicking sign up here. If you have an account, you can just log in, and this is what I am going to do. I am going to log into my account using an email and a password. Once you log in, the first step is to create a new application. So I'll use this button right here and then click on create new app. Give your app a name, node-to-do-app, and you'll see that this name is already taken and not available. So what I like to do is to prefix the name using my own name. So I'll say Chaoo -node to do app, and this is now available. Choose a region, I'll go with the default, and then create app. Once the app is created, you'll be redirected to instructions on how you can deploy your app, and we have several deployment methods. We have Heroku Git, GitHub, and then container registry. In this video, we are going to stick to Heroku Git, and to use Heroku Git, we need to make use of Heroku CRI. So the next step is to install Heroku CRI. I have already installed Heroku CLI, but for you, you need to click on this link. Let me open it on a new tab, and you land a page just like this one. Once you scroll at the bottom here, you'll see instructions on how to install on different OS. So make sure you install Heroku CLI, and then the other step is to follow these instructions, and these are a few instructions, so it will take us a few minutes to deploy our app. So I'll go to my application here where I have my MERN application, and then open the backend. So the backend is what we want to deploy on Heroku, and I'll open this path on command prompt. I'll type cmd right here, hit enter, and this will open my command prompt on that particular path or directory. So I can zoom in a little bit so that you clearly see what I am doing. So right here, the first thing that we can do is to check whether Heroku CRI is installed in our machines by using this command, Heroku -v. So right here we get the version of Heroku CRI that we are using. If you don't get a version and get an error, you'll know that Heroku CLI is not installed in your machine and you need to install it. The next step I'll do is to initialize a Git repository using this command, git init. So this will initialize an empty Git repository, and then I can open my backend code on Visual Studio Code using this command, code space and a period. This should open my code on Visual Studio Code. And here is our Node application. So index.js is the root of our application. And the first thing that I want us to do is to ignore these Node modules. So we don't want to push Node modules to Heroku because Heroku will automatically install the necessary dependencies using our package .json. So what I'll do, I'll come at the root of the app and create a new file, and this file is called git.gitignore, and then hit enter. So once this file is created, we can use it to ignore the files or directories that we don't want to deploy to Heroku, and in this case we want to ignore our Node modules. So right here I'll use a slash and then include node_modules. Now the next step is to add the necessary files to the staging area. So I'll come back to the command prompt here. If I say git status, you'll see that all these files are untracked and we need to add them to the staging area. And right here you should not see Node modules. If you see Node modules, something is wrong. Go and ignore it properly. So right here I'll add these files to the staging area. So I'll say git add and then a star, meaning all of these files, and then hit enter. And then right here, if I say git status, you will see that all of these files were added to the staging area, And now we can commit these changes using git commit and then -m, and I enter a message. Maybe I can say node app and then hit enter. Now the only thing that remains is to push these files to Heroku. So the next step that I'll take here is to log into Heroku. So I'll say Heroku login, hit enter, and you'll see press any key to open up the browser to log in or Q to exit. So I'll press any key to log in, and this should open the browser. So I have my browser opened here, and you only need to click login here, and now you can see you can close this page and return to Heroku CLI. It should now be logged in. So if I come back here, you can see now I am logged in as Chaoo Charles, and the next thing that we need to do is to add our remote repository to our local repository here. So I'll go back to where we had instructions for deploying. We have done the login, we created a new repository. Now we need to do this, okay, to add this remote repo to our local repository. So I'll copy this command, Heroku git /remote -a and then the name of the application, and then come back to my command prompt and paste it here, hit enter. And now this have created a connection between our local repository and the remote repository. So if I come right here, you'll see that we did this, okay? We added the files, we committed the files, and only this last step remains. But before we push the files, I have remembered something that we have not done, and that is specifying a command to start our application while it's deployed to Heroku. So if I come to my app here, you can come to package.json file, and we need to write a script here. So I can expand this. So one way is to write a script here, a start script. So you can say start, and then you specify the command here. The command will be node, and then the root of our application is index.js, and I should include a comma and spell this one correctly. So we need to include this command at the scripts so that Heroku knows which file and which command to run, so that our application can run correctly. So this is one way of doing this. The other way is to create what we call a block file, and that is what I'll stick to. So I'll just remove this one. I just wanted to show you an alternative. So if I come right here, so this is the documentation of the block file. If I scroll at the bottom, you'll see that a block file is simply a text file called block file without the file extension. So it's not written as blockfile.txt, rather it's written only as block file. So a block file have this format where we have the process type and then the command, and the process type can be web, worker, and then agent worker, clock, and so on. So the process type in our case will be web. So let's create this block file, and then I'll show you the command that we need to include there. So right here, I'll add a new file. Okay, I need to remove this because we are not using it. So at the root, I'll create a new file, call it block file, starting with a capital letter and then block file. We don't have any extension, so this is the block file. And then right here, the process type is web, and then full colon, and then the command that we learn is node index package.js, and you can see this is the exact command that we had included in package.json. Now we need to add this file to the staging area and commit it so that it can also be deployed to Heroku. So right here I'll say git add all files, and then if I say git status, you can see this new file is the only one that was added to the staging area. I'll say git commit, and then -m, and what I'll say here is added a block file. Hit enter, and now the only thing that remains is to push our application to Heroku. So if I come here, you'll see that we have this command git push Heroku master. So I'll copy that command and then I'll include it here. Hit enter. So you can see now it's deploying, it's installing Node modules. Proc file have been identified and it's web. And now our application have been deployed. So if I come back to our account here, I scroll at the top and then go to overview. You'll see just now we have deployed the app and build succeeded. So you can open the app right here, open app, and you'll see this welcome message, welcome to our to-dos API. And this message is the one that we included in our index.js file just right here at the root. So if we try to access our to-dos, we should get an error of not authorized because we are protecting our to-dos API. So if I come here and then add that extension right here for our to-dos, hit enter, you'll see not authorized. So our application have been successfully been deployed, and you can customize the domain name at our settings. If you don't want to use this herokuapp.com domain name, you can come to settings. When you scroll at the bottom here, you can set SSL certificates, and then we have somewhere where you can add a domain name. So now we have successfully deployed our Node.js app on Heroku, and in the next video I'll show you how to deploy a React app for free on Netlify. Thank you for watching, and also remember to subscribe to my channel. Hey, what's up guys? So in this video we are going to deploy our React app on Netlify, and we are going to make use of Netlify and also GitHub. So what we will do is that we will push our code to GitHub, and then we'll connect Netlify to GitHub, and Netlify will build the app from GitHub, and the app will be deployed. So the first thing that we need to do is to create a new GitHub repository. So if you don't have a GitHub account, you can go to github.com and create a new account, and then you can go to repositories, and in repositories you should see a new button to create a new repository. So I'll click on new, and then right here you can enter the name of the repository. I'll call it React app, and then maybe I can also include React-to-do app, and then you can either make it public or private. And then with create React app, these files, the readme file and the .gitignore files, are automatically added, so I won't need to add them again. So I'll simply create the repository. Now right here we have instructions on how we can connect our local repository and the GitHub repository and push the local code to our GitHub repository. But before we do all this, I want us to make some changes to our React code, and then we'll come back here and follow these instructions. Okay, so I'll go to where I have my MERN Stack application, and we are interested in Frontend. So in the last video we deployed the backend Node.js app to Heroku, so you can check that one out if you haven't seen it already. And now I want to go to the front end. I open this with command prompt by typing cmd at the path here, and this will open that directory to command prompt. So cmd, hit enter. So this have opened that path on command prompt, and I can zoom so that you clearly see what I'm doing. I think that is big enough. Maybe resize the window and reposition it here. So I'll open my front-end code on Visual Studio Code. So code space and a period, hit enter, and that should open that code on Visual Studio Code. So the code have been opened on Visual Studio Code, and the file that I am interested in is in API and then index.js. So we need to change this URL. This URL was for the localhost. And since we already deployed our backend in the previous video, we can change this URL to point at the backend that is available in Heroku. So what I'll do, I will duplicate this using Alt Shift and the bottom arrow, and then I'll comment the first line, just like that. And then when I come to Heroku, where we deployed our application, I can open the app using this button. So I'll click open app, and right here we will get the URL of our backend that is available on Heroku. So we need to copy this path. I'll use Ctrl C to copy the path, and then I'll go back to Visual Studio Code, and I need to replace HTTP localhost 5000 up to this point with that link that we copied from the browser. Now if I can minimize this one, you'll see now this is the path. So we have double slash here. I'll remove one of them. So now this is the path for our endpoint. Okay, now the second thing that we are going to do is to add a new file in our public folder, and this file is called _redirects. And the reason we are adding this file is because we are using React Router in our application, and these redirects will help us to point all the routes to index.html file. Since in our application we only have one index.html file, it's a single page application. Okay, so right here I'll add a new file, _redirects. I hit enter, and then in this file I'll include this command, a slash and then a star. So this means all paths or routes will be redirected to index, so a slash index.html, and then we will have a status code of 200. So this is all you need to do in this file. So what will happen is that when we build our application, this redirect will be available at the root of the build. So that's why we added it at the public folder. Now the last thing that you can confirm is that we are doing a git ignore of our node modules at this file .git ignore. Okay, and now at this point we can push our code to GitHub. So I'll come back to the command prompt here. Now right here we need to make sure that we have a git repository. So I run git init. In React, it is usually automatically initialized, but I deleted it to show you how to create a Git repository, Git init. So this will create an empty Git repository, but for you, you might not need to do that, okay? Now, the next step is to add all the files to the staging area. So if I perform a Git status, you'll see that we have all these files which are not yet committed, and all you need to make sure is that we don't have node modules here. And the next step is to learn git add and then a star to mean all the files. We add them to the staging area, and then after this we'll learn this command git commit to commit our changes, -m, and then double quotes, and right here I can enter a message of what we changed. In this case, I'll just say React app, enter, and now we have committed the changes. The next step, we need to link our local repository to our GitHub repository. So if I come to these instructions, you can see we have already done this, git init, git add, and also we have committed the changes. Now we can create a branch, a main branch right here. So I'll copy that, paste it here, press enter, and then I can copy this command for adding our GitHub repository to our local repository. So right here, I'll git remote add origin, and then I'll push the changes to the main branch in GitHub. So I'll copy that and then paste it here and press enter. So you might be asked to enter a password when you perform this git remote add. So make sure you enter the password and also the email if needed, so that you log into GitHub and it will allow you to do this. Now my code have been pushed to GitHub. Now I can come here and refresh this page, and we should see something different. And now here we have our files which are available in GitHub, and you can see the commit message is React app. Now that we have the application available in GitHub, we can go to Netlify, and the first step that we need to do is to log in. So if you don't have an account, you can just sign up for an account, but in my case, I'll just log into Netlify. Now I am logged in to Netlify, and I'll create a new site using Git. So new site from Git, you should see this button somewhere, even if you don't have any projects. So new site from Git, and then right here you can use Bitbucket, GitLab, or GitHub. In this case, we have used GitHub. So this will ask us to either log in or to do something like that, so that to authorize the app to GitHub. Mine was automatically logged in because I created an account in Netlify using GitHub. Now right here, I can search for that repository. I can say React. I search that, and then right here we should see React to do app, which is this one. And then did I select it? For some reason, I don't know why I was pushed back here. I'll say GitHub again. Search for React. I don't know why that happened, but let's see. And then what I want is this one. Maybe I need to click on this arrow, I don't know. Yeah, now we are here. So you'll get to the third step here, and then you'll select the branch that you want to deploy your application. In this case, we only have one branch, main branch. If you want to deploy it from another branch, you can select that branch. So at the bottom here, we have the command for building our app, which is npm learn build, and the directory that will be published is the build folder. Now right here, all you need to do is to hit deploy. Now this will take some time to deploy the site, and once it's deployed, you can also set up a custom domain name here and perform some other setup. Now as the site deploys, we can change the name of our site here using these site settings, and then right here we can change site name. So I'll change this to something simple, maybe Chaoo -react to do -app. I think that is more readable. Save, and now the name will be changed. So if I can come to this app now, we are still deploying, and I'll wait for it to complete. So the site have been deployed, and as I said before, you can set up a custom domain name if you want. But now it's accessible through this link. So I'll click the link, and you can see it's prefixed with the name of the app that we included here. And now here we are in our application. I'll try to log in. I'm not sure whether I'll remember the email and the password, but let's see. So then I enter the password, I click enter, and perfect, we are now being logged in right here, and you can see we were correctly redirected to this home page because of that redirect file that we added, and we can be able to access our Node app, which is on the CRUD. You can see that we don't have any local server running. It's only this command line that I have, no local server running. This is directly accessing our Heroku backend. I can mark this as done. I can edit new to-dos. I can delete. And when I hit F12 here, we can be able to see the console. When I come to the application here, you'll see at our local storage here, we have a JWT token, and this is the domain for the local storage. So we are successfully deploying our React app, and we successfully deployed our backend, and this marks the end of this entire series where we were creating a MERN Stack application, front-end being React and Redux, backend being Node.js, and we also did all the CRUD operation and authentication, and now we have successfully deployed the application. So thank you guys for watching the entire series. If you haven't watched the entire series, I'll make sure that I leave a link at the comment section below, and I'll see you guys in the next video.